And now we will start COPRI's event of Korea Arctic Science Research Seminar under the topic Next Generation IBRV Solving Future Arctic Issues. Good day. I am from COPRI. My name is Choi Young-jun. Despite your very busy schedules, I would like to thank distinguished guests, presenters, discussants here today, and all participants joining us online and offline. In compliance with the government and Busan City's social distancing measures, we have minimized the number of offline participants, and the seminar is live streamed online. This is the second Korea Arctic Science Research Seminar. We will be looking at the Polar Activities Promotion Act enactment, the 2050 Arctic Activities Strategy, and the Next Generation IBRV, and the top 7 issues that needs to be addressed with the new IBRV. And by using the IBRV, we will be tackling Arctic issues not only by researchers, but on some of the possible research topics, we have invited experts to give presentations, and we have simultaneous interpretation being provided. If you need interpretation, please use the receiver in front of you. Those of you joining us online, you can access the 2021 APW website to choose the language of your preference. And now we will start the second Korea Arctic Science Research Seminar. We would like to open this seminar by introducing honored guests. From the Ministry of Oceans and Fisheries, we have Director Lee Cheol-jo. Thank you very much. And now we will start the main session with an opening address by President Kang Sung-ho of COPRI. Good day. I am Kang Sung-ho, President of COPRI. Distinguished guests, despite your busy year-end schedules, I would like to thank you for being here, and Director Lee Cheol-jo of Marine Policy at the MOF has graced us with his presence, and I thank you. We are hosting the second Korea Arctic Science Research Seminar today, and to all experts from the industrial, academic, and research arenas taking time out of their busy schedules for presentations and discussions, I thank you on behalf of COPRI. The year 2021 will be known as a groundbreaking leaping board for Korea's Arctic research. In April, the Polar Activities Promotion Act, long awaited by all members of the polar community, was enacted and entered into effect in October. In June, to broaden Korea's Arctic science research in terms of region and sector, the Next Generation Icebreaking Research Vessel Building Project passed the preliminary feasibility study. In November, the MOF announced Korea's strategic direction for Arctic activities in the 2050 Arctic Activities Strategy. Korea thereby laid a new foundation for a new leap forward in scientific research in the Arctic, securing legislative and policy framework as well as infrastructure. However, global warming is rapidly changing the Arctic environment, which results in accelerated climate change originating from the Arctic. We cannot rest on our laurels under these circumstances. Now that we have established groundwork for a new leap forward, we need to contribute to resolving Arctic challenges by designing the right Arctic scientific research for this purpose. The Next Generation IBRV building project presented 7 Arctic issues to be addressed by the vessel and derived corresponding future research demand in Korea. Supported by the strong commitment from the MOF, the vessel building project was able to set sail. The second Korea Arctic Science Research Seminar As such, we'll examine response to climate change, marine ecosystem, marine resources, and exploration technologies, which were presented as key Arctic issues to be addressed by the next generation IBRV, and present future research direction and hold expert discussions. As the next generation IBRV was long awaited, not only by COPRI but also Arctic researchers in Korea, this seminar invited not only COPRI researchers but experts from the industrial, academic, and research arenas in Korea as presenters and panelists. I hope today's seminar presents how the new icebreaker to be built with 277.4 billion Korean won can be utilized to address Arctic challenges by suggesting the direction for Arctic science research and generates expected outcomes as a key platform for discussion. I would like to once again thank Director Lee Chul-jo for attending the seminar and all presenters and panelists. Thank you very much.
예, 개회사를 해주신
Thank you very much, President Kang, for your opening address. Next, I would like to invite Lee Chul-so, Director of Marine Policy Bureau at Ministry of Oceans and Fisheries, for his congratulatory remarks. 소리가
네, 안녕하십니까. 해양수산부.
Good day. I am Lee Chul-jo, Director of Marine Policy Bureau at the Ministry of Oceans and Fisheries. First of all, I would like to express my gratitude on behalf of the Ministry of Oceans and Fisheries to President Kang Song-woo of Korea Polar Research Institute and all those involved in enabling the second Korea Arctic Science Research Seminar to take place today despite the difficulties caused by COVID-19. And I would also like to extend my gratitude to all of our speakers and panelists who will be sharing their insights. Today it was a year of great significance in the polar history of Korea. It was already mentioned by President Kang. So if I may just briefly mention, finally, the Polar Activities Promotion Act was established in April of this year. And now, the Next Generation Icebreaking Research Vessel Construction Project passed the feasibility study that will help us enable research activities in high latitudes. Based on this achievements and our past performance, I believe that it is critical for us to set forth the direction for scientific research as well as policy, and that is why we've established the 2050 Arctic Activities Strategy. And the key point in this strategy is to resolve the pending issues such as marine pollution of the Arctic Circle, and also based on clear steadfast trust with the indigenous people, we want to engage in some further research as well as activities. And I believe that this is a true strategic way forward that is comparable to the prominence of Korea in the international stage. Today we will be talking about the way forward in our activities in the Arctic, and I believe that it carries significant meaning. Distinguished guests, ladies and gentlemen, with the Next Generation Research Icebreaker vessel, we believe that the quality and the quantity of our research in both the Arctic and Antarctic will be gaining significance. Arctic studies will be extended to 156 days. And the Antarctic research will be extended from 61 to 122 days. And particularly, there were areas that were not accessible with Araon. But now, the Barents Sea and the CAO will enable us to look into various research opportunities of the atmosphere, the climate, as well as the cryosphere. So this will be serving as a transformation point for Korea's Arctic studies. There are extreme abnormalities that are emerging due to the changes in the Arctic, and this is no longer something in the future. It's something that impacts us today. So we need to make sure to protect the lives of the citizens and engage in further research activity. And I do know that the Next Generation IBRV will enable all that, and I hope that we can engage in some further discussions on how to utilize this opportunity. Once again, thank you very much to all of those involved at COPRI for making today possible, and I would like to extend my gratitude to the researchers and experts for their insights. Thank you.
예,
Thank you, Director Lee, for giving us a congratulatory remarks despite your busy schedules. And now we are ready for the keynote presentation on a voyage of new horizons on board the Korea's next generation IBRV. We would like to invite Director Seo Won-sang of the Department of Strategic Planning of COPRI.
네, 안녕하십니까.
Hello, I am Seo Won-sang, Director of the Department of Strategic Planning at COPRI. I was in charge of the planning part of this new project, and I have come to present this topic, and the fact in itself is a great honor for me. I was on this project for 3 years, but I persuaded the government to pass this project through the preliminary feasibility studies, which took 7 years total. The first reason that we were able to pass this project is the MOF clearly demonstrated its ability and commitment to pass through this project, and therefore polar research related experts and institutions across the country shared the need to develop this project and demonstrated the need for this project very clearly, and I would like to thank you for your support. The topic is the voyage of new horizons on board Korea's next generation research icebreaker. Quite progressive, and I think that regarding this IBRV, this is the very first time that we are disclosing this official project to the public. So I would like to share what kind of process we took for the project to be passed and what we dream of for the future. And I would like to share this presentation with Vice President of COPRI, Shin Hyung-chul. Next slide. Can I control the slides? Okay. So this is the table of contents, and let me go through my slides one by one. So in 2013, as you know, we became the observer to the Arctic Council. And with that, there had been a surge in interest towards the Arctic, and in particular through climate change, as sea ice in the Arctic drastically was reduced. Some said that this was a crisis of climate change, or others said that they focused on what the impact would be on Korea, and while others focused on the possible increase in economic value, fisheries, natural resources that will be now accessible with the less ice extent and also the opening up of the Arctic sea routes. But what is common is that whatever the opportunities or challenges presented, we have to go to the Arctic ourselves and examine, research, and analyze the Arctic. There was no argument on this point. So we must go to the Arctic, but we already had an ice-breaking research vessel to do this with, and that was the Araon. But the problem with Araon was that Araon was the sole ice-breaking research that had to be injected into both Antarctica and Arctic, going through both poles, which is a very long way. And if you look at the chart, the travel voyage was only about 85 days, or the research expedition day was about 85 days, but the travel days was 150 days. So this was very inefficient, but inevitable. Since 2013, if you can see the map on the right, I think that January 2018 is the first of the map. The green indicates, the line indicates the ice thickness of 1 meters, blue 1.5 meters, and 2 by 2 meters of ice that can be broken by the vessels. And the white line is the BEEZ of coastal states. So inside the white line is the area open up for all countries, including Korea, to freely conduct research, and that is the CAO. So you see the changes in the map, but depending on the thickness of ice, there is great changes and difference. Because Araon in the Arctic Ocean can only operate for 2 months in the summer, where there is hardly any ice in the Arctic. So towards the top of the map, Chukchi, East Siberian Sea area, the Pacific side of the Arctic was the only area covered by Araon. So we wanted to cover the entire Arctic and the CAO over a long period of time with a new IBRV. And the topic of this project was to build the next generation IBRV that can operate in a green manner in the CAO. We have 4 boxes on the top that indicate the usage of this vessel. First is to respond to climate change and extreme weather on the Korean Peninsula. Second, to conserve and secure new CAO fisheries resources as an opportunity. And in using the IBRV, we are going to share the vessel with nationwide to revitalize polar research. And finally, we wanted to conduct international joint research to boost competitiveness of Korea's Arctic research. And also, in terms of Arctic governance, we wanted to boost Korea's influence. That was the major goal behind the project. And the IBRV is, compared to Araon, we'll have a new moon pool that was not on Araon. So that is on the bottom right. Crown Prince Haakon, at the bottom of the ship, has a hole. So through this moon pool, any drilling devices or exploration devices can be lowered and pulled up very safely. So Araon, the case of Araon, does not have moon pool, so we have to take the device out of the ship off the board of the deck, which is quite dangerous. And another new idea is that there will be detachable modular equipment in both Antarctic and the Arctic. We will have to cover more areas and more research. And there will be a number of different research demands to be fulfilled by this new IBRV. By modularizing equipments that are made detachable from the vessel, that would be very easy for us to support different demands. And comparing Araon with the new IBRV, we have a stronger ice-breaking capability and durability against cold conditions. Detachable and modular equipment will be added. These are the main improvements. And the GT is almost twice that of Araon, about 15,000 tons. It can sail 75 days without supply. Out of that, 25 days will be using LNG, and the 50 days low sulfur fuel, so it will have a dual fuel system. Can you see the picture at the bottom? If you take a closer look, Araon on the left has a crane in front of the ship where the container boxes will be loaded. But if you look at the new IBRV, the cabins are moved up front, and at the back there will be modularized container boxes loaded here. With all the equipment will be loaded here. So research equipment will all be loaded in one place for better efficiency. Then 5 years from now, the new IBRV, compared to other IBRVs overseas, how does it play? Well, in 2019, China, and in 2020, UK, 2021, Australia built a new ice-breaking research vessel. And Germany and Japan are building new ones too. In terms of ice-breaking capability, Korea's new IBRV does not fall short. But here's one question for you. There is a new vessel that we know, but is not included here. That's the 2018 Norwegian Crown Prince Stockholm. But its ice breaking capability is about 1 meter with 10,900 GT. But compared to Arctic coastal states, why do the mid-latitude countries build a larger and better capability vessels? We did have some questions about this and challenges during the preliminary feasibility studies. But for Arctic states, their EEZs are in the Arctic Ocean. And they can look at the sea ice conditions and very flexibly adjust their research schedule. But countries in the mid-latitude countries, once we go to the Arctic, we cannot come back and to adjust our schedules. We have to push through with our schedules anyhow. But the sea ice conditions continue to change constantly. So under these circumstances, we inevitably need a larger and better ship with a better ice-breaking capacity. And what would change with the new IBRV? If you look at the top row, this indicates the Araon trajectory from July 2030 to November 2030. That the ones indicated in the red are areas where Araon can cover, and in the bottom row in purple you see from the same period, in the same time period, the areas that the new IBRV can cover. With Araon, as you can see, during the summer area, we can conduct certain research. However, we needed a next generation IBRV because of the desperate need from scientists in Korea, because Araon can only cover the Arctic CAO in the summer when there is no ice. But the scientists wanted to see the process of melting and thickening ice, and the changes of sea ice and how that impacts the circulation of the air and the ocean, and also some of the microorganisms that are frozen in the water and then released when the water melts, ice melts, what kind of impact that has on the air, and how the sea ice changes in the Arctic impacts the Korean Peninsula. So to examine all this, scientists needed to go to the Arctic Ocean, not after the ice has already melted, but follow the ice as it changes to see the field for themselves. And Araon could not support this demand, and therefore we needed a IBRV, a new IBRV. And once we have the vessel built, not only the ice-breaking capabilities, but throughout the year for multi-seasonal research, we can conduct different researches. Right now, Arctic research days will be expanding from 35 to 156 days, and for Antarctic, 50 to 121 days. And the sea area covered will be much enlarged. Then, once we have the new vessel built, what will be the tasks to be tackled? As for details, I think that you will be hearing from our presenters and discussants. But while planning out the project, I think we can summarize the big tasks into opportunities and risks. Until 2050, we will be able to build a proprietary predictive model on Arctic sea melting and be able to predict the weather changes on the Korean Peninsula and elevate the level to the level of advanced nations. And that is the key 2050 goal. And we collected and sorted out all the demand and targets accordingly. This is a very exciting photo. Yesterday at a different seminar, you saw a similar picture. This is from the Mosaic project. Polarstern is lighted up against the polar night to support the researchers' work. Korea wanted to be a part of Mosaic and were invited, but because of the Araon schedule And with Araon's icebreaking capabilities, we could not take a central part. It was too risky for Korea. And so only the remote exploration team was a part of the Mosaic project. And it was very unfortunate that we were not able to be a part of Mosaic and IODP on the field in the Arctic. But that dream of taking leadership and initiative in large international projects, we were able to build IBRV. And from the very planning stage, we prepared the project as an open platform. Internally, we have the Joint Usage Committee that pulls together the government, academia, and industry. And externally, Mosaic or SAS or other large-scale international joint projects could be led by IBRV and with Korea at the center, and that is the main vision and goal and dream. And in terms of observation systems, there is a number of different systems that can be integrated. In Korea, not only vessels, but there are various types of observation infrastructures, on land and offshore. And there are fixed on-land observation facilities that is very stable, but it only covers a narrow scope and cannot conjunct the data with ocean data. And we conduct remote exploration that can cover a number of different areas. But when there is cloud that blocks the view, there can be blind spots, and the observation can be hindered. And there is no one facility dedicated to the Arctic. But once IBRV goes into the CAO and conducts field studies, it can combine both data onshore and from the satellite and verify and validate the data. Then we will be able to have a comprehensive observation system to acquire accurate data, which will contribute greatly to the development of Arctic research. Last but not least, these are some of the things that we need to think of. So it is basically a summary of what I have been saying. The IBRV is not just for the Arctic research, but the development of all polar research in Korea. And just because we have a new vessel, Araon will not be forgotten. Each will have its own mission and role to conduct best research. And what we must be resolute on is that not only for researchers conducting Arctic research, but all the Korean people who will be benefiting from research altogether own IBRV, and we must cherish IBRV. And last but not least, to international experts who gave us much support, I wanted to greet these six persons. I think it was December 1980s, 90s. We had an international conference, and we had those persons from all these different nations coming in Korea to share their ideas about the IBRV project. From Norway, we had Dr. Kim Holman, who said that Norway had built up the vessel in 2018, but like 9 p.m. December 31st, 1998 was when all these projects really first started. So he cheered us on to pull through with the project. And compared to Norway, I think that Korea really pushed ahead very quickly. Concluding my presentation, once again, I would like to thank you all for your great support. Thank you.
네, 오늘 주제
Yes, that was a fuller, you gave us a fuller picture of the beginning, expectations, conclusion of the new project for our future discussions. This seminar is very significant because number one, from MOF, we are joined by the MOF, and not only COPRI experts, but IBRV joint utilization and openness has been reflected through other experts from different sectors. So to commemorate this moment, we would like to proceed with a group photo. I would like to ask Director Seo and Director Lee at the front row, and the presenters at the second, discussants at the second row, and presenters next to our honored guests. Please come forward for the photo op.
있습니다. 고, 네. 다 같이 찍기 위해서 패널에 계신
I would like to kindly ask our panelists as well to join us on stage for the photo op.
예, 감사합니다. 그러면
Thank you very much. And while we prepare the stage, we will take a short break. And at about 10:05, we will start with the presentation and discussions.
네. 예, 그럼 지금부터 본격적으로
Let us now move on to the presentations. We will be looking into the next generation IBRV, solving future Arctic issues, and we will be talking about what kind of projects may be possible going forward. So we will be seeking some suggestions from our speakers, and I would like to kindly ask our speakers to come up onto the stage for their presentations. So first, we would like to invite our next speaker who will be talking about what we can get from the Arctic, the weather and the climate forecasting perspective. We will have Professor Lee Myung-in from UNIS to give us a presentation. Hello everyone, I am Lee Myung-in from UNIS. Thank you very much for inviting me to this very important and meaningful session. I have 15 minutes. However, this is a very challenging topic, but I wanted to give you a preview as to what we can get from weather and climate forecasting in the Arctic. I'm sure that you are all very well aware that there is a close relationship between the mid-latitudes and the Arctic. It was also mentioned by Mr. Sa just before. So this is the Arctic amplification. You can see that for the past 40 years, it indicates the temperature highs. I think that the animation is not working right now, but as you're very well aware, in the high latitudes, in the continents, there was a great increase in temperature. And if you refer to the Arctic areas, Arctic regions, it's about 2 degrees, and closer to the pole, 4 degrees. Of increase in temperature. So these are some information from the satellite. And here by latitude, you can see that in the Antarctic region, we're seeing a decrease in temperature. However, in the Arctic regions of the higher latitudes, we're seeing a great increase in temperature. This implies that there are many climate fluctuations due to the changes in the Arctic. There are 4 panels on the left, and you can see how the temperature fluctuates depending on the seasons. This is quite interesting because if you look at, the latitude is the y-axis, and there are some clear increases in temperature in parts of Arctic, particularly near the ground areas. So once again, the surface, the changes in the sea surface and the Arctic Ocean fluctuations are leading to these climate fluctuations. And irrespective of the seasons, you can see that we're seeing these major variations. And in addition to that, ever since the 2000s, there is this steep deviation of average temperature. You see the red and black lines. In the red line indicates the higher latitudes, including the Arctic region, and the black are the regions of the lower altitudes. But once again, you can see here that there's an exacerbation of global warming in the Arctic. So in the surface sea, I've mentioned that there are some major changes in the Arctic region, and this indicates the sea ice extent in the Arctic. Ever since the 2000s, there was a acceleration of decrease in sea ice loss, or decrease in sea ice. So these Arctic climate variations and fluctuations are leading to a great loss in sea ice, and this of course has a climatic impact on the world. If you look at the picture on the top left, this is on the trending of the temperatures in the winter season in the Arctic. I've mentioned that there is a great increase in temperature in the Arctic. However, if you look at the Siberian continent and the Korean peninsula, we are seeing a decrease in temperature. Recently, we've been seeing a weakening of this trend. However, what's for sure is that during the winter season, there are higher frequencies of cold spells that has been related to the changes of climate in the Arctic. And according to recent research, if you look at this picture on the bottom right, it indicates that the temperature changes between low sea ice and high sea ice years. So here, the mid-latitudes, including Korea, is seeing a decrease in temperature while the temperature in the Arctic is increasing. In other words, this is a warm Arctic cold Eurasian pattern, which has a direct relationship with the sea ice loss. So in terms of teleconnection, we can see that these cold temperature deviations or cold waves have a direct relationship. This is from Professor PM Kim's research. Sea ice loss, if it takes place in November and December, what happens is there will be specific waves that would be sent upwards, leading to a polar pipe anomaly that leads to increased temperatures. And then the cold currents will warm up, leading to a weakening of the polar vortex. And if that does happen, cold spells will emerge in the mid-latitudes. So there is this dynamic relationship based on his research. During the winter season, we think about the cold spells when we think about the sea ice, and many do say that it's coming from the Arctic. But there's also a lot of research on the summer season. So if you look at the mid-latitude heat waves in the northern hemisphere, the changes in the Arctic sea ice is impacting the temperature, especially the surface air temperature. This indicates that temperatures rise with the sea ice decline, leading to a greater number of heat wave events. So especially in the winter time, we've seen much research on teleconnection. However, in the summertime as well, we're seeing the number of heat wave events increasing, leading to great damage and losses. So we are seeing a lot of recent research that is focusing on the summertime fluctuations. It's important to understand have a scientific understanding of the Arctic and also the impact it has on weather conditions. And of course, it will help us raise the predictability of our forecasts. The IBRV was also about understanding and minimizing the impact of natural and weather catastrophes, as mentioned by the previous presentation. That's why Arctic observations are key. And in line with that, what I would like to say is that if we look at the environment in Korea in the summer season, geologically speaking, we are in the middle of the high and mid latitudes. And not only that, we're also sandwiched between the continent and the ocean boundaries. That's why we are impacted by these fluctuations. This was an interview with KBS, and they put together a slide for us. So if you look at the summer season in the tropical seas, the climate fluctuations are leading to heat waves as well as a long monsoon season, which is quite abnormal. Not only that, in the Indian Ocean, the convection has led to increased temperatures in the Arctic. So that's why we need to have a more refined observation of the Arctic to understand these teleconnection patterns, leading to better predictability in weather forecast. And I know that you've heard about the Arctic Oscillation many times, but if I may just briefly mention, it means that regularly the air in the Arctic oscillates, leading to a fluctuation in the jet stream as well as temperatures. In Korea, depending on the changes in the pressure system, the positioning of the jet stream will change and alternate. And when we do see a strengthened AO, Arctic oscillation, during the summer season, there will be stagnant pressure systems in the upper layer of the atmosphere, leading to heat waves in the mid-latitudes of the Korean Peninsula. So based on the Arctic oscillation, there are changes to the climate conditions. If you look at the 1998 to 2000s in the Northern Hemisphere, that's what you see on the left, and what you see on the right are the changes after the year 2000s. So if we see that the Arctic oscillation is a positive, you can see that the Korean Peninsula is indicated in red. So the summer temperatures can increase with that. And if you look at the recent numbers, there are some dots which indicate that there is statistical significance between the Arctic oscillation as well as the climate variations. And we believe that the effect has amplified with the changes in the Arctic sea ice. Moving on to the heat wave events on the Korean Peninsula, there are specific indicators. Of course, I cannot go into specifics, but here it indicates how these heat wave events have emerged. So CGT is the mid-latitude waves, and PJ is the tropical waves, and the AO is Arctic oscillation. And you can see that Arctic oscillation is quite evident. And that is why we need to have a better understanding of the Arctic. The Barents-Karat Sea Arctic sea ice was observed to understand how it impacts the Eurasian region. And you can see that here we're seeing anomalies in Arctic sea ice. In other words, a great decline in sea ice. And there are blocking patterns that are emerging on the Korean Peninsula, leading to more heat wave events. So this is a literature that was published. So what we can say that it's important to predict Arctic sea decline because that impacts the weather conditions in the mid-latitudes. So then, how well are we forecasting sea ice extent? If we look at the climate forecasting, the 2-month forecast is not that accurate because there are many uncertainties in the numerical models. However, recently with the advent of technology, we have actually utilized the Cryosat, a satellite that helps us observe the sea ice extent to 5 months. And the sea ice thickness is also quite important in terms of our predictability. But if you look at the correlation coefficient, it's still very low. I believe that this is due to the fact that the ice thickness is not as clear to forecast or to observe with the satellites. So Lawrence looked into how we can raise the predictability performance of our observations in the Arctic. The ECMWF, the European Center for Medium Range Weather Forecast, is very well known for its predictability. And you can see that there are both the green and blue lines. This indicates the site observations and also the microwave observations from the satellite. So in order to engage in better predictability in the 11 observations, we need to make sure that we have clear convection control as well as microwave observations from the satellite. And if we divide that up by season, if you compare with the winter and the summer season, in the summer season, you see that the MW is the microwave from the satellites, and the CONV is what's done on the ground or on the site. Of course, both are important. However, in the summer season, we are seeing better accuracy in the microwaves from the satellites. However, in the winter season, you can see that compared to the satellite observations, the direct site observations seem to be at the core. It's probably because of the limitations of the satellite observations. There are more uncertainties out there during the winter season. That's why we have to go on site to observe. And we also see radio sonde, aircraft, as well as buoy observations that can be included. So then, many people do say that our weather forecast has very sluggish performance, especially also if we look at the seasonal forecasts, and there may be many challenges due to there are many excuses made that the numerical models lack accuracy, for instance. However, you can see that it's very important to have key input data and accurate input data. However, for the Arctic, we do not have those robust data in place for the initial input. If you look at the number of data points, observation data points in the Arctic with higher than 60 degrees latitude, we have about 1.5 million observation data that's being used. But around the world, if you look at global data, we utilize about 10 million. And you can see that compared to the global data points and the Arctic data numbers, we are lacking in Arctic. So ex post, we do say that forecasting is important, understanding the connection between the Arctic and the mid-latitudes. However, you can see that ex post research is being done. However, in the case of our ex ante or our forecasting, we need to see and have some sound data input in the initial phases in order to raise the predictability of the observation or the accuracy of the observations. If you look into the simulations of the numerical models, this is from Canada. So this was about how we can strengthen the Arctic observation data, in other words, the site observation data, for instance. And when that does happen, we were able to see that predictability, not only for the Arctic, but for the mid-latitudes, tend to get better. So you can see that for the winter and the summer seasons, you can see that there is better predictability by raising the accuracy of Arctic observation data. We're also engaging in seasonality forecasting, for instance, whether it will be cold, warm in the summer season, how many heat waves we will be witnessing, and we want to forecast at least a couple of months beforehand. So resetting in the data is very important, and what we are focusing on recently is the following. It's true that there wasn't a lot of research on this topic because the initial data points for the oceans and sea ice is critical, and we've actually utilized 3 points to do that. If you look at this graph A on the top, you can see that this is when we do not reset the data on ocean and sea ice. So this is the predictability performance without the reset. So for the continents, the areas that are red means that we have raised or better predictability. So there are some limitations that you can see here in this color coding map. So this is the limitations of the existing technology. However, if you look at the graph B, this is when we actually utilize satellite data as input initially. And you can see that if we do have a balanced initial data input, predictability in the mid and high latitudes improved. So compared to this graph A, if we go to graph C, for instance, the initial data input of the ocean and sea ice will have a great impact on predicting the weather conditions by the seasons. So let me now move on to the possible future with the IBRV. Dr. Kim Jo-ung's research paper was used for this part of the presentation. So in the winter season of more than 70 degrees latitude in the Arctic seasons, or Arctic regions, if we engage in the observations, we will be able to predict any cold spells, fine dust, or yellow dust phenomenon on the mid-latitude. So it indicates that by utilizing the IBRV, bettering the accuracy of the observations in the Arctic will help us also improve our forecast in the mid-latitudes. This was the ECMWF's AO 2018 campaign. So here, the autumn, as it gets closer to the Arctic, was able to improve its accuracy in its observations. Recently, there is heightened awareness on the fact that these atmospheric fluctuations have a correlation with the Arctic. You can see that the ice sea concentration is greatly deviating, and in the Chuk Sea, you can see that all of these variations and fluctuations are impacting the mid-latitudes. This slide was also an animation, but unfortunately we cannot see it. But what I want to say is the Arctic region will change immensely. We do predict that there will be even more fluctuations, but there was just one slide before this which indicated the PM 2.5. So when we do observe these fine dust, we are seeing high concentrations in the Arctic region, meaning that due to the global warming in the high latitudes, it will lead to heat waves as well as forest fires in the mid-latitudes, leading to more fine dust, and of course, in turn, resulting in further Arctic sea ice decline. So along with the climatic impacts from the Arctic sea ice decline, it will also lead to some future climatic changes in the conditions of the mid-latitudes going into this vicious cycle. So including the IBRV and other observation capabilities, it's important to better our scientific understanding and enhance our predictability. And once we do that, I believe that we can find a way to prepare for any catastrophes. Thank you very much.
네, 북극발 기후 변화.
So that was on the climate change, results from the changes in climate in the Arctic. Moving on.
The next presentation is on the impact of environmental pollution on marine ecosystems in the Arctic Ocean and future research ideas. We have Professor Seung-kyu Kim from International University. Hello, I am Kim Seung-kyu from International University, Oceanography Department. I would like to present the impact of environmental pollution on marine ecosystems in the Arctic Ocean and future research areas. This is the order of my presentation. Arctic Ocean is the dead end of environmental pollutants. I will show you an overview of how environmental pollutants move to the Arctic Ocean, the rapid transition of Arctic Ocean environment, the future impact, and the research we must conduct accordingly, and the future tasks and prospects. As you are well aware, the surface current ends at the Arctic, and so through these currents, pollutants could enter into the Arctic. But the flow is from the Pacific and the Arctic, but from the those that come through the Atlantic, they immediately travel outside of the Arctic. But in the case of the currents from the Pacific, it is trapped inside the Arctic. So the pollutants from the Pacific impacts the entire Arctic circumpolar region. Second point, the pollutants come through to the Arctic through the air. Depending on the chemical properties, such as high volatile pollutants, can come through the air to the Arctic, but these with low volatility have a grasshopping effect that repeatedly are distilled, evaporated, and then deposited. So this very complex water and air currents are combined to bring pollutants to the Arctic, so the source of the pollutants are very difficult to trace. Anyhow, there are so many different environmental pollutants regulated across the globe, but they arrive at the Arctic and are accumulated according to a number of different studies. For instance, if you look at the blood lead level of those living in the Arctic, the share, more than 50% of the population have a higher than average level. So this indicates that these pollutants are indeed being accumulated in the Arctic. And as the earlier presenter said, through the air, these pollutants flow into the Arctic region. There are volatile organic pollutants that travel through to the western end of the Arctic, and you can see that compared to the mid-latitude level, the level of contamination can be even higher than in the Arctic. So such accumulation through the food webs in the Arctic could be bioaccumulated and spread. I said earlier that the pollutants reach the Arctic through the ocean or the air. And let me share with you why this is important using PFAA. From 20 years ago, PFAAs and PFCAs have been classified as risk materials, and it consists of FTOH and the PFCA, highly soluble. The precursors are highly volatile, and as you can see in the graph, mainly they are highly concentrated in advanced nations and cities. But the problem is that these precursors in low nitrogen air can convert the photo degradation to PFCA. And if you look at the concentration of PFCA concentration is high in the Arctic and low contaminated areas. So this means that through the air, environmental pollutants can be accumulated to a high level in the Arctic, and on the other hand, mid-latitude altitude levels, if we ban the release of these materials in the mid-altitude level, then we can see an immediate decline in the concentration of these materials in the Arctic. So when we conduct a tested the level of blood in Arctic seals, once these pollutants were regulated in the mid-altitude area, we can see an immediate drop in the blood level of Arctic seals. And so compared to the volume produced, in terms of volumes produced, PFCA volume is much higher than precursors. So it is too early to say that peak has been reached. So in going forward, about 30 to 50 years, we will have to see that the concentration level may continue to rise for the time being in the Arctic, because there's a time delay between the precursor and the PFCA. And as the earlier speaker said, the Arctic Circle is undergoing a massive change. It takes about 3.4% of total, 4.3% of total ocean area and 1.4% of total ocean volume. There are 8 Arctic Council member states, and there are a number of different observers participating. As you heard earlier, the sea ice is declining drastically in the Arctic, and there is great change. In particular, in the eastern Siberia, the West Arctic Sea, the change is even more dramatic. Because of climate change and global warming, anthropogenic activities will grow in the Arctic, and therefore human activities will spread into the Arctic. This slide indicates that by 2032, almost all the regions in the Arctic will be developed or used in one way or another. And this means that pollutants flowing into the Arctic will be multi-layered, concentrated, and diversified in the Arctic with different sources. Another change is that there are about 6 big rivers in the Arctic region, and pollutants, the fresh water that is discharged, takes up 10% of total freshwater discharged globally. So I said that the ocean volume of Arctic Ocean is only 1.4% of total, but 10% of freshwater flows into the Arctic Ocean, meaning that because of global warming and climate change, more and more freshwater is discharged into the Arctic Ocean, and this can incur changes in the Arctic Ocean and more pollutants flowing into the Arctic. Another point is that the declining sea ice extent will lead to the development of NSR, and this will boost ship traffic. According to recent studies, the number of vessels going through the Arctic has been growing at 20% level each year, and this will continue to grow, meaning that pollutants from vessels could reach the Arctic in a massive manner, and beyond the existing regulations on ships, any ships that use the NSR or the Arctic sea routes, additional agreements or regulations will be raised. In the Arctic region, the declining sea ice extent would impact the ocean, the air, and the interaction between ocean and air, leading to higher volume of sea ice and changes in the flux. So the pollutants will be traveling to the ocean, the Arctic Ocean, in different channels and in different volumes. So this slide shows you a snapshot of that change. From the onshore, because of increased human activities, there will be diversified sources of pollutants that can further travel into the Arctic through the ocean or through the air. Increased precipitation means that any pollutants that enter the air could lead to a higher flux and accumulation in the Arctic, and in the ocean through the ocean currents, a long distance travel of the pollutants will also grow, and through the flux, more pollutants will be accumulated. And as multi-year ice changes to a one-year ice, primary production will grow along with the biological pump. So overall, in the Arctic region, pollutant dynamics will change fundamentally. So not only the dynamics, but the ecosystem will change as well. As with the reducing sea ice, of course, the subpolar biodiversity will change. Habitats, range, effective abundance, prey accessibility, seasonality, physiology of all these species will change. This is POP, mid to long-term monitoring results. Yes, POP has been on a downward trend ever since the regulations, but some of the PCB, for example, has been actually growing after a decline. We were not sure whether this is because of a climate change or because of the ocean current increase inflow of ocean currents into the Arctic Ocean. We need further studies. And if you look at the polar bear, which is an interesting topic, decline in sea ice means less prey and less body conditions. However, there is a higher concentration of POP in the lipophilic POPs in the bodies of the polar bears, and this may lead to more abundance of polar bears. I mentioned earlier that there is multi-year ice and one-year ice, which affects primary production, which in turn affects the food chain as a whole. Multi-year ice being changed and replaced with first-year ice will give impact on the food web and food chain, and any contaminants that flow into the Arctic may have different impact. So as a future research area, I would like to raise the issue of microplastics, because all the pollutants I've been mentioning are at the molecular level, but plastics are at a particle level. Plastics are made by refining petroleum, and as of 2014, 6% of petroleum production, and in 2015, 20% led to the production of plastics. However, in producing and burning plastics, a massive amount of GHG is emitted. By 2050, 1.5 degrees Celsius is the temperature rise limit that we are going for. And in order to achieve that, CO2 emission must be limited to a maximum of 570 billion tons. But about 10 to 13% of that comes from burning plastics and producing plastics. So we cannot think of climate change without plastics. And plastics also include a number of different cocktails of chemicals. So when microplastics move to the Arctic and are accumulated, then they will be a vehicle of carrying pollutants. And a large amount of plastics can directly kill marine organisms, and smaller microplastics can enter into and penetrate into the entire food web. Microplastics move to the Arctic through the ocean and the air and can impact the entire ecosystem throughout the Arctic region. As I said earlier, our research team, along with COPRI using Araon, found that even the amount trapped inside the sea ice is 280 kilotons. And such a high amount of microplastics are already accumulated in the Arctic, mostly probably travel through the ocean currents. Going forward, microplastics are very important for the Arctic because multi-year ice is being replaced with first-year ice with higher primary production and higher biological pump. Microplastics will be intervening into this process, combining with organics, either enhancing or hindering the enhancement. So this will impact the overall carbon circulation. And this confusion caused by microplastics need to be looked into by Araon and also IBRV. And in these areas, these will be the top priority areas for our future research. And also with the decline in sea ice, this will lead to some of the barriers that block the movement of floating materials. So near the ice breaker vessels, we will have multiple and mounting layers of contaminants in the Arctic Ocean, which requires further research. And microplastics include not only molecular pollutants, but they will change the entire ecosystem. It has been used for the past 70 years and continue to flow into our ocean. And most of the microplastics in the Arctic Ocean come through the currents. And even if we stop all the production and use of plastics altogether, even right now, going forward 30 to 50 years into the Arctic Ocean, the amount that flows in will continue to grow. So that means we need to take action quickly. So to summarize, all the pollutants, toxic materials can reach the Arctic Ocean and accumulate there. Geophysical changes, increase in human activity, changes in habitat can be occurring. Accumulation, circulation patterns can change, but we know very little. So because there will be altering the sources, pathways, and distribution and fate of pollutants, we will have to use the next generation IBRV so that Korea can take leadership in relevant research. Thank you very much.
네, 감사.
Thank you very much for a very broad changes in the ecosystem, marine ecosystem in the Arctic, and your future research areas.
중앙 북
Let us now move on to the next presentation on Korea's science strategy for the conservation and management of fish in the Central Arctic Ocean. We would like to invite Dr. Na Young-sur from KOPRI for his presentation. Hello, everyone. I am Na Young-sur, Senior Research Fellow at KOPRI. I want to mention that from the very first voyage of Aragón in 2010, ever since its construction in 2009, I've been engaged in research in fish resources as well as the distribution of such fish stock. So I would like to talk about how we can conserve and manage fish resources in the Central Arctic Ocean with the perspective of a scientist. So let me talk about some of the environmental issues and changes and how it impacts fish resources in the Central Arctic Ocean, the CAO. And I would like to briefly talk about CAUFA, the Agreement to Prevent Unregulated High Seas Fisheries in the CAO, and on the importance of the role of scientific research. And the third part of my presentation will be on Korea's research capabilities in the Central Arctic Ocean. And last but not least, I would like to talk about what kind of scientific response will be desirable for the conservation and management of fish resources in the CAO. We're seeing warming of the Arctic Ocean, and I think that we can say that it's getting not just warm but hot. The surface sea temperature is increasing. We're seeing the sea ice loss, and that has led to many extreme weather anomalies around the world. So the environmental changes of the Arctic is not something that stays in the Arctic. It is becoming a global challenge. And these environmental changes in the Arctic has, of course, led to disruptions in the ecosystem and the ecology. And naturally, for the fish stock, the fish resources, it is impacted as well. With the decline in sea ice, what happens is there are specific fish stock that uses the sea ice as their habitats, but as you can see in the case of the Arctic cod, it will disrupt their habitats. With the changes in the temperature, there will be a change in their habitats. There will be a major impact on their habitats due to these changes in the environment. And if we look at the residents of the Arctic, they also say that they are witnessing many changes because there are specific fish that are caught that were never seen before. So at the end of the day, these environmental changes are impacting the activities of human beings that reside in these regions. The map you see here is currently color-coded, and the areas that are colored are the major fishing grounds of the Arctic region. It's not just the Arctic Ocean, but it also includes the subarctic ocean as well. And if you look at these fishing grounds, there are about 240 species that currently live in these waters. And the overall harvest volume is around 42% of the total catch around the world. Of course, the catch is not as significant in the Arctic Ocean right now, but with the global warming, we're seeing the subarctic oceans where the fish that live in these waters move northward, which means that the Arctic Ocean will become a new fishing ground going forward with more species making inroads. So as the Arctic Ocean is opening more opportunities for fishing, there were concerns that there may be the probability of reckless fishing. So that is why the CAUFA has been signed. For scientific researchers, I think CAUFA carries significant meaning. The reason why I say that is because with the signing of this agreement, fishing is prohibited at the Central Arctic Ocean, meaning that the biological resources or fish resources can be monitored, and we can also engage in scientific research to conserve, preserve, and manage these resources. If you look at the CAUFA agreement, if you look at the text, it indicates the importance of scientific research. You see the preamble and Article 4 of CAUFA, and it indicates that the scientific knowledge on these biological resources is something that needs to be taken advantage of. And also, it indicates that we need to promote cooperation in scientific activities aimed at increasing knowledge about the biological resources and ecosystem of the CAO. And within 2 years of the ratification, joint scientific research programs have to be put together. So with regard to CAUFA, you can see that there is stress put on scientific research. So then, what kind of research capabilities does Korea possess? From 2010, we've been engaging in research on the Arctic with our Araon icebreaker. It's true that we weren't focused on the fishing resource per se. It was more on the food web and on the impact it receives from any environmental changes in the Arctic. But for more than 10 years, we've been accumulating data on the changes of the biological resources, and we've been accumulating our research know-how in the process. Going forward, we believe that it will be important to research the Korea Arctic ocean warming and its response of the ecosystem. So there's this new research project that will be launched. What we do here is utilize the existing data to understand how Arctic Ocean warming is leading to specific responses of the ecosystem. So we want to put together a system to understand the relationship between the two of warming and the response of the ecosystem, and also forecast what's in store for us in the future. So that will be the topic for this K-Aware project. There are multiple topics that we will be covering, but particularly if you look at the module on the fishing resources and the ecosystem, there are these 3 important sub-research topics. First is on the sea ice and oceans ecosystem. As you know, the Arctic Circle is interesting in that we both have the sea ice as well as the oceans together, so it's important to understand the ecosystem there on the structure and the functionalities, and also understand the spatio-temporal distribution of the biological and fish resources, in addition to technologies to acquire these resources. Not only that, simulation on the mid to long-term forecasts of these biological and fish resources will be key to understand the ecosystem of the sea ice and the oceans. So with regard to fish resources in the Arctic Ocean, you may wonder the distribution of such resources, but unfortunately we don't have data. In the Mosaic program, there were many attempts made to understand what kind of fish species live there and also on the distribution of such species. So it's still in the initial phases of understanding the distribution of the species. But for our research, what we wanted to do was utilize various observation systems and equipment to research the species distribution. So this is something that we will be doing in the future, but there are both pros and cons of these observation facilities, and if we can complement that, I think that we can engage in some quality research on the distribution of fish resources. To give you some more information, the most traditional way would be utilizing the net, where we will be sampling the resources, but in the case of the Arahon, we're not a trawl. So what we need is an optimized mid-water trawl to complement the functions of Arahon. But of course, with the second, next generation IBRV, I do believe that we will be seeing a better environment to carry out research. And we also have the underwater camera and the sound system, the biological sound system. And by utilizing the eDNA system, we can also acquire some more information on the species. So we want to utilize this system as well. In 2021, during the Arctic voyage of Arahon, we gathered some information and also did some sampling. You can see the researchers on Arahon, and on the right, you can see some of the pictures of the biological resources that were sampled in the process. If you look at the picture on the left, there you can see these long rods. So these are the so-called hand nets or landing nets. Below the sea ice, we see Arctic cods. So if you break the sea ice, you can see that the fish will come up. So what the researchers are doing are using these nets to scoop up the fish after breaking the sea ice. And on the right, you see the CAO, and the area that's indicated in red is where we've actually sampled these fish. You can see the crabs, the pollock, the cods. Well, in terms of the specific species, we're currently classifying them right now, but in CAO, you can see that there are many species living in the CAO. And another interesting fact that we've identified was that in the latitude of 76 degrees, 700 meters below water in the deep seas, we were able to film what it's like with this underwater camera. So you can see that there were specific species of the flatfish. This is the flatfish that you see here. And you can see shrimps still living in the deep waters of CAO, as well as the Orcas gillies. So this is the current state, and we don't know what will happen in the future. As mentioned, we will have to wait and see whether it will become new and a more comprehensive fishing grounds with the increase in temperature. What we do is we utilize our own scientific data, but we also establish a one-stop portal where anybody can have access to the scientific data and to understand the situation in the CAO. So what we want to do is, going forward, if we can acquire any fishing data, any fish resource data, we will update this portal to make sure that quality information can be accessible for all. So we want to curate this data to make sure that everybody can utilize this data. So bringing this all together, recently we are seeing a greater say from the non-Arctic states. That is why our scientific contributions will be key going forward. What we want to do is, based on our quality infrastructure, we do have our IBRV Arahon, we also have our Tasan station in the Arctic. So what we want to do is utilize this infrastructure and also make use of the accumulated data and share that. And as mentioned, we have the portal and the database to make it accessible for other researchers. So when we put together our future strategy in scientific research, I think since we are at a point in time with greater participation of non-Arctic states, I think that we need to also expand the domain of our research in CAO. And with the next generation IBRV, I think that we can accelerate our efforts. And I also want to mention that it's important to engage in proactive acquisition of information. At the CAO, we still do not have information on the species distribution as well as the volume. There isn't much data, so it's important to proactively acquire information in areas or waters where data is non-existent. This will help us better our capabilities in the future, and I think that all of this data will help us model out the future prospects of fish resources and changes in the habitat. In addition to such scientific research, there's another point of consideration. The CAO is a vast vast waters, so we cannot do this alone. That is why we need multilateral research voyages as well as joint research projects with other countries around the world. Not only that, we have the indigenous communities living in the Arctic Circle. Their knowledge and research that befits their needs is something that we also need to conduct going forward. And utilizing this data, it's important to make inroads into the governance of various scientific organizations and mechanisms. Thank you very much.
예, 발표 잘 들었습니다.
Thank you very much for your presentation, and let us now move on to the next presentation.
넓혀서
Going even broader, we will look at the development of reverse aging exercise mimicking drugs through the study with Arctic fish. I'd like to invite Professor Mi Seop-yoon of Gachon University. Yes, as introduced, I am from Gachon University, from the Department of Medicine. I am Mi Seop-yoon. I am very honored to have this opportunity to make a presentation in this significant seminar. I would like to my topic actually is quite different from what you have been hearing today. I would like to look at how we can use Arctic resources in a more practical manner from the medical perspective and from the medicine's perspective. So my topic is the current status and outcome of the research and the future direction. And I will focus on the example of using polar bioresources based on my research and the future recommendation for research. As you know, polar research is led by COPRI, and over the past 30 years, there have been much progress and achievement. In particular, a new IBRV will be built, and we are ready for a new turning point in this polar research. And I think that we need to produce more concentrated results in research, and to gain more public interest, we need to be able to produce research results that can be understood by the public. And in step with the national demand, we need to develop relevant technologies so that the research results can be more beneficial to the country. And that should be the direction of the research. And in this direction, we are conducting ecosystem and many other relevant research with COPRI, and we are particularly interested in using Arctic resource. And there have already been many different relevant achievements. Just to summarize, there are two major achievements. One is to analyze the characteristics of Antarctic organisms, and using this, there are research conducted already on how to present more useful results. So for the first time in the world, a whole genome sequencing of Antarctic higher organism has been done and identified mechanism behind adaptation to extreme cold conditions. And in particular, using this technology, developing cold-tolerant gene from plants to develop cold-tolerant barley. And I understand that Antarctic lichen was used to conclude technological transfer agreement on diabetes medicine as well. So based on these research results and looking into the next generation polar research, using bioresources and biomaterials will be the key direction. And as you have been doing so far, polar biocharacteristics need to be analyzed to extract useful materials and substances. And polar biotic beta metabolome will be researched to develop practical and useful products. So these are the basic two tracks, and as you can see here, in order to commercialize these research, we need long-term research to analyze, discover the resources and analyze the characteristics and verify and validate the technologies to look at how these resources can be actually used. And commercializing them ultimately requires a long-term planning and perspective. We need to first build a pipeline of analyzing polar resources and a system to validate the research so that we can confirm the commercialization and potential. And this is a closer way to quickly reach results. However, that in turn requires discovering and analyzing biotic metabolomes and what kind of new materials linked to existing materials and how effective they can be in curing the diseases, and how we can develop them into new materials and new medicine. So this also requires a very long-term 3-step planning. So I am going to show you the example of research I have done. My project was chosen as a PAP project by COPRI, and for 2 years I have been working on this research to utilize polar resources. And as a model, I would like to present my project. We started off by the question out of a medical need that we face at my university. Korean society is rapidly aging, and the biggest problem here is sarcopenia of seniors. So sarcopenia would naturally seem to be a natural process of aging, but it is not the case, because sarcopenia is an illness. It is a reduction of muscle volume and the muscle power. So less mobility leads to metabolic illnesses, which drastically increases the death rate. So recently, illness code has been applied to sarcopenia, and this requires action, but we have yet to develop a cure. Doctors just simply recommend exercise and protein intake, but seniors who cannot really exercise can never overcome sarcopenia on their own. So we cannot just simply put this aside as a natural aging process. So in order to overcome sarcopenia, we need an exercise mimicking cure. So because of these characteristics, I focused on the fish from polar regions, as you have seen earlier. These fish can hardly move in the very, very cold water. They live very subsea. But even with such limited exercise and mobility, the muscles of these fish are quite sizable. And so even in such a condition with limited movement, I believe that there can be some kind of a controlling mechanism that controls the muscle. And if I can find that mechanism, I think that I can use it to help develop a cure for sarcopenia. Which also arises from lack of mobility. So in order to find a way to overcome sarcopenia of seniors, we wanted to look at the characteristics of the fish and the krill shrimps that are usually the prey for these fish. And we wanted to focus on what kind of substances in the krill fish lead to higher volume of muscles. And this is where we focused on in order to develop a cure for sarcopenia. So the target was mTOR, substance mTOR, which helps increase protein and muscles. To activate mTOR, we needed to find what would better enhance mTOR in order to overcome sarcopenia. So we looked at the substance that activates mTOR. We use different resources from COPRI, KIST, and different colleges of pharmacy at University of Gachon to find this. So we optimize our system to analyze the krills and mTOR with COPRI, and at the College of Pharmacy, they found a way to optimize the way to extract the useful substance from our Antarctic krill, and we built both in vitro and in vivo system for analysis. If I show you the results, mTOR complex was identified with a fully established analysis method, and we built a analysis system by Mr. Kang Min-young at KIST. And this has not been disclosed yet, but I cannot say that we have found the mTOR complex separated from a polar fish, but we are really successful. And we found a new candidate factor that combines with mTOR. So we will be showing you 7 different factors, and we have validated them again with a mouse test and found 2 more combining factors, CSP and MIH. CSP is a protein that targets mTOR, and MYH is for muscle fiber cellular differentiation and growth. And we can show you very interestingly at the bottom, that is a picture of a muscular cell, high density photo by dyeing the cells. The yellow indicates how the 2 different proteins are combined. And if you look at the end of the right-hand side photo, at the end of the fiber, you can see that they are concentrated there, meaning that the muscle cells have been formed, and while the fibers are being formed, these 2 are combined and act in some way. So we are planning and proceeding with follow-up studies in a very interesting manner. And also, we want to look at how the muscles are enlarged among the polar fish. So with the help of Dr. Kim from COPRI, we looked at the krill shrimp, because krill shrimp is the main prey for these fish, and we wanted to look at some useful substances possibly found in the Arctic krill. And we look at different factors that can impact the controlling of mTOR. And we found the 70% activated substances. So we did an analysis, and very interestingly for us, the cellular differentiation itself, so the enlarging of muscle, is not where this substance acts, but in enlarging the muscle itself, in convergence of the cells, this substance was at play. And with a secondary extraction, with a solvent, we are continuing to track down this process, and we are in phase 3, but it is not included in the slide. So we found that conversion is facilitated with no difference in cellular differentiation. So in vivo, we found how this acts in the muscles. We looked at the barium chloride to look at the muscle damage model that we already have, and how this ETOH extract works. So there are very few regenerative organs in our human body, but muscles can be regenerated after damage. So after damage, muscles are regenerated in different manners, and we can easily tell them with the naked eye. But in time, the muscles are fully restored. So we can easily analyze the impact of different substances. With Antarctic krill extract, we found that the muscle fibers are formed in a much stronger manner, and this has huge implications, because sarcopenia means the reduction of muscle volume and fiber. If at the early stage we can reinforce muscle volume, then we don't have to reach the stage of using cure. We can further delay and block sarcopenia development. So I think that there is huge potential for a cure, and we have applied for a patent, and we are continuing our research. So just briefly, we started off out of a medical need, and we use polar fish and the relevant characteristics to look at internal and external factors involved to help develop a cure of sarcopenia. We are nearly complete, and once completed, we will conduct technological transfer to develop food or medicine for sarcopenia. And furthermore, based on the polar research, we can become an entity that can develop a polar research infrastructure. So in the long-term plan, we have conducted our research for the past 2 years, but we are still at the stage of going from stage 1 to stage 2. So once we reach commercialization and develop actually into actual products, we need a long-term planning and support. So based on my experience, if I may, I would like to recommend a good and effective way to find useful bioresources. I think it is better to start off from a medical need. And this is a more efficient approach rather than starting from the polar region itself. And although I am not a member of COPRI, please make full use of external research institutes for a fuller research. And lastly, for 2.5 years, this was a PAP project that I pursued. But the research expenses have not been sponsored yet. So a long-term planning and budgeting in place to support a longer project would be even more helpful in providing support for the long term for all Arctic or polar research that are needed. Thank you very much. Yes, with the IBRV and medical needs were connected in this very meaningful presentation.
마지막으로 북극해
Let us move on to the last presentation. The last presentation is on the development of integrated health management system for polar Oregon operating ship and offshore based on satellite data. We would like to now invite Mr. Song Kang-hyun from Korean Register in charge of eco-friendly ship plant research. Thank you very much for all of your sharing on research findings. And my presentation will be focused on the IBRV, where all of this research will take place. And with the opening of the NSR, I think that there will be more ships that will be operating in polar waters. So I would like to talk about the safety of these ships. We talked about climate, environment, fish resources. And last but not least, I also am suffering a little bit from sarcopenia, and I've been working out right now. So I believe that all of the presentations had to do with what impacts the world, and especially for the very last presentation, it actually gave me some food for thought on how I can enhance my muscular strength. So thank you very much for the presentations. In my presentation, I would like to talk about the health management system of polar operating ships and other offshore structures. So it's about how we can maintain and manage the ship integrity or the structural integrity. In the 1990s, the bulk carriers have actually been quite damaged. So the IMO decided to engage in an investigation on the causes for such damage. So what they did was install sensors on these bulk carriers to measure and monitor the stress. So this was to understand the causes of the damage, but they found out that this has helped them monitor the overall structure of the ship that led to enhanced safety of these ships. So the IMO recommended to put together a hull stress monitoring system on the ships. So for particular ships with high risks, this monitoring system is embedded, and especially for the ice-breaking vessels, such system will be paramount. The signals that are transmitted can be analyzed to understand the remaining life of the ship. And not only that, the digital twin, which is the buzzword in the shipbuilding industry right now, can also be used to manage this data and monitor this data. So I would like to talk about what kind of research is underway in these domains. I'm sure that you all know the necessity of such research because in the Arctic Circle, a lot of gas, oil exists, and if we do decide to explore these resources, you can see that Europe and to Korea, China, and Japan, high significant gas consumers will have to receive and be supplied of these resources. Then that means that we need transport routes to make that possible. And rather than going down the Suez Canal, if we do see the waters open up, we can actually economically transport these resources to our countries. And also on the shipbuilding industry, due to the environment issues, compared to last year, we've seen an increase in orders by threefold for Korean shipbuilders because this environment element is a critical factor. If the NSR opens up, we believe that there will be more IBRVs being constructed, which will become the driving force of the shipbuilding industry. The next generation IBRV has a close relationship with Korea's shipbuilding industry. In order to build sound and robust ships, you need world-class technology. And I think that Korea's shipbuilding industry has that, which will, of course, benefit the next generation IBRVs. And in the flip side, in the case of the shipbuilding industry, they can utilize their cutting-edge technology to raise their competitiveness in the ships that they build in this new Arctic era. But of course, in all this, safety is the critical element. If there is an accident, if there is an event or incident, it may lead to casualties, deaths, damage to the reputation, as well as economic loss. So for the polar operating ships, it's important to make sure that safety is guaranteed. Therefore, this research is on predicting the safest route for these ships and also find a way to engage in safe maintenance. So for these ships, what happens is maintenance takes place every 5 years. But if we do see these polar ships, they go down very difficult situations. So it's not just a prescriptive type of maintenance that is required. If they have actually went through sea ice, there will be more maintenance required. So it should be based on the environment, the context. So a risk-based maintenance technique is something that we think is necessary. So that was also the need for such techniques was one of the reasons why we decided to engage in this research. In Russia, the gas is utilizing the ARC-7 by DSME to transport the LNG to the Far East. So this is the Yamal LNG carrier. So not only with regard to transporting these resources of oil and gas in the Arctic region, if the NSR opens up, we are going to see an increase in increase in cargo volume, and versus this going through the Suez Canal, we will be able to reduce the time by 30%. And as you know, what we had to do was to utilize the Capesize bulk carrier to go around Cape Town when the Suez Canal was blocked due to the container ship. But you can see that even compared to this route, we can reduce the time by a half if we utilize the NSR. So for the captain, if you want to voyage from A to B, it's important to first make that judgment whether this is a safe route. So that's something that should be done before the voyage. It's important to understand whether the ship has enough propulsion power to overcome the ice resistance, and you also need to understand whether it can overcome the ice impact. So in other words, structural stress is something that has to be assessed beforehand. But there are, of course, uncertainties that cannot be predicted. So sensors are embedded on the ship to engage in real-time monitoring to understand whether there are any situations where we're seeing the ship nearing towards its threshold. So then the alarm system will go up for the captain to understand what it has to do, whether it would have to divert from the situation. And by using these stress sensors, we can also measure the fatigue, the abrasion of the ship to measure the structural integrity of the ship. These sensors are very expensive, so you cannot attach these sensors to every area or every part of the ship. So it should be just focused on some key areas. And what we have to do is, for areas that are not measured, data should be gathered as much as possible to manage the structural integrity of the ship by also utilizing the digital twin. So I've already mentioned some of the contents of my research, but it starts off with the satellite to observe the sea ice and to predict the ice strength. So there's a mapping of the sea ice strength that's done. COPRI is in charge of mapping the sea ice strength. And once we have the map on the sea ice strength, we will decide on the safety route. And real time, during the voyage, we will be monitoring the situation and the alarm will go off when there is an issue. So the second part is putting together an integrated monitoring system. And the third, we analyze all of the stress signals to understand the fatigue life, abrasion, as well as the overall life of the ship. And last but not least is utilizing the digital twin to manage the structural integrity of the ship. So strategy 1 and 2 will be combined into one integrated system, which will be on board. And the third and fourth strategy has to do with maintenance. So it will be installed on ground to manage the situation. In the case of the IC strength map, you can see that there are high and low resolution images that are gathered from the satellite, and the automatic classification would be done on the images to understand the sea ice strength. There is, as you can see, the seasonal map of the icy strength, and next is on the safety route. Once we have this map, there could be multiple routes possible from A to B. And so we will look at the structural aspect and also in terms of the ice load to see whether that ship can actually fare such route. And not only that, it's about optimization to find the optimum route that will help us get to the destination in the shortest period of time. So that's how it's done, if you refer to the slide. So visualization of the characteristics of the sea ice is an input that we would be using, and we will be visualizing that using this program. We will edit the sea route to decide on the optimum route of the ship. Let me now move on to our real-time integrated monitoring system. There are many sensors that are attached to the ship, and especially for the icebreaker, for the areas that break the ice, there are multiple sensors that are attached. Not only Araun, but for the LNG carriers or the tankers and the automobile carrying vessels, all can utilize this integrated monitoring system. So you have to check whether these sensors can be used in cryogenic circumstances, and also it's attached to very narrow areas. So we're looking into wireless capabilities. So for Araun, you can see that the sensors were attached to gather information and monitor the information. So the signals that come from the bridge can be monitored. When there is a risky situation, the alarm will go off. And we now have a slide that indicates how the fatigue damage can be forecast it, and also how we can engage in simulation to reflect this data in the non-measured portions of the ship. On the ship, well, you can see the ship. We're seeing abrasion take place, so we have to measure that to understand the fatigue damage, and all of this data is being accumulated to check the fatigue life of the ship. I tried to summarize this on one slide. So real time, we gather this data on board, and then we engage in an assessment on the structural response of the BIC. We expand that out to the non-measured areas, and using the digital twin, we can have that all embedded into the system for simulation. So this is the abrasion test that's done, and we're collecting the data. So this is the digital twin structural integrity management system. So it manages all of the sensors. It forecasts the remaining lifespan of the ship. So that's all brought together to understand when maintenance should take place. And also decision making on the risk-based maintenance can be done by using this data. This is the digital twin management system that was developed. This is a 3D system. You can just click onto the tabs and you can see the life remaining for all of these individual parts and components. Starting from last year, we've been conducting this project. It's a 3-year project. The Korean Register is the lead, and there are multiple organizations, including DSME, Inha National University, Inha Technical College, KUPRI, Seoul National University, and in the sensors, FutureMain. So all of the leading institutions are involved, and we are coordinating all of the efforts. Next year, I think the research will be completed, where we will be able to present to you some refined findings of the research. Thank you very much.
예, 오늘 이 자리가
Yes, thank you. We talked about the climate, ocean, ecology, bio, fish resources, as well as some of the technologies that should be on board for IBRV. So we've had a comprehensive list up of various topics. And thank you very much for the speakers for their insightful presentations. And we can see that the audience has been benefiting greatly from the presentations. It's very difficult to do this, but miraculously, we are right on time. It's right now 11:30. So I would like to thank you all for being with us, and we'll now take a 10-minute break and then resume to invite our speakers and panelists for a panel discussion. So I will see you back in 10 minutes. Thank you.
예, 그러면
And now we will start a designated discussion with experts on the five presentations. This session will be moderated by Mr. Kim Sung-jun of COPRI's Climate Research Head. We have Mr. Kim Beng-min from PNU, Yang Eun-jin from COPRI, Mr. Kim Do-nam of National Institute of Fisheries Science, Mr. Do Ha-kwon of COPRI, and Mr. Ju Hyung-min of COPRI from the IBRV team. And now the moderator has the floor. Thank you very much for the introduction. Good day. I am honored to be the moderator for the discussion session of the Korea Arctic Science Research Seminar. I am Kim Sung-jung of COPRI. And before we start the discussion, I would like to say that the five presentations were all very interesting. And during the presentation, we've had some online questions. So before we proceed with the discussion, let me pose the question first. To Professor Myung-in Lee.
So with regard to the sea ice concentration and density, whether those are both same concepts. So I think that it's basically more or less the same sea ice intensity as well as concentration. So with that, let us begin the panel discussion. We have 5 panelists, and they were already introduced by our MC. So let us now begin. We have about 50 minutes for the panel discussion, so we cannot allot a lot of time for our individual participants or our panelists. We will be able to give you about 5 minutes per person. So I'd like to first ask Professor Kim Beng-min from Bugyeong National University for your intervention. Yes, thank you. Let me now begin my comments on Professor Lee's presentation. Professor Lee talked about the relationship between the Arctic and the mid-latitudes. So thank you very much for giving us a summary on your research. In 2014, you've also introduced my paper, so thank you very much. When I was engaging in research, there wasn't any papers that looked into the teleconnection between the Arctic and the Korean Peninsula. Along with Dr. Kim Sung-jung, what I tried to do was to understand the climatic relationship between the Arctic and Korea in the winter season. But ever since, we've been seeing more research emerging. And Professor Lee also talked about the fact that we're now moving from not only the winter season, but also to the summertime to understand the relationship of events or anomalies of heat waves, as well as forest fires, and how that's interconnected with the changes in the Arctic. Thank you very much for that detailed presentation. So you can see that we do have now a clear relationship based on observations between the Arctic and the mid-latitude weather events. So then, based on this relationship or teleconnection, how can we raise our predictability in our forecast? That was also mentioned in his presentation. And he introduced to us some recent research projects, and that if we do have more sufficient observation data of the Arctic, we will be able to raise the predictability performance of our weather forecast in the mid-latitudes. With regard to the background of Professor Lee's presentation, I would like to say that there was a lot of research on the relevance between the Arctic and mid-latitudes. However, on the other side, many of the conclusions were drawn that there isn't a clear relationship between the two. There were a lot of papers that were published as such. But if you look at these two conflicting papers, for those that believe that there is a relationship between the two, would base off their paper on the statistical analysis on past observational data. For those that believe that there's an uncertain relationship, would be focused on the computer numerical models. So still, there is some controversy between these two groups, and my paper was also at the center of such discourse and dialogue. But as I was listening to Professor Lee's presentation, there was one point that came to my mind that was deemed important. If you look at the recent research, compared to the mid-latitudes, you can see that the Arctic region, that's about just a tenth of the mid-latitudes. If we do have more sufficient data on Arctic observations, and because we have better satellite technology, we will be able to get more data to monitor the Arctic. And with better monitoring, you've mentioned that the predictability of the models will be improved. So I believe that if we can enhance the modeling based on further input from Arctic observation data, I think that we may be able to find a middle ground between these two conflicting views in the academia. So I was able to find some key implications from his presentation. Thank you very much for that. But I think that there are some areas that may require some more improvement where, yes, we do understand that the Arctic is important. So then where should be our focus? If we think about the climate change in Korea and to resolve the issues at hand in Korea, particularly which area in the Arctic should we focus on? I would like to maybe give some more food for thought on that. So Director Seo Won-sang mentioned that through the next generation IBRV, we will able to go into and trailblaze into new fronts. So the next generation IBRV will have better accessibility to the Arctic Circle. And in 2014 and now, there's a great difference in terms of the you can see that closer to originally it was in Norway, but it's now moving towards central Siberia, where we're seeing these interactions between the atmosphere and the ocean. So if we want to make full use of the next generation IBRB and to understand the climatic relationship of the Arctic and East Asia, and to make sure to understand and forecast these blockings based on the models, I think that we need to maybe shift towards the East Siberian Sea and focus our modeling on that, which will help us make better use of the next generation IBRV and also have better capabilities of the researchers on climate, because this area seems to be more relevant for the Korean Peninsula. So I think that this will help us deliver more refined results for our region. And Professor Lee, you talked about the importance and emphasized the importance of Arctic observation. But at the end of the day, if we want to raise the predictability of the modeling, the various calculations and formula in the model. So for the climate scholars, we call this the physical calculation process. So these formulas are all coded into the computer model, but you can see that the clouds of the Arctic and the surface ice, you need these inputs into this physical process. So when we do engage in research to better the input, I think that we can raise the predictability. And one final point. Climate change is impacting our everyday life, and we call this not climate change, but now climate crisis. And centered on the government, carbon neutrality is the key word right now, so many people are interested in this topic. However, there is one point that we need to remember. In order to achieve carbon neutrality in 2050, I don't know whether it be 1.5, 2 degrees, or 3 degrees, but we need to have accurate forecasting. In other words, we need accurate scientific data to achieve carbon neutrality. So we need to once again review how accurate we are in our forecast. And as a climate scholar, what I can say is that the uncertainty of these climate models, and we need to find a way to raise the predictability in order for us to achieve true carbon neutrality. And once again, that's why we need to invest in the Arctic, and the next generation IBRV is definitely a new opportunity for us. Thank you. Yes, thank you very much, Professor Kim, for that comment. You've mentioned about the importance of the Arctic observations, and also the fact that we need to raise the predictability of the models based on this data. and also how we can utilize the next generation IBRV in an efficient fashion to better our predictability in weather forecasts on the Korean Peninsula. Thank you for your comments.
Next, Ms. Yang Eun-jin from Kopri. Hello, I am Yang Eun-jin from Kopri. Since 2010, I have been looking into the Arctic Ocean, and the building of the IBRV was gleeful news for me. Listening to 5 presentations, I think that the IBRV will be very much in use. And Professor Kim Seung-gyu, you mentioned the environmental pollutants and ecosystem, and my comment is on your presentation. At the end of your presentation, you mentioned that we know very little about the Arctic pollution, and it came right to my heart. Araon actually conducted so much research in the Arctic. However, as you know, Araon had limited sea time and ice breaking capability, which meant that there was so much lacking that we needed to tackle all these Arctic issues, and that is why we are building a new RBRV. As climate change continues, the Arctic Ocean is actually opening up. In terms of ocean and air, pollutants are reaching the Arctic Ocean. And such inflow of pollutants are impacting the species inhabiting the Arctic and the human life that feed off of those species. So the trajectory of the pollutants and how the type of pollutants must be identified as a priority. And in the end, the next generation IBRV, once built in the Arctic CAO, will reach into areas that could not be reached by Araon, but starting with the areas that Araon has reached, to look at the marine pollutants, to collect information, and in real time monitor by building an observation network. In this way, I think we will be able to access pollutants in the Arctic in a more easy manner. And another point, many people ask me, what if the ice-breaking vessel just break up all the ice in the Arctic? Wouldn't that impact the environment? Well, I don't know what to say to that, really. I am speechless. But when we approach pollutants in the Arctic Ocean, I believe that IBRV will be spending more than 150 days in the Arctic Ocean. And that way, from the IBRV, there will be many different pollutants coming out of the IBRV, which should not be neglected. And once the new vessel is built, environmental pollutants in relation must be researched together. And secondly, in the CAO fisheries, Dr. Da has already presented that Araon didn't have any system to fish, but despite that, CAO fisheries agreement has been signed, and therefore we must protect the fisheries in the Arctic, and in a very primordial manner. We had to catch one fish one by one, and we had to filter the seawater for eDNA, and we used different assimilated data to collect the relevant data. But thankfully, in 6 times years, when the next IBRV is built, the vessel will have many different latest equipment that are attached to the vessel to analyze fish data. And we will be using this equipment to conduct fisheries research in the CAO. After the CALFA agreement has been signed, we will both tackle the research and also look at the fish as well. And this will be very good and advantageous for us to get a fishing quota allocated later on in the CAO. And Araon in its own way and the next IBRV in its own way will be used to conduct research in the CAO. Although there is very little fish in the CAO at the moment, we will continue and we will need to continue to accumulate relevant data. And lastly, once the IBRV is built, I think one of the key missions that needs to be carried out is a one-stop Arctic Sea Research Project. Yes, atmosphere, ocean are very important pollutants travel to the Arctic through the air and water from the subpolar region to the polar region. And as Professor Kim mentioned, microplastics flow into the Arctic through the air, but are built in the sea ice, in the water, and accumulated and deposited. So Arctic research should go beyond just ocean research. We must observe from the space, atmosphere, sea, ice, sea itself, and the subsea area. And all this needs to be tackled in a one-stop project. And in that way, I think we can contribute and find clues to resolving all the Arctic issues that remain unresolved. Thank you very much. Thank you very much for your comments about the marine pollutants, their trajectory identification. The next generation IBRV, once launched, could be releasing its environmental pollutants. So we need to take an interest in that. And also, Araon has researched the fishery resources in a very primitive manner, but with the IBRV, we'll have latest equipment for this, and an integrated one-stop project is needed.
Next, I would like to invite Dr. Kim Doo-nam of National Institute of Fisheries Science. Hello, everyone. Thank you, and it's a great pleasure to join our panelists in the discussion. I would like to talk about Dr. Na Hyung-sur's Korea Science Strategy presentation on Korea Science Strategy for the Conservation and Management of Fish in the Central Arctic Ocean. It was very interesting, and thank you so much for that in-depth research. With regard to cow in the high seas, until 2017, there was the fish stock expert meeting. The fifth meeting took place in 2017, and there was a lot of reference that was used to engage in mapping as well as monitoring. And in 2020, through the ad hoc coordinating group, SAS as well as Mosaic research projects were underway. And as you've mentioned, the Arahon did not take part in the Mosaic program, and that was quite a pity in my view. But of course, I'm sure that Dr. Na, you were involved, which is of course fortunate, and I believe that it was a great opportunity for you to collect information. As I was listening to your presentation, at COPRI, it's for the 5 years and 9 months. There was a K-Aware program and plans were set forth. And I can see that you have a well detailed out plan for that K-Aware research program, and I hope that we can also find a way to contribute to that research project or program. And we believe that the high seas and the fishing resources, can we actually connect the two? Is the question that comes to my mind. Every time I take part in scientific seminars and I listen to presentations, and also after I listen to your presentation, this is a thought that that remains, because we are identifying biodiversity and we're trying to understand the distribution of the species. But I think that this is a slightly different angle from utilizing the fish resources. For instance, we talked about the IBRV, where the midwater trawl will be installed onto the next generation icebreaker. But in order to engage in a certain type of targeted fishing, what needs to be done is to understand and analyze the biological characteristics of the species and find the optimal fishing method to catch such fish. So you need a multidimensional analysis and approach, and then you make that lead up to a certain fishing method. So I think that it's not just about sampling out from a random distribution. So in that aspect, I think that if that was the target, then that would be fine. But if you want to connect this with fisheries and the fishing method, I think that there may be a gap between the two. And in the CAO, there are also fishing methods that are prohibited from damaging the the bottom seabed. So I know that there were benthic fish stocks that do live in the seas. So, and it's very difficult to identify the distribution of such fish stock. And based on what you've mentioned, Dr. Na, I believe that there may be two recommendations that or suggestions that I can pose as a member of the NIFS. So first, in CAO, we have Canada and Greenland and other coastal states. And that I think that joint research with these countries are pivotal because these fish resources are highly migratory and straddling stocks. And you can see that they are broadening their horizon with the opening up of CAO. So I think that we need joint research with the countries because the fish stock, of course, as you know, they do not set their boundaries on the boundaries of or the EEZ. So in addition to the existing research reference, and if we do engage in research voice of the next generation IBRVs, I think that it's important to have other external researchers and foreign researchers on board to engage in joint research. In the case of a scientific research, based on CALFA, it indicates that within 2 years you need to establish a joint research program to see whether the fish resources can be catched in a sustainable fashion and that we need to assess the impact on the fish stock. But if you look at the Antarctic and in other high seas, if you see the case of the RFMOs, it's true that the Arctic is probably the very last standing contentious waters of high seas. So based on the other research programs, I think that we need to take preventative measures. And if that is the case, I think that not in 2 years, but maybe in 10 years, we may not be able to engage in any research on the sustainable fishing methodology. So that's why I want to say that we do need joint research with other coastal states in the Arctic Circle. And especially COPRI and Korea have these key experts like Dr. Na, and you are also a expert in sounds, and you have various techniques and facilities and equipment. And AUBRB, you've mentioned about the various undersea types of facilities and equipment. So with such expertise and experts like you, I think that even without utilizing fish gear, we may be able to understand the distribution of biodiversity underwater. For fishing, what we want to do is also introduce an electronic monitoring system. So in order to engage in such monitoring projects, you need image information and also information on the fish stock. But the coastal states within the EEZ do have such information, and I think that if deep learning can be possible, we can do that. And if we do need machine learning, that can also be utilized. So within this monitoring system, I think that it would be best to identify the species, measure the size, and for that to be possible, we need information from the coastal states, and we can utilize this information to maybe forecast and predict the weight. And I think that even without certain equipments, this can be possible. So I would like to mention that this could be another possibility for further joint effort. And the second point I would like to make, many did mention that site observations are more accurate than satellite observations, and that there may be a big numerical gap between the two. So you've mentioned about the importance of utilizing buoys for site observation. So continuous monitoring, I would like to say, is of course important. In the case of microplastics, with a greater concentration of the microplastics, you can see that there are specific species in the ecosystem that are greatly impacted, first and foremost. But if we do have Araon and IBRB, we will be able to draw a better picture, but I want to say that there are the biological, chemical, and physical factors that need to be continuously monitored even before we have the next generation IBRV. And we mentioned this with Dr. Na during the break, but the oceanic survey is, of course, always done. It doesn't go as planned, and when it reaches about 60% of our targeted goal, we say that we have actually achieved our goal. So there are so many factors in the observation or survey on board that will be impacted by so many external factors. So in the case of this K-Aware project, I'm pretty sure that there may be many challenges along the way, but despite the fact, I do want to mention that sustained monitoring is key. And in your presentation, I did make note of a couple of points. Dr. Na, you've indicated various methods about the net for the larval fish, for instance. And in the little waters, we also had non-invasive fish gear to collect these benthic fish. For instance, you can see that in the case of the octopus and for the non-vertebrates in the benthic areas or layers of the sea, I think that there could be other methods that can be utilized to collect such fish. So before we do have the next generation IBRV, I think that there are some better ways that we can utilize going forward. And then also about getting proactive information on the biological resources. I want to mention that this is really important. If you look at the Arctic waters, is probably the only high seas that does not have an RFMO. So what we're trying to do is acquire proactively information on the Arctic. And when we do have an RFMO in place, what could happen is we can actually contribute in the efforts and endeavors, and we will be able to get more incentives in the process. So in our scientific research, I want to mention that a proactive acquisition of information in this region is something that I really would like to support. Thank you very much.
의견 감사드립니다. 중앙국극회.
Thank you very much for your views. You've mentioned that link with fisheries, you've mentioned that is a different story. And with climate change and with the decline of Arctic sea ice, you've mentioned that joint research with the coastal states would be key. And of course, it would be great if we could engage in science observations, but AUVs can be utilized, and we can also verify these other unmanned and satellite observations. But you've also mentioned that we can actually acquire images to better the understanding in our observations.
Thanks, Mr. Do. Yes, I am from COPRI. My name is Do Ha-kwon. COPRI had two keywords in tackling biological research. First, good adaptive can lead to developing actual cure for sarcopenia. And thankfully, Professor Yoon said that through the substances found in polar organisms, we can lay the foundation for further development of medicine. There are combining proteins that combine with mTOR that can help overcome sarcopenia. And Arctic krill, also, we can extract 70% of elements to test and validate potential to overcome sarcopenia. So that was the gist of the presentation. And for both issues, presenters how bioresources must be maximized for use. Climate change, and what we can learn from IBRV is that climate change impacts the abundance of the species. They can be driven into extinction. And number two, through the IBRV research, we can engage more institutes, not only COPRI, to look at more and extract more useful resources from the Arctic. So what I would like to recommend based on the presentations is that for polar resources, we need a more comprehensive management system that is yet to be built. In step with changes, I think that we need to build a comprehensive and integrated management system so that polar resources can be efficiently managed, and we need to include cultivation systems and conservation systems. I know that there are useful possible potential materials, but we cannot conduct research all at once. So we need to maintain a resource management system so that we can secure bioresources. And as Professor Yoon mentioned, when we need help from external experts, we can share data with them through a system. And through this system, we can build a basis for international cooperation. Thank you very much. Yes, thank you for your comments. As global warming happens in the Arctic, sea ice is melting and pollutants keep flowing into the Arctic. So the impact to the polar and mid-latitude areas is huge, but the impact on the biological impact has not been fully researched. And with the global warming in the Arctic Ocean, this can lead to a reduction in abundance, in fact. So with a comprehensive observation system on polar resources, we can share data. And that was the gist of your comment.
죄송합니다. 주영민 단장님 부탁드립니다.
Next, Dr. Ju Hyung-min of COPRE. Hello, everyone. I'm Ju Hyung-min, in charge of the IBRV team at COPRE. Our speakers are all on the demand side of IBRV, and I think that I'm the only person that's on the supply side of the IBRV. This August, I joined the IBRV team, and you can see that Mr. Seo was the very first original team of the IBRV, which we passed the pre-feasibility study, and us as the second team is to build a robust ship based on the bidding process to select the shipbuilder of our next generation IBRV. And I want to say that we do have the strong responsibility to build a robust ship that will enable research voice in 2027. As was already mentioned, we had 7 challenges that we wanted to address and what we wanted to present at the pre-feasibility study. And we will make sure to build that ship based on your input. But there are a couple of points I would like to mention. Professor Kim talked about marine pollution. Of course, research on pollution is important, but what's more important is to make sure that it does not pollute the Arctic Circle. So we are trying to focus on building eco ships or green ships. As you know, we do have 2 dual fuel, including LNG, to reduce any impact on the air, so reduce air pollution. And we've seen strengthened regulations on exhaust gas from the ship, but what we want to do is to make our internal standard more stricter. So SCR are some of the equipment that we will have on board to reduce NOx and to make the ship greener than any other ship. And Professor Lee and Professor Na and Kim talked about some of the research that can be done in the high seas. So to cater to these needs, we will make sure to enhance our ice breaking as well as structural integrity capabilities. And Dr. Na talked about the importance of joint research. In the case of the Araon, it's being operated in both the Arctic and Antarctic. So in the Arctic, you can research for 35 to 40 days approximately. But if we do have the next generation IBRV, this ship, if it goes according to plan, about 150 days can be provided as the research period by using this IBRV. So I think that a lot of the research demands can be satisfied in the process. And then with regard to ship safety by Mr. Song, So we have CRISO as our joint lead to find a way to enhance the safety features of the IBRV. As you know, the next generation IBRV will be much more capable than the Araon in terms of size as well as other capabilities, and we will have various equipment on board. So as a researcher, I know that you would want the optimal environment to engage in your research, so we will make sure to have that in mind starting from the design. Araon was our very first IBRV, so it was the first for everything, for all of us, so there were a lot of challenges, but based on that, we've learned a lot of lessons, and for about 10 or so years through the voyaging in the Arctic and Antarctic, we were able to accumulate knowledge and know-how and feedback from the researchers on what the next generation IBRV should look like. Next year, when lead agency is selected, we will be hosting many public hearings, and I would like to ask for your feedback and your insights so that we can build a better IBRV. Thank you very much. Thank you very much for your comments. So, as the supplier of the IBRV, you mentioned that there could be certain pollution from IBRV, the new next generation IBRV, and you've mentioned that you're going to make sure that it's an eco ship or a green ship. And with a lengthened voyage period, you've mentioned that a lot of the research needs will be satisfied in the process. And there are waters that the next generation IBRV will be able to travel, and you've mentioned about enhancing the robustness and the integrity of the IBRV to make that possible. And he also talked about the importance of seeking feedback, and that the organization will be hosting public hearings to build a better ship. I would like to extend my gratitude to the meaningful interventions of all of our panelists. I think that we have about 10 minutes remaining. So in addition to our designated discussants, I would like to ask our speakers as well as those here on site if there are any comments that you may have on this topic. So with regard to the presentations, as well as any comments on ways to facilitate Arctic research, is there anybody that would like to chip in? Yes, Director Seon-sang, would you like to go first?
Yes. When I heard the keynote speech, I heard it from a research planner. And as an international law expert, I would like to present on the KAUFA. As I planned this project and as I heard of the demand for fisheries research, I believe that the direction for scientific research must include conservation of fisheries resources in CAO. But research in fisheries in CAO doesn't mean development or industrial development. It also includes how the fish species are distributed in this area and how we can better conserve them is the whole purpose of KAUFA. And through 10 years of scientific research, we found that this can be sustainably and economically if we conclude that economically these fishery resources can be used in a sustainable manner, then we will start allocating the quota. Same for KEO. For this project, conservation of fisheries resources is the main purpose, and once we are sure that fishery resources can be safely conserved, then we can start looking into possible fisheries. So I think that we are in the same line. Thank you very much for that. Regarding fishery resources, yes, whether we are going to use it or conserve the resources, I think that there is a debate. The Arctic region itself, well, what happens in the mid-latitude area impacts negatively to the Arctic, and as the Arctic melts, the shipping route is shortened. And I don't think this necessarily leads to an increased pollution, but it can also reduce transaction distance and time to save energy as we ship the same volume of cargo. So I don't think that we can see this only negatively, because CO2 when emitted immediately mixes up with the atmosphere. Of course, air also is a different story, but anyhow, that is what one point I wanted to raise. And anyone else? Comments, questions, or anything? In the interest of time, maybe Mr. Kim?
저는 그냥 그 북극에서의 환경 오염
If we just focus on the pollution of the Arctic,
통해
Yes, I collaborated with COPRI in not only Arctic but Antarctic. I conducted microplastic research. One of the key findings for Antarctica was using a research station, but the pollutants coming out of the research station itself, the discharge water, in fact, could be an important source of pollution in Antarctica, as we are learning. And so now we have various agreements in place to protect the Antarctic region, but any compulsory actions are not yet in place yet. And we are still in the process of setting the criteria for what can be done in Antarctica. But once these issues become more serious and raised, then the regulation will be strengthened. So the research stations will have to have facilities or measures in place to prevent pollution. So in that sense, for polar research, and for the IBRV, I believe that similar applications will be applied. So as Mr. Chu has mentioned, not only using low sulfur fuel or limiting air pollutant emissions, which is ongoing, but as we compile these efforts, we can also look at the heavy water discharge, the control of the discharge regulation, and the painting material on the ships, and so forth. All these specific regulations are being discussed among scholars. So going forward, as vessels are more in use, then those regulations may come to force. So we must think of them in advance. When you are building the vessel, I think that you need to give these sides a consideration. Maybe not at the very initial stage, but later when these issues arise, you need to have some kind of a buffer and strategy to respond accordingly. Thank you very much. As we operate the station, and I was a winter team leader myself, but discharge water is always a cause of concern. With more and more stations built, then of course we do think that the pollution from the stations could be a possibility, so we need to reinforce regulations. And as Mr. Chu has mentioned, in those terms, IBRV must restrain and minimize pollutants as much as possible as research is pursued. So anybody else?
최영주 실장
And maybe Mr. Choi, if any questions online? None. All right, then anyone from the floor?
시장철 부장입니다.
뒤에 마이크가 준비돼 있어.
빨리 밥 먹기 위해서
it's just me between lunch, so I want to mention.
30년이나 50년을 내다보고
I want to say that as the pole of the Earth, I think that we may have to be more, let's say, provocative in the words that we may use. I think there is a lot of research that we want to do in the future, but I think that we need a 10-year or 20-year roadmap, because if we do not have that long-term plan, it would just be about trying to find budgeting in a short span of time. So I think that it's important to make sure that we have a long-term perspective going forward.
예, 우리 좋은 말씀 해주셨고요.
Thank you for the wonderful comment, and of course, this may be a sensitive topic, but the IBRV will not be just for COPRI, but for all academic and industrial use. for all of us, I believe. So I think that was the point of the comment. And since we have run out of time and it's lunchtime, we had been running a very tight program, and I apologize. So with this, I would like to conclude the Korea Arctic Science Research Seminar. Thank you very much. Thank you. The moderator has done wonderfully keeping in time, and we are right on time. Thank you very much. Today's seminar was so very sophisticated in terms of presentation and discussion, second to none. Thank you very much for the high quality content. And with that, I would like to declare that the Korea Arctic Science Research Seminar has come to an end. I would like to thank all participants joining us online and offline for joining us. And why don't we conclude the seminar with a big round of applause. Thank you very much.
발표
원활한 회의 진행을 위해서 휴대폰은 소리가 울리지 않도록 진동 또는 무음으로 설정을 부탁드리겠습니다. 휴대폰은 다시 한번 말씀드립니다. 휴대폰은 진동이나 무음으로. 안녕하십니까. 그럼 지금부터 북극협력주간 과학기술의 날 두 번째 세션으로 한국북극연구 컨소시엄 세미나를 개최하도록 하겠습니다. 오늘 사회를 맡은 한국북극연구 컨소시엄의 서영교 사무총장입니다. 먼저 바쁘신 가운데에도 오늘 세미나를 위해 참석해 주신 강성호 한국북극연구 컨소시엄 운영위원장님과 오늘 행사 좌장을 맡으신 김현수 대한조선학회 회장님, 그리고 주제 발표와 지정 토론을 맡으신 전문가 여러분들께 감사의 말씀을 드립니다. 또한 온라인으로 참여 중이신 모든 분들께 감사드립니다. 오늘 세미나는 한국북극연구 컨소시엄이 해양수산부 지원으로 지난날 발간한 극지 이슈 리포트가 다룬 8개 주제 중에서 3개의 중심 주제를 선정하여 극지활동진흥법 제정과 북극권에서의 우리나라 경제산업전 진출 전략 세션을 구성하였으며 그 해당 주제의 저자분들과 지정 토론자분들을 모시고 행사를 진행하고자 합니다. 그럼 오늘 코학 세미나에 대한 환영의 의미로 극지연구소의 소장님이시자 한국북극연구 컨소시엄의 운영위원장님을 맡고 계신 강성호 운영위원장님께서 개회사를 해주시도록 하겠습니다. 앞으로 나와주시기 바랍니다.
네. 안녕하십니까. 극지연구소 소장이자 한국북극연구 컨소시엄 코악 운영위원장을 맡고 있는 강성호입니다. 먼저 우리나라에서 북극을 주제로 하는 가장 큰 행사인 북극협력주간에서 한국북극연구 컨소시엄이 세미나를 개최할 수 있도록 아낌없이 지원을 해주신 36개 회원기관과 관계자분들께 진심으로 감사드립니다. 특별히 오늘 이 행사가 개최되도록 지원해 주신 해양수산부 관계자분들께 감사의 말씀을 드립니다. 2013년에 수립된 범부처 북극정책기본계획을 기반으로 해서 2015년에 출범한 한국북극연구 컨소시엄은 산업계, 대학, 연구계 등 36개 회원기관이 그동안 적극 참여해 주시고 지원해 주신 덕분에 2030 북극연구 중장기 로드맵 수립에서부터 극지 이슈 리포트 발간, 북극서클 총회에서 컨소시엄 세션 개최, 그리고 국내 북극협력주간에서 매년 연례 세미나를 개최할 수 있었습니다. 또한 북극인문사회 및 산업분야 기획연구 수행 등 회원기관의 전문성을 기반으로 다양한 연구 영역을 발굴하고 그 활동 범위를 확장할 수 있었습니다. 특히 그간 북극협력주간에서 북극연구 컨소시엄 세미나는 북극의 과학, 산업, 정책 등의 전 분야에 대한 주요 이슈를 확인하고 융복합적인 관점에서 미래 비전과 대안을 제시하는 연례 행사로 자리매김하였습니다. 오늘 세미나도 해양수산부가 지원하고 북극연구 컨소시엄이 제작 발간한 극지 이슈 리포트의 주요 8개 주제 중에서 올해의 북극 이슈와 정책 수혜에 부합하는 이슈들을 중심으로 오늘 세미나를 구성하였습니다. 대표적으로 극지활동진흥법이 국회를 통과하였고 차세대 새벽연구선 건조 예비타당성 조사 통과 등의 굵직한 현안들이 해결되었습니다. 이러한 현안사항을 반영하여 올해 세미나 주제는 극지활동진흥법 제정과 북극권에서의 우리나라 경제 산업적 진출 전략으로 설정하였습니다. 정책적인 관점에서 극지활동진흥법의 세부 내용과 우리나라 극지정책의 전망을 발표하고 산업적 관점에서 극지선박 안전운항 기술 개발 주제를 논의할 예정입니다. 마지막으로 수산과학의 측면에서 지구온난화가 극지수산자원에 미치는 영향과 대응을 주제로 삼아 법, 산업, 수산과학적 측면에서 다채롭게 북극 이슈를 논의하는 자리가 될 수 있도록 구성하였습니다. 모쪼록 오늘 세미나에서 컨소시엄 회원기관 전문가분들의 발표와 토론을 통해서 극지활동기본법을 기반으로 하는 북극 이슈 해결을 위한 융복합적인 협력과 해안이 도출되어 우리나라가 북극에서 나아가야 할 정책 방향이 제시되길 기대합니다. 마지막으로 코로나 사태 장기화와 바쁘신 연말에도 불구하고 이 자리에 참석해 주신 김현수 대한조선학회 회장님을 비롯한 KMI, 국립수가원, 크리소, 대우조선해양 등 모든 전문가분들과 온라인으로 시청하고 계시는 모든 참여자분들께 건강과 행운이 함께 하시길 바라겠습니다. 감사합니다.
네, 감사드립니다. 그럼 본격적으로 발표를 시작하도록 하겠습니다. 각 발표자분들은 원활한 행사 진행을 위해 발표 시간 20분을 정확하게 지켜주시면 감사드리겠습니다. 그럼 첫 번째로 극지활동진흥법 제정과 우리나라 극지정책의 미래라는 주제로 극지연구소 최영준 정책개발실장님께서 발표를 해주시겠습니다. 네, 시작해 주시기 바랍니다.
예, 안녕하십니까. 극지연구소에서 정책개발실장을 맡고 있는 최영준입니다. 오늘 저는 극지활동진흥법 및 하위법령의 주요 내용에 대해서 제정 이유와 어떠한 기대가 있는지에 대해서 말씀드리도록 하겠습니다. 네, 사실 극지활동진흥법은 이번에 세 번째 입법 활동을 통해서 통과된 법률입니다. 지난 19대, 20대에도 입법이 됐었지만 일부 쟁점 조항이 있어서 국회에서 회기 만료로 자동 폐기가 되었었고, 이번에 세 번째 21대 국회에서 쟁점 조항을 삭제하고 주요 진행 내용 위주로 법이 입법이 되어서 신속하게 제정이 되었습니다. 사실 19대, 20대에 대해서는 저희 서은상 부장님이나 또는 다른 박사님들께서 먼저 백업을 많이 해주셨고, 제가 지금 시기에 21대 국회에서의 입법 활동을 지원했기 때문에 본 발표를 진행하게 되었고, 21대 주요 내용에 대해서 중심으로 말씀드리도록 하겠습니다. 먼저 극지활동진흥법 제정 목적에 대해서 말씀드리겠습니다. 먼저 극지활동진흥법은 기후변화, 자원 확보 등의 극지의 전략적 가치 증가에 따라서 우리나라 전체 차원에서 정부 수준에서의 체계적 지원을 위해서 마련된 진흥법적 성격의 법률입니다. 기존의 극지와 관련해서는 남극활동진흥법 및 환경보호에 관한 법률이 있었지만 이 법은 사실은 국제조약에 따라서 국제조약 의무 수행을 위한 국내의 강제적인 의무 수행을 위한 약간의 규제법적인 성격이 있었고, 우리나라만 좀 특이하게 남극연구활동진흥 기본계획이라든지 일부 진흥 내용이 가미되어 있었고, 그에 따라서 현재 제4차 남극연구활동진흥 기본계획이 수립되는 등 남극법에 따라서는 사실은 남극에 대한 부분에 대한 계획은 수립이 되고 있었습니다. 다만 결국 놓고 보자면 북극에 대해서는 사실은 이제 법정 계획이 부재한다거나 법률적인 영향이나 근거를 확보할 수 있는 근거가 사실 없었기 때문에 극지활동진흥법으로 묶이게 되면서 북극에 대한 법적 근거 또 법정 계획을 세울 수 있는 기반을 마련하게 되었습니다. 재정 경과에 대해서 말씀드리면 제21대 국회가 개원하고 20년 12월에 정부 발의로 기존의 국회 입법과 달리 이번 극지활동진흥법이 제출이 되었습니다. 그리고 좀 신속하게 저희가 놀랄 정도로도 신속하게 진행이 돼서 3월 24일에 국회 본회의가 의결되었고 20일 국무회의 공포를 통해서 제정된 후에 현재 하위법령까지 제정해서 10월 14일부터 극지활동진흥법이 시행이 되고 있습니다. 그래서 주요 특징에 대해서 말씀을 드리면 극지활동진흥을 위한 일반법적 성격을 가지고 있는 법률로 봐주시면 되겠습니다. 그래서 목적, 이념, 연구개발, 인력 양성, 경제활동 진흥 등에 대해서 일반적이고 선언적인 조문을 사실 담고 있습니다. 그리고 또 남극활동 및 환경보호에 관한 법률이 사실 사라진 것이 아니고 남극법이 있는 상태에서 극지활동진흥법이 수립이 된 거기 때문에 남극법은 특별법으로서 남극에 대한 규제와 일부 진흥 내용을 담고 있고 극지활동진흥법이 극지에 대한 포괄적인 내용을 담고 있습니다. 그래서 극지법 제5조에 보시면 극지활동과 관련해서 다른 법률에 특별한 규정이 있는 경우를 제외하고는 이 극지법에서 정하는 바에 따른다 이렇게 규정이 되어 있고 6조 1항에는 극지활동 진흥 기본 계획을 수립할 때에는 남극연구활동진흥법에 있는 남극활동 진흥 기본 계획과 남극에 대해서는 연계해서 수립을 해야 된다 이렇게 법 조문으로 연계가 되어 있습니다. 그리고 또 이제 진흥법적 성격이 있기 때문에 그 진흥을 위해서 극지활동 진흥 기본 계획 수립, 통합정보 시스템 구축, 그리고 안전관리 체계 구축 등의 후속 조치와 진흥을 위한 기반 체계 마련에 대한 내용을 담고 있습니다. 자, 그럼 이제부터 재정의의에 대해서 본격적으로 말씀드리겠습니다. 첫째로는 우리나라가 극지를 바라보는 관점과 접근법의 전환이 있었다고 감히 좀 말씀을 드릴 수 있겠습니다. 기존의 남극법 재정 목적을 보게 되면 남극조약과 환경보호 의정서에 따라서 국제협력체제의 참여와 필요사항 규정을 통해서 과학기술 발전에 기여한다고 국제법적 성격의 의무 이행과 과학 발전에 대한 기여라는 부분으로 사실 좀 제한이 있었습니다. 다만 이제 극지법 재정 목적을 보게 되면 지속 가능한 발전과 체계적인 극지 활동 진흥의 육성 지원 사항에 대한 규정을 통해서 국가 경제 발전과 국민 삶의 질 향상, 인류 공통의 문제 해결에 이바지한다는 것으로 좀 더 폭넓게 재정 목적이 제정되어 있고 기존의 과학 연구나 환경에 대한 부분뿐만 아니고 경제나 지속 가능한 개발, 우리 또 삶의 문제에 영향을 미치는 문제까지 해결한다고 보다 적극적인 관점을 제시하고 있습니다. 그래서 법률이라는 것이 국내법이긴 하지만 어쨌든 국가가 극지를 어떻게 바라보는지에 대해서 국내뿐만 아니고 만방에 공표를 한 것이기 때문에 이 점에 있어서는 극지법을 통해서 우리가 극지에 다가가는 방법과 인식에 큰 변화가 있었다고 평가해 볼 수 있겠습니다. 두 번째로는 극지활동 기반 시설 운영에 대해서 극지활동 수행의 법적 기반을 확보하게 됐다는 데 큰 의의가 있습니다. 사실 이제 정책 지원을 하면서 가장 약간 궁색했던 부분이 있는데요. 사실 외부나 또 부처에서도 극지활동이 어떤 근거를 가지고 수행을 하냐 이렇게 물었을 때 사실 답할 근거가 없었습니다. 법적 근거가 없었기 때문에 극지 연구가 왜 필요하고 기후변화와 맞물려서 어떠한 논리로 진행이 돼야 되는지에 대해서 설명을 주로 했었는데 극지법이 제정되면서 이제는 극지 활동에 대한 부분이 국제협력, 인력 양석, 연구개발, 활동 인프라 운영에 대해서도 극지법 몇 조 몇 항에 의해서 우리가 수행하고 어떻게 하고 있다 이러한 법률적 근거를 당당하게 말할 수 있게 됐습니다. 세 번째로는 앞서 잠깐 말씀드렸지만 극지 활동에 대한 법적 지원 기반이 확대됐다는 의미가 있습니다. 극지법에 따라서 이제 북극권을 포함한 법적 기반과 법정 기본계획을 수립할 수 있게 됐는데요. 기존에 13년에 북극정책 기본계획도 세웠고 18년에 북극활동진흥 기본계획 그리고 이번에 2050 북극활동 전략도 수립을 했지만 사실은 법률에 근거한 것이 아니고 국무회의 의결을 통해서 발표된 정책이었습니다. 그리고 남극은 이제 계속 지금 3차까지 해서 4차까지 수립하고 있듯이 법정 기본계획으로 남극 연구활동 진행 기본계획을 계속 지속적으로 수립을 하고 있었고요. 결국은 이제 북극이라는 빈 공간에 대해서 극지활동 진행 기본계획을 통해서 법률적인 계획을 마련할 수 있게 된 것으로 평가할 수 있겠습니다. 네 번째로는 남북극을 포괄하는 세계 유일의 사례입니다. 이번 개막식에서 장관님께서도 발언에서 말씀을 하셨지만 세계 최초로 남북극을 포괄하는 법률적인 통합 체계를 가질 수 있게 되었습니다. 이제 남극에 관련해서는 대부분의 국가가 남극법을 가지고 있습니다. 즉 우리나라처럼 국제 의무와 환경보호, 과학적 기술 발전을 위해서 저희와 유사한 성격의 조항을 가지고 있는 남극법들을 남극 활동을 하는 대부분의 국가가 가지고 있고요. 북극에 관련해서는 북극 관련된 법률은 연안국들이 주로 가지고 있습니다. 왜냐하면 연안국들에게 북극은 남의 나라 땅이 아니고 자기 땅이기 때문에 그에 대한 환경보호, 해상 안전, 해양 환경 등에 대해서 규제 내용 또는 진흥 내용을 담은 법률을 가지고 있습니다. 그리고 저희가 이제 이 작업을 하면서 계속 이제 리서치를 했는데 가장 유사한 법률로는 1984년에 제정된 미국의 북극 연구정책법이 있습니다. 그래서 그 법에는 우리와 유사하게 부처 간의 협의체를 구축할 수 있는 내용, 그리고 과학연구를 컨트롤할 수 있는 위원회 설립, 그리고 북극 연구 기본 계획을 5개년 주기로 수립하게 되어 있어서 우리와 상당히 유사한 내용을 많이 가지고 있고, 다만 북극에 한정되어 있다는 특징이 있겠습니다. 그래서 그런 의미에서 우리나라가 여러모로 찾아보았지만 남북극을 함께 포괄하는 법률을 수립한 것은 세계 최초이자 유일의 사례로 남게 되었습니다. 다음으로 이제 법안의 주요 내용에 대해서 말씀드리겠습니다. 잠깐 특성에서 말씀드렸지만 일반적이고 선언적인 내용들이 좀 담겨 있고요. 그리고 극지활동 수행체계 구축에 대해서 구체적인 내용들을 담고 있습니다. 그리고 또 진흥과 법적 근거 확보에 대해서 이 법에 예를 들면 정부가 이 분야에 있어서 어떠한 정책을 수립해서 지원해야 된다, 이러한 사항들이 담겨 있습니다. 보다 자세한 조항별 의미는 뒤로 가서 다시 한번 말씀드리겠습니다. 그래서 제가 이제 법 조항에 대해서 체계 구축과 법적 근거 확보에 대한 주요 내용을 위주로 정리를 해봤는데요. 첫째로는 극지활동 진흥 기본계획을 수립하게 되면서 앞으로 5년 단위로 매년 기본계획과 시행계획을 수립해서 23년부터 27년까지 앞으로 계획을 수립할 예정으로 있고, 이 계획에는 현재 수립한 2050 북극활동 전략을 바탕으로 5년 단위의 세부 계획이 반영돼서 과학연구뿐만 아니고 경제, 산업, 조선, 항로, 에너지까지 모든 포괄적인 내용이 담길 예정으로 있습니다. 그리고 이제 제13조에 보면 극지 통합정보 시스템 구축에 대한 내용이 담겨 있는데요. 이 법을 지원하는 과정에서 많은 지능법적인 부분들을 살펴봤는데 대부분의 지능법이 이와 같이 통합정보 시스템을 구축 운영한다는 내용을 포괄하고 있습니다. 그래서 이 통합정보 시스템 구축 운영을 통해서 이 법이 지능법적인 성격을 나타내는 가장 특징적인 조항이라고 볼 수 있겠고요. 앞으로 이에 따라서 이제 정부와 극지연구소는 앞으로 예산을 확보해서 극지연구 데이터, 또 극지 관측 자료, 공간정보 시스템, 안전항로 시스템, 위성자료 등에 대해서 체계적으로 하나의 플랫폼에 모아서 관리를 해야 하는 과제를 안게 되었습니다. 그리고 또 하나는 이제 극지 사고 예방과 신속한 대응을 위해서 안전관리 체계를 마련하게끔 법적으로 조항이 되었고, 이에 따라서 안전관리 지침 수립, 기반 시설에 대한 안전 점검 등을 수행할 예정으로 있습니다. 그리고 그간에 우리가 계속 해오던 연구개발, 그리고 기반 시설 운영, 국제 협력에 대한 부분이 법으로 근거가 되었고요. 이제 마지막으로 하나 주목할 만한 것은 그동안 이제 극지연구소가 임무를 수행했습니다만 여러 가지 사업들에 대해서 용역 사업으로 수행을 한 부분들이 많이 있었습니다. 근데 이제 이 법을 통해서 이제 어떠한 기능에 대해서 어떤 기관에 업무를 위탁할 수 있는지에 대해서 명확하게 근거가 확보되었기 때문에 이런 연구를 수행하는 기관에 있어서도 앞으로는 명확한 위탁 근거를 가지고 업무를 수행할 수 있게 되었습니다. 그리고 이제 시행령과 시행규칙이 사실 법이 4월에 제정됐지만 10월에 시행되면서 6개월 동안 이제 시행령과 시행규칙의 절차를 밟게 되었고, 법에서 대통령령 또는 시행규칙으로 정한다고 한 부분에 대해서 저희가 대통령령 10개조, 해양수산부령 3개조로 시행령과 시행규칙을 마련했고 법과 동시에 21년 10월부터 시행이 되고 있습니다. 그래서 극지활동 진흥 시행령에 대해서는 기본계획 수립, 또 실태조사, 전문인력 양성, 업무 위탁, 그리고 극지활동에 필요한 기반시설 안전관리 등에 대해서 법률에서 세부적인 내용으로 정하도록 위임된 사항에 대해서 보다 명확하게 제시를 하고 있고, 시행규칙의 주된 내용은 극지 통합정보 시스템 구축과 관련된 내용입니다. 제13조에 보시면 관련된 내용은 극지법 중에 유일하게 시행규칙으로 위임한다고 되어 있어서 시행규칙의 극지 통합정보 시스템에 대해서 정의와 또 어떠한 대상들이 포함이 되어야 되는지에 대해서 제시가 되어 있습니다. 그래서 계속 이제 말씀을 드리면 이제 후속 조치를 시행을 해야 되고요. 이제 극지활동 진흥 기본 계획은 차년도부터 정부에서 발주를 해서 수립을 할 예정으로 있고, 통합 정보 시스템도 현재 구축을 위한 예산 작업을 위해서 정부 프로세스에 따라서 정보화 전략 계획 수립 등의 작업을 하고 있고, 현황 파악 등의 조사가 수행 중에 있습니다. 그리고 극지활동 기반 시설 안전관리 체계 구축에 대해서도 안전관리 지침을 어떻게 세워야 되는지, 현재 안전관리가 어떻게 되고 있는지 현황 파악 등에 대해서 부처와 극지연구소가 협조해서 현재 절차를 밟고 있는 것으로 알고 있습니다. 마지막으로 이 법에 따라서 앞으로 어떻게 이제 극지 연구가 변해 나갈지에 대해서 잠깐 말씀을 드리면, 첫째로는 극지 활동에 대한 국가 차원의 공통된 인식과 수행 체계를 확보했다고 평가할 수 있겠습니다. 그래서 이제는 법적 기반을 가지게 되었고, 이 법에 따라서 수립되는 법정 기본 계획에 따라서 극지를 포괄하는 극지 활동 기본 계획을 수립할 수 있는 정책적 기반을 가지게 되었습니다. 그리고 이 법에 따라서 보다 구체적으로 통합 정보 관리라든지 안전 관리를 할 수 있는 체계를 구축하게 되었고, 여기에 더 뜻깊게도 21년부터는 차세대 새벽 연구선이라는 첨단 연구 인프라를 확보함으로써 이 법의 수행과 목적 달성에 기여하는 첨단 인프라까지 함께 확보할 수 있는 큰 의미가 있는 해가 됐습니다. 그리고 두 번째로는 산학연 간의 유기적으로 연계된 극지활동 협력 생태계 활성화에 법이 기여할 수 있을 것으로 예상을 할 수 있습니다. 예를 들면 통합정보 시스템만 하더라도 극지연구소가 과학 데이터를 가지고 있기는 하지만 항로 정보라든지 극지 기지 주변의 수로 정보, 그리고 또 위성 정보, 이런 부분에 대해서는 다양한 기관이 함께 참여해야 됩니다. 그래서 국토지리원이나 또는 해양조사원도 함께 해야 되는 부분들이 있고요. 그래서 그런 식으로 저희가 협력 생태계를 마련해 나가야 하고, 인력 양성만 하더라도 과학연구자뿐만 아니라 정책연구자, 그리고 인프라 전문가, 그리고 특히 세빙선으로 오게 되면 안전관리자와 아이스 파일럿까지 함께 양성을 해야 되기 때문에, 이거는 더 이상 이 법에 따라서 진흥을 위한 시책을 시행하더라도 어떤 한 개의 기관이 다 할 수 없는 그런 이제 수준이 되었습니다. 그렇기 때문에 극지와 관련되고 또 거기에 지원할 수 있는 모든 기관들이 함께 협업을 해야 이제 생태계와 법의 의무를 수행할 수 있는 그런 상황이 되었습니다. 그리고 이제 마지막으로는 법률적 조항에 따라서 특이 사항을 살펴볼 수 있겠는데요. 현재 제4차 난극연구활동 진흥 기본계획에 대해서는 국가과학기술자문회의의 심의를 거쳐서 확정하게 되어 있습니다. 근데 이제 극지활동 진흥 기본계획은 법제처에서도 왜 국무회의인지에 대해서 물어보긴 했지만 국무회의의 심의를 거쳐서 확정을 하게 됐습니다. 저도 정책부서에 와서 과기관계 장관회의, 국무회의 등에 대한 정책을 올리는 것을 지원을 해봤는데, 국무회의에 올리는 것이 훨씬 더 까다롭고 다양한 분야를 포함해야 하는 어려움이 있는 작업입니다. 따라서 이제 국무회의 심의를 거쳐서 통과가 되다 보니 정책적 위상도 높아지고, 또 극지연구에 대한 타당성, 수행 필요성, 또 이슈와 공론화 과정에서 어느 정도의 우위를 점할 수 있는 이점이 있다고 해석해 볼 수 있겠습니다. 그래서 지금까지 주요 내용과 앞으로 미래상에 대해서 한번 살펴봤고요. 보다 자세한 내용은 토론을 해나가면서 말씀드릴 수 있도록 하겠습니다. 이것으로 발표를 마치겠습니다. 감사합니다.
네, 감사드립니다. 정확하게 시간 지켜주셔서 감사드립니다. 극지활동진흥법 제정과 배경, 내용, 의의 그리고 미래상에 대해서 발표해 주셨습니다. 두 번째로 디지털 트윈 기술을 활용한 극지운항 선박 안전운항 기술 개발 현황과 미래 전망이란 주제로 선박해양 플랜트 연구소 정성엽 박사님께서 발표를 해주시겠습니다. 네, 시작해 주시기 바랍니다.
네, 안녕하십니까. 방금 소개를 받은 선박해양 플랜트 연구소의 정성엽입니다. 일단 발표에 앞서서 이런 자리를 마련해 주신 극지연구소 강성호 소장님께 감사의 말씀을 드리고요. 그리고 또 이런 발표 기회를 주셨던 한국북극연구컨소시엄의 서영교 사무총장님께도 감사의 말씀을 드리겠습니다. 일단 오늘 제가 말씀드릴 내용들은 여러분도 아마 다들 잘 알고 계실 것 같습니다. 4차 산업혁명 관련해서 가장 큰 키워드 중에 하나가 디지털 트윈이 되겠고요. 이런 디지털 트윈 기술들이 실제 극지 선박에 어떻게 적용될 수 있는지, 그리고 미래는 어떻게 전개가 될지 말씀을 좀 드리도록 하겠습니다. 일단 발표는 다음과 같은 순으로 진행을 좀 하도록 하겠습니다. 일단 디지털 트윈이라는 얘기를 좀 드리기 전에 아마 산업혁명 얘기를 먼저 좀 드려야 될 것 같습니다. 여러분들 다들 잘 알고 계시겠지만 산업혁명은 1차부터 4차까지 진행을 해오고 있는데요. 일단 1차 산업혁명은 1700년대 중반부터 발생을 했던 사건이 되겠습니다. 가장 큰 키워드는 증기기관의 등장이 되겠고요. 이런 증기기관의 등장으로 인해서 노동력이 대체되는 효과를 가져오게 되었고, 이로 인해서 생산성이 크게 향상되는 효과를 갖고 오게 되겠습니다. 그리고 그 이후에 1800년대 중반부터 2차 산업혁명이 도래를 하게 되었는데요. 2차 산업혁명의 가장 큰 키워드는 전기 에너지의 등장이 되겠습니다. 이런 전기 에너지 등장으로 해서 상품의 대중화를 가져오는 계기가 마련이 되었고요. 20세기 중반부터 3차 산업혁명의 시대로 접어들게 되겠습니다. 3차 산업혁명 같은 경우에는 주로 이제 컴퓨터나 여러분들 아시다시피 인터넷의 발전으로 인해서 사람들은 정보화 시대를 살아가게 되었고요. 이제 저희는 이제 현재 4차 산업혁명 시대를 살아가고 있게 되겠습니다. 일단 4차 산업혁명 시대는 산업구조 전반에 큰 변화를 발생을 시키고 있습니다. 특히 이제 기술들 간의 지능화나 융합화를 통해서 현재 사회는 초연결화 영역으로 진입을 하고 있게 되겠는데요. 특히 그 중에서도 디지털 트윈이라는 새로운 패러다임이 등장을 하게 되었습니다. 이런 디지털 트윈이라는 것들은 실제 가상의 공간과 실제 현실을 융합하는 기술이 되겠고요. 잠깐 그림에서 보시는 것처럼 실제 환경이 아닌 가상의 공간에 디지털화가 되어 있는 모델을 구축한 다음에 실제 환경에서 모사할 수 없는 환경들을 모의나 모사 과정을 통해서 현상을 예측하고 분석하는 데 활용되는 기술이라고 보시면 될 것 같습니다. 일단 디지털 트윈 기술들 같은 경우에는 4차 산업혁명 핵심 기술과도 각각 연계를 통해서 기술 발전이 급격하게 이루어지고 있습니다. 여러분들 다들 잘 아시는 바와 같이 4차 산업혁명의 핵심 기술은 크게 4가지로 구분을 할 수가 있게 되겠는데요. 일단 첫 번째, 물리 대상이 어떤 연결한 상태를 통해서 정보를 서로 주고받고 공유할 수 있는 사물 인터넷 기술들이 큰 축이 되겠습니다. 그 다음으로 실제 센서를 통해서 정보를 획득한 다음에 이 정보를 좀 더 유의미하게 해석하기 위한 어떤 정보 플랫폼 형태가 빅데이터가 되겠고요. 이런 빅데이터 정보를 바탕으로 해서 새로운 사회 문제를 해결하기 위한 기술들이 어떤 알고리즘화돼서 인공지능이라는 기술들이 새롭게 도입하게 되었습니다. 또한 이제 실제 현상과 어떤 그 가상의 현상들을 같이 혼합시켜서 증강현실 기술을 통해서 이런 디지털 기술들이 활발하게 전개가 되고 있게 되겠고요. 이와 함께 여러분들 아마 잘 아실 수 있을 것 같은데, 실제 예전에는 중앙 집중형 저장 시스템을 갖고 있는 반면에 현재는 이제 분산형 저장 집중 기술인 블록체인 기술을 활용을 하게 되면서 실제 데이터를 활용하는 과정에서 보안성은 높이게 되겠고, 데이터를 효과적으로 관리할 수 있는 기능도 향상을 시키게 되었습니다. 또한 예전에는 IT 서버 시스템을 본인이 구축을 하고 활용을 하게 되었는데요. 최근에 이제 웹 베이스 기반을 통해서 이런 클라우드 시스템을 활용을 하게 되면은 실제 이런 사용자가 서버나 스토리지가 없더라도 인터넷상에서 이런 기술들을 활용할 수 있게 되는데, 아까 말씀드렸던 총 6가지 기술과 디지털 트윈 기술들이 각각 혼합이 되어서 새로운 플랫폼과 기술들을 개발하고 있게 되겠습니다. 그렇다면 이제 실제 디지털 트윈 기술들이 산업계에 어떻게 좀 활용이 되는지 말씀을 드리도록 하겠습니다. 일단 디지털 트윈 기술 같은 경우는 종래에서는 주로 이제 제조업에 많이 활용이 되고 있는데요. 지금 최근에서는 이제 현실 문제를 좀 해결하기 위해서 산업계 다양한 분야에서 활용이 되고 있습니다. 일단 뭐 도시나 교통, 물류, 에너지 분야의 전 영역에서 사용이 되고 있는데요. 이런 새로운 사회 문제를 해결하기 위해서 디지털 트윈 기술들이 새롭게 적용이 되고 있습니다. 각각의 사례를 좀 더 말씀을 드리게 되면은 실제 이제 도시 분야 같은 경우에서는 도시 계획과 관련된 사항들, 어떤 건물을 배치하는 과정에서 일조권이나 조망권을 어떻게 영향을 미칠지 판단을 할 때 디지털 트윈, 즉 스마트 시티 모델이 지금 활용이 되고 있게 되겠고요. 일단 또 교통 분야에서는 실제 교통 흐름 분석을 통해서 어떤 교통량을 제어하고 분석을 하거나 실제 사고가 발생하는 경우를 대비하기 위해서 디지털 트윈 기술들이 활용이 되고 있습니다. 또한 물류 분야에서는 실제 물류 과 관련된 상이나 상하역과 관련된 장비들의 모니터링 기술들, 그리고 물류 전체 흐름에 대한 상태 모니터링을 통해서 실제 궁극적으로는 생산성을 향상시키는데 디지털 트윈 기술들이 활용이 되겠고요. 끝으로 이제 에너지 분야에서는 주로 이제 각각의 기능을 갖고 있는 발전소 개념들을 디지털 트윈화 시키면서 가상의 발전소 구축을 통해서 하나의 통합된 모듈로 관리하는 데도 활용이 되고 있습니다. 그렇다면 이제 디지털 트윈 기술들이 조선이나 해운 산업에 어떻게 영향을 좀 미치고 있는지 말씀을 드리도록 하겠습니다. 일단 잠깐 보시는 사진들이 실제 선박들이 운행되는 과정에서 배출되는 배출 가스를 보여드리고 있는데요. 실제 선박들이 운행되는 과정에서 탄소 배출이 발생을 하게 되겠고, 이러한 탄소 배출은 지구의 온난화를 가속화시키는 영향을 미치기 때문에 최근에 이런 선박기인 오염 배출을 감소시키기 위한 기술 규제가 적용이 되고 있습니다. 잠깐 보시는 바와 같이 국제해사기구 IMO에서는 실제 선박의 탄소를 감축시킬 수 있는 가이드라인을 제공을 하고 있게 되겠는데요. 2030년도까지 40% 감축 목표를, 그리고 2050년도까지는 50% 감축 목표를 제안을 하고 있습니다. 그만큼 실제 조선이나 해운 산업에서는 탈탄소화가 새로운 사회적 이슈로 작용을 하고 있게 되겠고, 이런 이슈를 대응하기 위한 기술들이 새롭게 개발되고 있는데요. 이러한 과정에서 조선해역 분야에서는 디지털 트윈 기술이 활용이 되고 있습니다. 잠깐 보시는 바와 같이 실제 선박이 운행되는 과정에서 발생할 수 있는 여러 장비에 대한 모니터링 체계를 통해서 선박의 어떤 상태 감지뿐만 아니라 예지 보존에 관련된 기술들이 적용이 될 수 있게 되겠고요. 이런 예지 보존을 통해서 선박의 전생애 주기 관리를 통해서 선박의 유지 보수 비용을 좀 향상시키는 데 활용이 되고 있습니다. 또한 최근에 이제 육상 원격 제어 기술뿐만 아니라 자율운항 기술을 이용을 해서 어떤 선박의 운항을 지원할 수 있는 운항 최적화에 관련된 기술들, 그리고 어떤 항해사나 파일럿들의 의사결정을 지원할 수 있는 시스템으로도 연결이 되고 있고, 궁극적으로 나아가서는 이제 스마트 항만 기술과도 연결을 통해서 물류 효율성을 향상시키는 데 크게 기여를 하는데 디지털 트윈 기술이 적용이 되고 있습니다. 일단 국외 사례를 좀 살펴보게 되면은 주로 이제 북유럽 국가 위주로 해서 디지털 트윈 기술들이 적용이 되고 있는데요. 잠깐 예를 좀 들게 되면은 DMV나 콩스버그 마리타임, 노르웨이에 있는 NTNU 대학, 그다음 신테프 오션 같은 경우에는 공동으로 오픈 소스 기반의 시뮬레이션 디지털 트윈 모델을 개발을 하였습니다. 일단 선박의 설계나 건조, 운영 전 과정에 걸쳐서 디지털 트윈 기술들이 활용이 되겠고요. 이런 과정을 통해서 실제 선박들이 운행되는 과정에서 운항 효율성을 향상시키고 실제 유지수 비용들을 좀 더 절감시키는데 크게 기여를 하고 있게 되겠고, 궁극적으로 나아가서는 실제 선박의 안전 운항을 기여하는 데도 크게 활용이 되겠습니다. 그렇다면 이제 국내 경우를 좀 살펴볼 수 있게 되겠는데요. 국내 같은 경우는 가장 강점인 정보통신 기술을 바탕으로 해서 실제 IoT 기술뿐만 아니라 빅데이터, AI 기술들을 활용을 해서 선박들의 디지털 트윈 기술들이 적용이 되고 있습니다. 일단 국내 조선사 같은 경우에서는 주로 선박의 상태 모니터링이 가능한 상태 모니터링 시스템을 개발을 하고 있고, 이런 기술들을 실제 선박에 탑재를 해서 선박의 유지보수 향상과 선박의 운용에 활용을 하고 있게 되겠고요. 오른쪽에 보시는 사진과 같이 실제 선박이 운행되는 과정에서 증가현실과의 기술 융합을 통해서 선박들이 운행되는 과정에서 위험한 구간들을 미리 식별해서 회피할 수 있도록 하는 항해 지원에도 활용이 되고 있다고 보시면 될 것 같습니다. 그리고 이제 해운업계를 좀 살펴보게 되면은 실제 해운업계에서는 디지털 트윈 기술들이 좀 더 일찍 적용이 되고 있습니다. 밑에 보시는 바와 같이 네덜란드 노테르담 항이나 싱가포르 항에서 디지털 포트 개념이 좀 도입이 되고 있는데요. 물류 전 과정에 적용이 돼서 실제 어떤 암벽 스케줄링에 관련된 사항들, 실제 선박들의 벙커링 프로시저, 그다음에 선박의 접안이나 이항에 관련된 모든 계획들을 수립하는데 디지털 트윈 기술들이 활용이 되겠고, 이런 스마트 포트 개념이 새롭게 도입되면서 어떤 그 해운업계에서도 효율성을 향상시키는데 크게 디지털 트윈 기술들이 적용이 되고 있겠습니다. 그렇다면 실제 디지털 트윈 기술들이 극지운항 선박에 어떻게 좀 적용되는지 한번 말씀을 좀 드리고자 합니다. 일단 북극은 새로운 환경 변화가 급격하게 발생을 하고 있습니다. 아마 여러분들 많이 알고 계실 것 같은데 실제 북극 지역의 지구 온난화로 인해서 해빙 면적이 급격하게 줄어들게 되겠고, 밑에 잠깐 보시는 것처럼 2021년도 여름철 북극 해빙 면적은 거의 상당 부분이 줄어든 것들을 알 수 있게 되겠습니다. 매년 통계에 따르면 한반도 면적이 한 6배에서 7배 정도의 얼음 면적이 지금 유실되고 있는 것으로 보고가 되고 있는데요. 이처럼 이제 북극 지역에 상당히 많은 얼음이 녹게 되면서 예전에는 이제 얼음으로 덮여 있었기 때문에 어떤 접근성이 어려웠던 북극의 천연 자원 개발이 활발하게 진행이 되고 있습니다. 특히 이제 북극 쪽에는 천연 가스나 석유가 상당량이 매장되어 있는데요. 이런 것들을 적극 개발하기 위한 연구 프로젝트가 진행이 되고 있게 되겠고, 특히 러시아 같은 경우에서는 이제 북극해 연안을 가지고 있기 때문에 러시아 연안에 부존되어 있는 선연가스를 개발하기 위한 연구 프로젝트가 국가 단위로 진행이 되고 있습니다. 잠깐 밑에 사진을 좀 보시게 되면은 2016년도에서는 실제 북극권 지역에서 LNG 선박들의 통항이 거의 없는 것을 알 수가 있게 되는데, 야말 프로젝트 이후에 2019년도의 현상을 좀 보시게 되면은 상당히 많은 선박들이 북극해 지역을 운항하고 있는 것을 알 수 있게 되겠고, 이러한 환경 변화로 인해서 디지털 트윈 기술들이 극지운항 선박에 좀 적용이 되고 있는 사례가 되겠습니다. 그리고 또 아시는 바와 같이 올 3월 달에 선박에 좌초 사고가 하나 있었습니다. 주로 이제 남방 항로를 일컫게 되는데 수에즈 운하를 통과하는 항로가 되겠고요. 이런 수에즈 운하를 통과하는 항로에서 초대형 컨테이너 선박들이 좌초가 되면서 양방의 통행을 막는 사고가 발생을 하였습니다. 이는 실제 남방 항로를 통과하는 선박의 어떤 물류 체계를 마비시키는 사건이 발생을 하게 됐는데요. 이런 사건을 계기로 실제 많은 선주들이나 화주들이 요구했던 것들 중에 하나가 새로운 대체 항로의 필요성을 언급을 하게 되었습니다. 이러한 관점에서 러시아 같은 경우에는 이제 북극 항로를 새로운 대체 항로로서 적극 강조를 하고 있게 되겠고요. 여러분들 아시는 바와 같이 실제 북극 항로는 거리가 줄어들기 때문에 통상적으로 선박의 운항 시간이 줄어들게 되겠고, 운항 시간이 줄어들게 되면 실제 선박에서 배출되는 탄소 가스가 감축이 되기 때문에 이러한 여러 관점에서 북극 항로가 새로운 이슈로 작용할 수 있고 새로운 대체 항로로서 충분히 역할을 가능할 수 있다고 이제 러시아는 특별히 강조를 하고 있게 되겠습니다. 하지만 이제 북극은 얼음이 존재하기 때문에 이런 얼음이 있는 환경에서 선박들이 운행되기 위한 안전에 관련된 기술들이 좀 더 요구가 되고 있겠습니다. 이런 기술들을 해결하기 위해서 상당히 많은 기술들이 개발되고 있는데 아까 말씀드렸던 디지털 트윈 기술들이 이런 기술과 목적을 이루어서 새롭게 개발이 되고 있는데, 일단 이런 사회환경을 바탕으로 해서 제가 두 가지 분야에서 디지털 기술들이 어떻게 적용이 될 수 있을지 도출을 해봤습니다. 일단 첫 번째 기술은 이제 안전 운항에 관련된 기술이 되겠고요. 잠깐 보시는 것처럼 선박들이 운행되는 과정에서 다양한 얼음과의 충돌을 고려를 할 수 있게 되겠습니다. 실제 얼음과 충돌하는 과정에서 선박에 구조적인 손상이 발생을 하게 되면은 실제 사고 현상을 초래할 수 있기 때문에 이런 것들을 사전에 방지하기 위해서 디지털 트윈 기술을 적극 활용하게 되면은 어떤 극한 환경이나 실제 현상에서는 마주하기 어려운 환경들을 미리 시뮬레이션을 통해서 예측을 할 수 있는 기술에 활용이 되겠고요. 또한 또 최근에 많이 활용이 되고 있는 증강현실 기술을 활용을 하게 되면은 북극은 이제 해빙 지도라는 정보를 제공을 하고 있게 되는데 얼음의 두께나 얼음에 모여 있는 밀접도를 제공하게 되는데, 이런 정보를 이제 증강현실 기술과 융합을 통하게 된다면 선박들이 운행되는 과정에서 앞에 있는 지역의 얼음 컨디션들을 미리 파악하는 데 활용이 되겠고요. 이런 과정을 통해서 선박의 안전 운항을 지원하는 데 크게 역할이 되겠습니다. 또 궁극적으로 나아가서는 이런 정보를 바탕으로 해서 선박의 최적 항로를 선정을 통해서 선박의 운항 효율성을 좀 더 향상시키는 데도 크게 활용이 되겠습니다. 두 번째 분야는 이제 시뮬레이터 분야를 좀 고려를 해볼 수 있습니다. 일단 시뮬레이터 분야 같은 경우에서는 종래 많이 사용되고 있는 기술들이 선박의 성능을 예측하는 데 활용이 되고 있습니다. 잠깐 보시는 것처럼 실제 선박의 성능을 예측하는 기술들은 기존의 어떤 경험적인 방법을 이용을 하거나 수치 모델을 이용해서 선박의 성능을 예측하게 되어 있는데요. 만약에 선박의 성능에 영향을 미치는 변수들이 좀 더 비성형성을 가지게 되는 경우에서는 이런 종래 방법들을 활용하는데 크게 기술적 한계에 부딪히게 되겠습니다. 그래서 최근에 이제 이슈가 되고 있는 인공지능이나 딥러닝 기술을 이용을 해서 인공신경망이나 심층 신경망 모델을 활용을 하게 되면은 실제 선박의 성능을 예측하는 데 크게 확장이 가능하게 되겠고요. 잠깐 보시는 바와 같이 실제 디지털 모델 구축을 통해서 선박의 다양한 운항 환경에 대한 미리 모사를 통하게 된다면은 최근에 많이 적용이 되고 있는 환경 규제나 기술 규제에도 아마 선제적 대응을 하는데 크게 기여가 가능할 것 같습니다. 그리고 궁극적으로 이제 시뮬레이터가 갖고 있는 가장 고유의 기능이 되겠는데요. 시뮬레이터가 갖고 있는 어떤 시뮬레이션, 실제 모의나 모사 과정을 통해서 어떤 항해사나 선장을 배출하는 데도 크게 기여할 수 있기 때문에 인력 양성에서도 아마 크게 기여를 할 수 있을 것으로 판단됩니다. 일단 제가 준비한 내용이 마지막 슬라이드가 되겠고요. 일단 이런 디지털 트윈 기술들이 극지운항 선박에 적용되면서 저희가 미래 전망을 어떻게 좀 해볼지 크게 세 가지로 구분을 하였습니다. 일단 말씀드린 바와 같이 북극 쪽은 상당히 많은 천연 자원들이 부존이 되어 있습니다. 석유나 천연가스가 매장되어 있기 때문에 어떤 자원의 경제적 안보 측면에서 북극의 진출이 좀 필요하게 되겠고, 실제 이제 북극은 새로운 시장으로서 큰 가능성을 갖고 있기 때문에 선제적인 시장 선점이 좀 필요하게 되겠습니다. 그리고 이제 우리나라 같은 경우에는 주로 이제 그 업저버 국가에 해당함에도 불구하고 실제 선박을 건조하는 기술력은 세계 최고 수준을 갖고 있게 되겠고, 이와 함께 해운 업계에서 상당히 큰 영향력을 제시를 하고 있습니다. 그렇기 때문에 어떤 조선이나 해운산업의 지속 가능한 발전을 위해서도 아마 디지털 트윈 기술들이 좀 적용이 되고 나면은 이런 기술들을 선도하는 데 크게 기여할 수 있을 것으로 판단을 하고 있고, 그리고 좀 더 나아가서는 이제 거버넌스 구축에서도 지금까지는 약간 좀 소극적인 입장을 좀 취해 왔다면 아마 좀 더 앞선 미래에서는 저희가 이제 어떤 거버넌스 체계 구축에서도 아마 좀 강한 입지를 기여하는 데 크게 도움이 될 수 있을 것으로 판단됩니다. 그리고 이제 마지막으로 이제 우리나라의 선제적인 대응 전략을 좀 도출을 할 수 있게 되겠는데요. 가장 중요한 것들은 이제 국내 기업들의 북극 진출을 위한 활성화 전략, 그다음에 활성화를 할 수 있는 역량을 좀 더 강화시키는 것이 필요하게 되겠습니다. 그리고 또 이제 북극 지역은 여러 가지 불확실성을 좀 가지고 있습니다. 어떤 얼음이 존재하기 때문에 민간 주도의 사업 참여를 통해서는 이런 불확실성을 극복하는데 큰 어려움이 있기 때문에 주로 이제 정부 주도의 어떤 사업 프로젝트 추진뿐만 아니라 정부 지원 개발을 통해서 이런 역량을 좀 강화시킬 수 있는 기반이 좀 마련돼야 되겠습니다. 이와 함께 이제 실제 이제 북극 지역은 상당히 많은 환경 규제나 기술 규제가 새롭게 적용되고 있기 때문에 이런 규제에 대해서 선제적으로 대응할 수 있는 기술들이 요구되게 되겠고, 끝으로 이제 나아가서는 이제 저희가 갖고 있는 조선 기술, 그다음에 해운 기술들, 그리고 이제 디지털 기술과의 융합화를 통하게 된다면 아마 민간 협력 체제를 통해서 저희가 기술을 선제적으로 개발하게 되겠고, 그 기술에 대한 저희가 국산화를 수행하게 된다면은 아마 저희 주요 경쟁국인 뭐 유럽이나 일본, 중국 등과의 어떤 기술 경쟁에서 경쟁 우위를 선점하는 데 크게 기여할 수 있을 것으로 판단됩니다. 제가 또 준비했던 자료들의 참고 문헌들이 되겠고요. 일단 긴 시간 경청해 주셔서 감사합니다. 고맙습니다.
네, 감사드립니다. 디지털 트윈 기술의 미래 북극 항로 운항 선박 적용 가능성과 전망에 대해서 말씀해 주셨습니다. 이제 마지막 주제 발표가 되겠습니다. 지구온난화에 따른 극지수산자원 변화와 우리나라의 대책이란 주제로 국립수산과학원의 오현주 연구관님께서 발표해 주시겠습니다. 시작해 주시기 바랍니다.
네, 반갑습니다. 먼저 이 자리에 할 수 있도록 기회를 주신 분께 감사드리고요. 앞서서 복과 관련된 내용을 말씀해 주셨는데 저는 지구온난화에 따라서 어떻게 해양 생태계 변화 그 속에서의 수산자원 변동과 우리가 어떻게 대책을 해야 되는지에 대해서 말씀드리도록 하겠습니다. 북극은 다 알려지다시피 그 환경 변화에 중요한 역할을 하게 되고 또 지화 자원이라든지 많은 게 묻혀 있고 특히나 해빙이 됨으로 인해서 우리에게 새로운 가치로 다가오고 있습니다. 그런데 일반적으로 우리가 이용하는 데 대해서 앞서서 말씀하셨다면 저는 그 속에서 살고 있는 인간을 포함한 생물이 어떻게 살고 있는가에 대해서 말씀드릴 건데요. 북극이라 하면 우리 북극 사람과 함께 북극군과 함께 같이 유기적으로 이렇게 생태계를 구성하고 있습니다. 다음 그림을 보시면 이게 많이 보셨을 거잖아요. 먹을 게 없어서 통통해야 되는 곰이 이렇게 말라가 있는데 최근에 이거보다 더 큰 연구 결과가 보고되었죠. 이거 혹시 보셨는지 모르겠지만 북극곰이 물범을 먹지 않고 사슴을 이제 잡아먹는 게 이제 보고되었습니다. 이만큼 어떤 지구 온난화라는 게 우리 인간의 측면에 봤을 때는 새로운 항로를 개발하는 측면에서 긍정적인 게 있지만 북극곰의 입장에 봤을 때는 이렇게 생존하고도 관계되는 거라고 보여집니다. 그런데 실제 우리가 북극에 어떻게 해빙이 분포하는지 보면은 감소되고 있는 상황을 볼 수가 있고요. 특히나 전반적으로 우리가 볼 수 있는 것처럼 이제 얼음이 이제 녹아지는 것처럼 지구 온난화라는 게 우리한테 이제 급속도로 다가오고 있고 특히 그린랜드의 빙하의 감소를 보시면은 96년도, 98년도, 2007년대 엄청나게 많은 해빙이 이루어지고 있습니다. 이런 해빙을 봤을 때 인간 입장에서 봤을 때 해빙이 되니까 좋겠다고 하겠지만 실질적으로 그 속에서 일어나는 해양 생태계 측면에서 보게 되면은 해빙이 됨으로 인해서 담수가 유입되면 이렇게 변화가 많이 일어나고 있고요. 특히나 이와 더불어서 그 상위 단계에 있는 그 소비자가 감소가 일어나고 있습니다. 근데 특히나 이러한 게 눈에는 보이지 않지만 우리 바닷속에서는 어떤 변화가 일어나냐면 실질적으로는 생산량은 증가되고 있습니다. 담수의 유입됨으로 인해서 어떤 그 화학적 변화와 물리적 변화에서 생산량이 증가되고 있습니다만은 우리가 보지 못했던 특히 바닷속에서의 그 육지의 식물과 같은 역할을 하는 식물 플랑크톤의 종 조성을 보시면은 크기가 작은 아이들이 증가를 하게 되고 또 그 기여도가 조금 감소하고 있지만 전체적으로 그 식물 플랑크톤이라든지 동물 플랑크톤의 생태에서 봤을 때는 저차 기본이 되는 식물 플랑크톤의 종 조성이 변하고 있는 것을 알 수 있습니다. 이와 더불어서 해빙이 되다 보니까 조류도 자체도 이제 서식처가 생기면서 이제 점점 확대가 되겠죠. 근데 특히나 이 동물 플랑크톤이 같은 경우에는 우리가 어류들이 먹는 주요한 먹이 생물로서 아주 중요한데, 지금까지는 북극이 워낙 얼어져 있다 보니까 어떤 생태계 측면에 있어서 먹이 생물이 어떤 역할을 하는지에 대해서는 사실은 연구가 되어 있지 않습니다. 물론 그 북극과 인접한 해역에 대해서는 되어 있지만 해빙이 됨으로 인해서 북극 쪽으로 이제 플랑크톤도 위로 올라가게 되는 거죠. 그와 맞물려서 척지해 같은 경우에는 저수생물성도 변하고 있습니다. 이러한 해빙이 우리가 단순하게 얼음이 녹아서 항로가 개척되겠구나 하는 측면을 떠나서 해양 생태계가 어떻게 변화를 일으키냐면, 앞서 제가 보여드렸던 먹이만 구물에 있어서 과연 인간이 나중에 받을 수 있는 게 긍정적일까 부정적일까에 대한 고민이 필요할 것 같습니다. 제가 그러면 살펴봤거든요. 해빙이 그러면 수산학적 측면에서 어떤 게 유리할까 보니까 해빙으로 인해 가지고 그 북극 밑에 아북극이라고 하는데 거기에 살고 있는 어류들이 이제 북상할 가능성이 크다고 연구가 되어 있습니다. 보시면 높은 그와 보통 낮은 궤를 그룹핑이 되어 있는데, 결국은 이 해빙이 지속되다 보면은 대서양 불불락이라든지 이제 상업종이 많이 서식처가 확대될 것으로 보입니다. 특히 대서양 붉은 볼락을 보시면은 왼쪽 보면 옅은 색이 실제 분포 지역인데, 만약에 향후에 해빙으로 인한다면은 이렇게 확대가 될 것이라는 이제 연구 결과가 나와 있습니다. 남극을 보겠습니다. 지금 저희가 극지라 하면 북극과 남극을 보고 있는데, 북극 같은 경우에는 이제 새롭게 우리한테 새로운 기회를 제공한다는 측면에서 이제 저희가 어떻게 생태계를 보존하면서 지속적으로 이용할까에 대해서 법도 만들어지고 또 새로운 그 세빙선을 만들어서 우리가 해야 된다는 게 있지만, 남극 같은 경우에는 현재의 어떤 생태계적인 보존 측면에서 이제 많은 역할을 하고 있습니다. 보시면은 남극은 먹이망이 북극과 달리, 북극은 이제 인간하고 관계되는 것이 있으면 남극은 크릴이 중심이 되어서 새롭게 다른 생물의 먹이 생물도 되지만, 또 우리 인간의 입장에서 보면은 또 몸에 좋은 또 기능성 물질이 있기 때문에 또 그걸 가지고 하는 또 수산 자원적인 측면이 있습니다. 근데 이 크릴이 중심이 되어서 남극의 이제 수산 자원이 유지가 되고 있는데요. 주로 여러 가지 보시면은 뭐 펭귄이라든지 뭐 다양한 생물들이 살고 있고, 특히 우리가 일식집에 가면은 이제 그 비싼 고기가 이제 메로라고 알려져 있는 남극 이빨고기라든지 이런 주요 상업 쪽이 이제 어획되고 있는 것이 남극입니다. 그런데 최근에 이제 남극 해빙이 이제 변화가 이제 급속도로 이제 이루어지고 있고요. 거기에 맞춰가지고 이제 환경적으로도 대기 온도도 상승하게 되면서 남극에 대한 것도 빙하가 녹음으로 인해서 부가적인 해양 생태계가 영향을 끼치고 있는 게 사실입니다. 이러한 영향은 앞서서 설명드렸다시피 기온이 올라감으로 해서 우리가 일반적으로 동물 플랑크톤의 먹이가 되는 식물 플랑크톤의 사이즈가 작게 되다 보니까 결국은 에너지 효율이 떨어지겠죠. 예를 들면 저같이 이제 뚱뚱한 사람은 이제 더위에 약해서 힘을 못 쓰지만 에너지가 많습니다. 그런데 저보다 반쪽인 사람은 더위를 잘 견디지만 에너지 효율이 낮는 거죠. 그러면 동물 플랑크톤 입장에서는 어느 아이를 취하느냐에 따라 가지고 에너지 효율도 달라지고 상위의 어류라든지 다른 상위 주요 상업종을 갔을 때에도 어장의 그 어획량이라든지 생산량에도 많은 영향을 끼칠 것 같습니다. 그런데 실질적으로 보셨을 때도 지구 온난화에 따라서 이제 그 생태계가 변동을 하게 돼 있고, 또 크릴이 그러면 온도에 어떠한 성장을 보일까 했을 때 온도가 높으면 높아질수록 크릴의 성장률도 이제 감소하고 있는 거죠. 그러면 결국은 크릴을 주식으로 하고 있는 뭐 고래라든지 다른 주요 수산종이 결국은 감소를 이룰 수 있기 때문에 수산 자원학적인 측면에서 봤다면 이제 위기가 오게 된 겁니다. 실제로 보시면은 크릴과 그 살프라는 것은 이제 플랑크톤 일종인데 개체수가 변동을 하게 되고 있습니다. 전반적으로 이제 순남극 해역이 어떻게 생태계 변동하냐면, 여러 가지 요인을 했을 때 좌측 그림은 실질적으로 관측했을 때도 보면 서남극 쪽에서 이제 영향을 많이 받아가지고 변동이 일어나는 거고요. 오른쪽 그림 같은 경우에는 예측을 해봤습니다. 다른 요인을 넣었을 때 어디가 많은 영향을 받는가 했을 때 역시나 서남극 해역에서 생태계가 변동한다는 것을 알 수 있었습니다. 자, 이거는 저희 이제 그 남극 조사를 하기 위해서 이제 배에서 찍은 모습이거든요. 그러면 결국은 우리 인간이 어떻게 생태계를 보존하고 또 이용할 수 있으며 지속적으로 함께 갈 수 있는가에 대한 고민이 필요할 것 같습니다. 실제 우리나라에서는 3척 정도는 남극에서 이제 운영을 하고 있지만 크릴이라든지 이빨고기를 의획을 하고 있습니다. 이게 크릴이거든요. 그냥 봤을 때는 이제 새우같이 보이는데 이 아이를 먹는 해양 생물이 있을 것이고 또 여기에서 기능성 물질을 추출해서 또 인간이 먹기도 합니다. 그럼 이 크릴이 차지하는 것은 우리가 지금은 퍼센테이지가 얼마 되지 않지만 결국 궁극적으로는 우리 남극의 생태계에 있어서는 이 크릴이 아주 중요한 위치를 차지할 것 같습니다. 남극 크릴의 주요 어장은 보시다시피 북쪽에 있고요. 어획량은 지속적으로 증가를 하고 있지만 크게 증가하지는 않고 있습니다. 남극 이빨고기입니다. 이빨고기 하면은 남극 이빨고기와 파라고니아 이빨고기가 있는데 약간 차이는 있습니다만 옛날에는 파라고니아 이빨고기를 그렇게 치지는 않았다고 합니다. 그렇지만 수요가 많아짐으로 해서 파타고니아 이빨고기에 차지하는 게 위치가 많이 성장을 하고 있습니다. 이러한 남극 이빨고기에서 어장도 보시면은 크릴과 달리 하부 쪽에 되어 있고요. 어획량은 전체적인 변동이 없지만 우리가 고민해야 될 게 있습니다. 그림이 하나 빠진 것 같아요. 네. 자, 북극 같은 경우에는 이미 이제 기본적으로 이제 정책이라든지 다 정리되어 있더라고요. 그런데 제가 자료를 찾아보니까 남극에 대해서는 이 그림이 상징적인 것 같습니다. 이 그림이 혹시 무엇인지 기억나신지 모르겠는데요. 이 그림은 2016년도에 해양생물자원보존위원회에서 로스해를 해양보존구역으로 지정하자는 승인을 하기 위해서 다 사인을 한 거거든요. 그렇다면 북극에 대해서는 우리가 어떤 개발적인 측면에서 우리가 진행을 해야 됐지만 남극 같은 경우에는 보존적인 성향이 강한데 이걸 어떻게 우리가 지속적으로 활용할 것인가에 대한 고민이 필요할 것 같습니다. 그게 맞춰가지고 저희가 이제 찾아보니까 앞에 이제 설명을 해주셨는데 극지활도진흥 법안을 통해서 우리나라 멀리 떨어져 있지만 북극과 남극에 있어서 우리가 어떻게 같이 협력을 해 나갈 수 있는가에 대한 이제 기반을 마련되어 있었고 이걸 토대로 해서 저희가 이제 나가야 할 방향이 있을 것 같습니다. 제가 고민을 해봤거든요. 크게 4가지 측면인 것 같습니다. 우리가 특히 북극 같은 경우에는 연안국에서 그 영유권이 강화되고 임으로 해서 우리는 그렇게 강력한 주장을 권리를 요구할 수 없는 입장이 있습니다만은 우리의 과학적 지식을 가지고 결국은 북극의 생태계를 보호하고 남극의 생태계를 보존하는 데 우리가 어떤 역할을 할 것인지에 대한 어떤 과학적인 지식을 제공하면서 어떤 협력적인 나아가기가 필요할 것 같고요. 두 번째는 인프라입니다. 지금 앞서서도 이제 디지털 튜닝이라든지 방법을 해서 어떻게 선박이 안전하고 또 할 수 있는 연구를 할 수 있는가에 대한 어떤 요소 기술을 개발한다고 하지만 결국은 멀리 떨어져 있는 북극과 남극에 대해서 우리가 어떻게 잘 할 수 있는 그런 인프라를 구축하고 또한 이런 연구를 할 수 있게 대한 다양한 기관과 역할을 어떻게 할 수 있는가에 대한 게 필요할 것 같고요. 세 번째입니다. 극지 생태계는 보시다시피 지구온난화로 인해서 저차 해양 먹이망에 대해서 상당하게 변동이 일어나고 있습니다. 그걸 연구를 하기 위해서는 실질적으로 단순하게 수온이 높고 식물플랑크톤이 많다 적다가 표현이 아니고 그 안에서 일어나는 하부 먹이 단계에서 어떠한 변동이 일어나서 상위 단계인 크릴이라든지 이빨고기에 영향을 끼친 것에 대한 어떤 그런 대형 프로젝트를 발굴을 해서 실질적으로 보존을 하고 이용하기 위한 게 어느 선인가에 대한 평가가 필요할 것 같습니다. 마지막 전문 인력 양성입니다. 특히 바다라는 것은 연구하기 상당히 어렵습니다. 배를 타고 가야 되는 것도 있지만 그 안에서 이루어져야 될 항목도 엄청나게 많은 걸 알고 있습니다. 그런데 현재는 우리가 우리나라 연근에 대해서도 인력풀이 약하지만 특히 남극 북극에 대해서 하기에는 더 많은 인력이 양성이 필요할 것 같습니다. 그런데 결국은 제가 말씀드리고 싶은 것은 이러한 것을 결국 혼자 할 수 있는 게 아니고 우리 대한민국이 나서서 함께 할 수 있다 하면은 이걸 모든 것을 해결할 수 있을 것 같습니다. 감사합니다.
네, 감사드립니다. 남북국 수산자원의 기후변화에 따른 남북국 수산자원의 영향과 지속가능한 관리, 보존의 중요성에 대해서 말씀해 주셨습니다. 이어 전문가 토론의 시간을 갖도록 하겠습니다. 오늘 토론은 극지기술연구회 차기 회장님이신 김현수 대한조선학회장님께서 맡아주시겠습니다. 그리고 세 분의 토론자를 모셨습니다. 먼저 주제 순서에 따라 한국해양수산개발원의 김민수 실장님, 그리고 대우조선해양중앙연구원의 최중효 박사님, 마지막으로 해양수산개발원의 심성현 박사님께서 각각 맡아주시겠습니다. 그러면 마이크를 김현수 좌장님께 넘겨드리도록 하겠습니다.
제 말씀 잘 들리시나요? 네, 감사합니다. 네, 오늘 세 분의 발표를 들었습니다. 이 코아크가 만들어진 지가 한 8년 정도 되는 걸로 제가 알고 있는데, 저도 처음에 코아크 만들면서 이제 그 산업분과 분과장으로 이런저런 활동을 하면서 파운데이션 안에 기여를 했습니다. 오늘 이 자리에 와서 보니까 또 굉장히 그동안 저변도 많이 넓어지고 좋은 그 발표를 잘 들었습니다. 기본적인 저희가 취지대로 기본적인 세 개의 분과에 대한 컨셉들이 그대로 살아있는 것 같고요. 그래서 오늘 세 분의 발표에 관련해서 정책 관련된 부분들이 기본적으로 발표가 됐고, 그다음에 산업 부분과 수산과학에 대한 부분들이 한 푼씩 아마 발표가 된 것 같습니다. 좋은 발표 잘 들었고요. 저희 이제 토론 시간에는 세 분의 연사를 아까 소개해드린 세 분을 모셨는데요. 그 세 분들이 뭐 지금 기존에 발표됐던 세 개의 어떤 그 발표에 대한 질의를 포함해서 추가적으로 혹시 하고 싶은 말씀이 더 있으시면 그런 것들을 좀 더 해주셔도 될 것 같고요. 시간을 제가 약속받은 시간이 있는데 그거보다 조금 더 시간이 가능하면 플러브나 온라인상에서 지금 듣고 계신 분들한테 한두 가지 질문을 좀 받도록 하고요. 이게 가능하면은 혹시 채팅방 이런 게 가능할지 모르겠는데 질문 이런 걸 좀 남겨주시면 제가 모니터링을 요청을 드려서 일반 참여하는 분들한테도 의견을 한번 듣는 그런 시간을 갖도록 하겠습니다. 네, 먼저 우리 주제 발표해 주신 분은 이제 극지연구소의 우리 최영준 실장님께서 해주셨는데요. 극지 정책을 연구하는 우리나라의 또 대표적인 기관이 KAMI가 있습니다. 그래서 KAMI 우리 국방극지연구실의 김민수 실장님한테 먼저 마이크를 넘겨서 지정 토론과 관련된 제의를 부탁드리도록 하겠습니다. 네, 부탁드리겠습니다.
네, 방금 소개받은 한국해양수산개발원 북방극지연구실을 맡고 있는 김민수입니다. 우선 의미 있는 자리에 토론으로 불러주셔서 대단히 감사드리고요. 제가 짧지만 발제문을 좀 준비를 해왔습니다. 그래서 발제문을 중심으로 해서 좀 말씀을 드리도록 그렇게 하겠습니다. 우선 동법령이 굉장히 오랫동안 수건이었는데 올해 제정이 되었습니다. 그래서 많은 노력을 기울여 주신 해양수산부와 극지연구소에 감사 말씀 우선 드리고요. 특히 오늘 발표해 주신 최영준 실장님을 비롯해서 많은 실무 관계자 분들이 계십니다. 그래서 그분들께 특별히 또 감사 말씀드리겠습니다. 오늘은 실질적으로 법령을 제정하는 데 많은 기여를 해주신 최영준 실장님께서 오늘 발표를 통해 극지활동진흥법에 대해서 쉽게 그리고 핵심적으로 잘 설명을 해 주셨습니다. 제가 이제 전공이 좀 법입니다. 그래서 좀 말씀을 드리면 법은 두 가지 차원에서 보통 발전을 해오고 있습니다. 첫 번째는 현재 일어나는 현상이 법적인 어떤 안정성을 침해를 할 수 있기 때문에 그러니까 법의 부재로 인해서 침해를 해칠 수 있기 때문에 그것을 법적 안정성을 유지하기 위해서 사후에 제정되는 법률이 있습니다. 그래서 흔히 우리가 이름을 붙여서 무슨 법이라고 하는 게 주로 그런 부분이고요. 두 번째는 앞으로 이제 향후에 여러 사회 경제적 발전 단계에서 예상되는 법적 문제에 사전에 대응하기 위해서 법이 제정되기도 합니다. 그래서 법적 용어로 전자는 렉스 라타라고 해서 있는 법이라는 측면이 있고요. 후자는 렉스 베란다라고 해서 있어야 할 법적인 측면이 있습니다. 오늘 최영준 실장님께서 발표해 주신 이 극지활동진흥법은 이러한 측면에서 후자의 개념에 좀 가깝다고 볼 수 있습니다. 법률 제2조에서 극지활동이 극지환경의 보존과 조화 균형을 이루며 극지의 지속 가능한 발전에 부합하도록 미래 지향적인 관점에서 이루어져야 한다고 규정하고 있기 때문입니다. 그래서 극지활동법은 바로 이러한 극지활동의 체계적 극지활동의 지원과 육성을 목적으로 한다고 또 1조에 규정을 하고 있고요. 그래서 후자의 법적 개념에 좀 가깝다고 볼 수 있습니다. 그래서 이러한 관점에서 최영준 실장님께서 발표해 주신 내용에 살을 좀 붙여서 의견도 드리도록 하겠습니다. 우선 그 남북국은 각자 다른 법적인 국제법적인 어떤 체계를 가지고 있습니다. 그런데 저희가 극지활동진흥법을 제정을 할 때 이런 문의들을 해주셨어요. 이미 남극활동 및 환경보호에 관한 법률도 있고 굳이 이걸 통합하는 극지활동진흥법을 제정할 필요가 있는가, 이런 문제를 제기해 주신 분들이 있습니다. 실제로 우리나라가 세계 최초로 남북국 극지통합 법률을 제정을 했다면 그간 다른 국가는 별개의 법률을 계속 유지해 왔다라는 또 반증이 되는 것이거든요. 여기에 대한 개인적인 생각을 말씀드리면 어느 쪽이 더 나을지에 대해서는 정답은 없다고 생각합니다. 이는 극지를 바라보는 정책적 관점, 국가가 가진 역량과 의지, 그리고 잠재력, 국민들의 관심, 지리적 위치 등 많은 요소 등이 고려되어서 정책적으로 결정할 수 있는 그런 부분이라고 생각합니다. 그래서 어떤 옵션, 즉 어떠한 법 체제를 가지더라도 법 제도를 뒷받침하는 어떤 세부적 정책 방안이 마련된다면 마련되고 이를 뒷받침하면 된다라고 저는 생각을 합니다. 예를 들어서 하나의 기본법이 제정되었다면 시행 계획을 통해서 남북국이 가지는 특수성을 고려해서 정책적 방안을 마련해서 보완하면 되고, 남북국을 다루는 별도의 법 제도를 가졌다면 통합적으로 양 제도를 조율할 수 있는 정보의 기능을 갖추면 된다고 생각합니다. 개인적으로는 극지 통합 법률이 남북국을 아틱, 안타틱이라고 이분법으로 보지 않고 폴라라는 하나의 관점에서 양 지역이 가지는 공통성에 무게를 두고 있다는 점에서 더 점수를 주고 싶고요. 이러한 차원에서 우리나라는 이제 극지활동법이라는 통일된 법제도를 마련했습니다. 근데 법적인 효력 차원에서 남극 활동 및 환경 보호에 관한 법률과 이 극지활동진흥 법률이 법률상 동일한 법적 효력을 가집니다. 그래서 서로 동일한 법적 효력을 가지는 두 법률이 향후 법률을 시행하는 정부 부처와 관련 어떤 기관의 세부 계획 수립과 추진을 통해 상호적으로 저는 잘 운영될 수 있다고 생각을 합니다. 다음으로 이제 법률이 제정되었으니까 이제 실질적으로 어떻게 이행할 것인지에 대한 부분이 새로운 과제로 다가옵니다. 이러한 관점에서 지난달 11월 30일 날 제정된 북극 2050 북극활동 전략에서는 극지활동진흥법에서 규정하고 있는 많은 실질적 내용을 담고 있습니다. 북극에서의 경제적인 활동이라든가 극지 통합 정보 시스템이라든가 이런 극지활동진흥법을 추진할 수 있는 실질적인 어떤 정책적인 그런 방향성을 제시를 하고 있는데요. 그런데 이제 실질적 이행 과정에서 이제는 법이 제정되었으니까 좀 더 발생할 수 있는 법 규정이 혹시 모자라는 게 없는지, 그러니까 법의 흠결 문제가 없는지를 좀 살펴봐야 하는 과제가 남습니다. 일례로 하나만 예를 드리겠습니다. 제14조 그 극지활동진흥법과 관련해서 안전관리와 관련한 규정을 두고 있습니다. 말씀을 드리면 극지활동에서의 사고 예방과 그리고 사고 시 신속 대응을 위한 안전관리 체계를 대통령령으로 위임을 하고 있는데요. 근데 대통령령을 보면 이렇게 되어 있습니다. 연구기관의 장, 극지활동시설 관리자로 사고 보고 의무를 해야 하는 주체를 제한을 하고 있습니다. 그런데 극지활동에 대한 정의를 제3조에서 보면 극지환경 및 극지자원의 관리, 보존, 개발, 이용과 관련된 활동으로 정해두고 있습니다. 그러니까 개발과 이용을 하는 주체도 극지활동에 대한 주체가 될 수 있고, 향후에 우리가 극지활동에서의 사고 예방과 관리에서 선박 항행이라든가 관광 활동이라든가 수산 자원을 할 경우 예상되는 어떤 그런 활동에 따른 안전이나 그런 부분들이 또 문제가 될 수 있습니다. 그래서 앞서 말씀드렸듯이 극지활동법이 밀행지향적 관점에서 설립된 법률이라면 이러한 향후 예측되는 부분도 향후 좀 보완을 할 수 있는 부분이 좀 필요하다고 생각합니다. 마지막으로 발표와 관련해 가지고 두 가지 의견을 좀 드리도록 하겠습니다. 우선 발표는 굉장히 어떻게 이 법률이 만들어지고 어떤 효과를 가지고 우리가 어떻게 추진해 나갈 것이라고 하고 있는데, 정책 수립 관점에서 좀 분석적인 부분이 좀 있었으면 어땠을까 하는 생각입니다. 예를 들어서 법률을 보면 시행 주체가 국가와 해양수산부로 나눠져 있고요. 그리고 조항도 뭐뭐를 하여야 된다라고 꼭 하게끔 하는 의무 조항이 되어 있는 조항도 있고 뭐뭐 할 수 있다라고 규정된 조항도 있습니다. 예를 들어서 해양수산부가 정책 추진 주체로 되어 있는 경우 극지활동진흥법은 반드시 수립해야 되는 의무 조항인 반면에 실태조사는 실시할 수 있다라고 규정을 해서 약간 재량 규정으로 되어 있습니다. 또한 국가가 정책 추진 주체가 되어 있는 경우는 전문 인력 양성은 꼭 추진해야 하는 의무 규정으로 되어 있는 반면 교육 홍보는 재량 규정으로 되어 있습니다. 이렇게 법이 규정하는 그런 우선순위를 보면 국가가 뭐뭐 하여야 된다라는 부분이 가장 우선순위가 두어지겠고요. 그다음에 해양수산부 장관이 뭐뭐 할 수 있다라는 부분이 상대적으로 덜 중요한 우선순위로 되겠습니다. 이러한 분석은 향후에 우리가 정책적으로 어떤 부분에 좀 역점을 두고 무게를 둬야 될지에 대한 부분을 좀 잘 보여주고 있는 부분이라 이러한 부분들을 우리가 고려를 해야 조금 정책적으로 좀 방향성이 정해진다라고 생각을 하고요. 그리고 말씀드렸듯이 시행 주체가 국가로 되어 있는 부분들이 많습니다. 즉 이게 뭐냐면 해양수산부나 외교부 중심의 어떤 활동을 해라라고 한 게 아니라 산업부, 과학부, 환경부, 뭐 이러한 범부처 간의 북구 경제활동의 진흥이라든가 전문인력 양성이라든가 이런 부분들을 범부처적으로 하라라고 이제 규정을 하고 있는 것입니다. 그래서 범부처적으로 이걸 이행을 위한 정책 협의회 같은 것들이 반드시 도입이 돼서 이걸 추진할 수 있는 그런 역점을 두고 진행을 해야 된다라는 부분을 하나 말씀을 드리고요. 마지막으로 짤막한 의견을 하나 제시드리고 토론을 마무리하도록 하겠습니다. 발표하신 내용에서 4페이지에서 북극에서 도 규제 등의 법률로 이렇게 표현한 부분이 있는데요. 이렇습니다. 약간 오해의 소지가 있을 것 같아서 말씀을 드리는데 환경에 관련해서는 규제 중심의 법률이 맞습니다. 다만 북극권 연안국이 이지에서는 유엔 해양법 협약에서 규정된 권리와 의무를 바탕으로 해서 이용이나 개발에 대한 법률도 존재하고 있기 때문에 북극에 관한 연안국의 법률이 반드시 규제 중심적인 법률이 아니라 규제와 이용에 관련 법률이 병존하고 있다라고 하는 게 보다 정확한 표현이 아닌가 싶습니다. 이것으로 지정 토론을 마무리하고요. 나중에 또 더 나은 토론을 위해서 의견을 말씀드리도록 하겠습니다. 감사합니다.
네, 아주 구체적인 토론해 주셔서 너무 감사드리고요. 제가 정리해 보니까 북극활동진흥법에 대해서 지금 이것이 미래 사회에 대한 발전을 베이스로 한 아주 좋은 법률이다라는 표현을 해주신 것 같고, 법률 관련돼서는 뭐 구체적인 어떤 이행 방안이나 이런 부분도 세밀한 좀 보완이 좀 필요하다는 말씀을 좀 해주신 거로 판단이 되고요. 발표 관련해서도 뭐 한두 가지 말씀해 주셨는데 질문 사항이 좀 있으신 것 같아서 혹시 최영준 실장님이 혹시 답변이 가능하시면 간단하게 답변을 좀 부탁드리겠습니다.
예, 제가 간단하게 이제 말씀 주신 사항에 대해서 답변 드리고 넘어가도록 하겠습니다. 일단 발표는 이제 극지법의 성과를 좀 강조하는 측면에서 사실 작성이 됐고요. 지적해 주신 4쪽의 이제 북극에 대한 규제 등의 법률은 마찬가지로 해양법 협약에 따라서 항행에 대한 보장이나 이런 부분들이 있는 부분이 있는데 제가 좀 찾은 부분이 좀 뭐 러시아 쪽이나 이런 쪽에 있어서의 자국 쇄빙선 이용이나 이런 부분들을 좀 많이 강조하다 보니까 이렇게 표현됐고 다음부터는 좀 수정해서 사용할 수 있도록 하겠습니다. 역시 좀 법적인 전문가 관점에서 봐주셔서 감사하고요. 그리고 이제 사실 극지활동진흥법에 대해서 이제 좀 저도 이제 비평을 좀 하자면 사실 이제 남북극을 묶는 것이 효율적일 수도 있지만 또 남북극의 각각의 특성이 있기 때문에 다른 국가들도 다른 이제 체계를 유지한다는 점을 짚어주신 거에 대해서는 당연히 맞는 말씀이고 남극과 북극도 사실은 이제 어원 자체도 아틱이고 아틱에 반대되는 ANT를 붙여서 안탄틱이 되듯이 약간 반대에 대한 특성이 인식이 존재하는 것이 사실이고 지금 이제 당장 이제 내년부터 이제 박사님과 같이 극지활동 진흥 기본 계획을 수립을 해야 되는데 어떻게 남북극을 엮어 나가고 어떤 우산 과제를 도출할 것인가에 대해서는 굉장히 좀 고민이 되는 시점입니다. 그리고 사실 이 남북극에 대해서 묶는 부분에 대해서 특히 법률적인 연계 관계는 좀 법조문에 표현이 되어 있지만 시행령이나 이런 부분에서는 법에 대한 어떻게 연계하고 진행기본계획을 어떻게 수립할지에 대한 구체적인 내용이 좀 부재하기 때문에 그 부분을 이제 처음 수립할 때 어떻게 잡아나갈지에 대해서는 저희 연구소에서도 굉장히 큰 부담을 가지고 있는 것이 사실입니다. 그리고 또 하나 고백하자면 아까 잠깐 말씀드렸지만 법이 굉장히 빨리 통과가 됐습니다. 그래서 좀 이제 부족한 점이 있는 것이 사실이고 주어도 국가나 해양수산부로 좀 나눠져 있고 어떤 것은 해야 한다, 어떤 것은 할 수 있다. 그리고 이런 부분에 있어서 사실 좀 문제점이 이미 발생을 하고 있습니다. 저희가 이제 뭐 예산적인 부분이나 이런 부분이 필요한 사항이 있는데 그런 부분은 이미 법을 사실 가지고 가지만 할 수 있다라고 되어 있는 부분에 대해서는 할 수 있다고 되어 있다고 강조하시는 분도 계시고 그래서 그런 점들은 좀 앞으로 좀 법이 개정되거나 할 때 좀 해소해 나가야 되는 사항이 사실입니다. 그리고 저희가 이제 시행령을 만들면 특히 시행령을 만드는 과정에 있어서 법에 대해서 다시 한번 평가를 해보게 됐는데 잘 알고 계시듯이 주어 문제도 있고 또 가장 중요하게 역할을 해야 할 그 극지 정책이나 활동에 대한 조정을 해야 할 정부 또는 민간과 민관에 대한 협의체 내용이 빠져 있고요. 그래서 이런 부분들은 앞으로 계속 개정 소요가 있을 때마다 대응해 나갈 수 있도록 저희가 이제 준비를 해야 되고 저희 연구소에서도 관련돼서 좀 연구를 진행해서 미리 좀 이슈를 짚어볼 수 있도록 하려고 합니다. 다만 이제 해야 한다와 할 수 있다에 대한 차이는 좀 이제 시행령을 이제 제정하는 과정에서도 좀 논란이 있었는데요. 논란까지는 아니지만 또 이제 시행령 제정하는 데 있어서 각종 평가들을 또 시행을 합니다. 그래서 통계, 성별, 뭐 또 규제 영향 평가 이런 것들을 하는데 또 요즘은 정부에서 그 뭐 해야 한다라는 의무를 부과하는 법률을 제정하는 것을 최소화하고 있습니다. 그래서 그런 부분에서 예를 들면 안전관리 지침을 제정해야 한다 이렇게 하면 이것들이 정부에서는 규제로 평가될 수 있다는 법제처적인 관점의 분석도 있었고요. 그런 부분들은 이제 저희가 하나씩 정리해 나가서 대응할 수 있도록 하겠습니다. 오늘 좀 전문가적인 관점에서 사실 제가 제시하지 않은 부분들을 면밀히 짚어주셔서 감사합니다.
네, 질의 토의 너무 감사합니다. 살짝 우리 극지 연구소에 있는 우리 서은상 정책 본부장님께서 찬조를 좀 부탁을 하셔서 제가 긴급하게 짧게 좀 한 말씀 부탁드릴까요? 네.
예, 아까 그 질문해 주신 죄송합니다. 질문해 주신 내용 중에 그 실태조사 관련된 부분은 아마 1900이 아니죠. 2018년대로 기억을 하고 있습니다. 그때 당시에 그 국회에서 서른 의원이 뭐 여러 개 법안에 있어서 어떤 실태조사 조항을 넣어달라는 요청, 그 개정 요청이 있었고, 그때 이제 상당히 여러 개 법률이 기존 법률이 개정이 됐는데요. 그때 개정된 것 중에 하나도 남극연구활동진흥 남극연구활동 및 환경보호에 관한 법률도 그때 같이 개정이 됐었습니다. 그때 동시에 실태조사는 거의 대부분 이제 할 수 있다가 되었고, 특히 다른 건 몰라도 극지 관련된 실태조사는 그 코로나 상황이라든가 아니면 악천후라든가 여러 가지 환경 때문에 이게 해야 한다라고 잘못 넣었다가는 또 그걸 의무를 이행하지 못하는 상황이 생길 수 있기 때문에 할 수 있다로 들어가는 게 맞다고 생각을 합니다.
네. 변론을 하러 나오셨던 것 같아. 제가 코로나 상황에서 그런 것들이 법적인 부분들이 유권 해석이나 이런 것들이 가능한 부분임에도 불구하고 나름대로 이기유가 있다는 생각을 하고요. 2021 북극협력주간에 사실은 정책이라는 큰 세션이 있습니다. 그래서 그쪽에 계신 분들하고 오늘 주제 발표하신 분하고 그 다음에 집중 토론해 주신 분 포함해서 양대 기관들이 좀 더 좋은 모습으로 전격적인 방향을 잘 제시해 주시면 다른 기관들도 거기와 같이 보조를 맞춰서 좀 좋은 발전의 모습이 되지 않을까 이런 생각을 하고 있습니다. 이제 두 번째 이제 산업분과로 넘어가서요. 이제 디지털 트윈에 관련해서 우리 그리스도의 정성혁 박사님이 어지런저런 화두를 많이 던져 주셨고요. 그 지정 토론 관련해서는 우리 이제 대우조선해양의 중앙연구원의 최중호 책임연구원께서 똑같은 방식으로 질의를 하셔야 되고, 아마 최중희 박사님도 올해 아텍 관련된 연구를 하고 하셨기 때문에 뭐 관련해서 지정 토론을 좀 해주시면 감사하겠습니다. 마이크 넘기겠습니다.
예, 안녕하세요. 대우조선해양의 최중현입니다. 잘 들리시나요? 예, 굉장히 좋은 자리 초청해 주셨는데 제가 본의 아니게 지난 주말에 그 자녀가 자가격리 통보를 받아서 이 가족들도 단체 행사 있는 곳에는 참석하지 않는 게 좋겠다고 보건소에서 그래서요. 좀 본의 아니게 참석치를 못했습니다. 저도 오랜만에 북극 연구하시는 분들 많이 뵙고 싶었는데 예, 양해의 말씀 부탁드립니다. 화면으로 제 얼굴이 나니까 더 뚱뚱해 보이는 것 같아서 좀 죄송스러운데요. 정성엽 박사님이 디지털 트윈 기술의 극지선박 적용에 대해서 좋은 말씀 주셨고요. 약간 조금만 더 첨을 드리자면 보통 조선소에서 이제 디지털 트윈 기술을 적용한 선박들을 그냥 통칭해서 이제 스마트십이라는 표현을 쓰고요. 지금 조선 3사, 뭐 저희 회사 포함한 조선 3사에서는 모두 다 스마트십 기술을 개발을 해 놓은 상태고, 현 프로젝트에도 적용을 하고 있습니다. 그래서 스마트십을 뭐 어느 단계까지 했냐 그러면 저희가 뭐 플랫폼화 했다라고 표현을 드리고 있고요. 각 조선소마다 조선소 고유의 스마트십 모델 플랫폼을 들고 그 플랫폼을 지금 배에 설치하고 있는 중이고요. 개발한 지는 10여 년이 조금 넘은 것 같고요. 10여 년 동안 왜 이렇게 조용했냐 라고 들도 하실 수 있는데, 이게 사실은 실제 배에 설치되고 있기 때문에 이 영업 뭐 회사로서는 영업 기밀 중에 하나인 항목이고요. 어떤 것들을 스마트화 했냐, 그러니까 디지털 트윈화 했냐, 이런 것들이 경쟁력이기 때문에 사실은 많은 것들이 알려져 있지는 않습니다. 한 10여 년 전쯤에 이 스마트십을 개발하면서의 목표는 사실은 에너지 세이빙이었거든요. 연료를 아끼겠다. 그러니까 그러니까 배가 바다에서 가는 추진 효율을 1% 내지 뭐 7% 정도 아끼면서 연료는 뭐 10% 가까이 아낄 수 있는 이런 항로를 제공하거나 아니면 이런 운항 지침을 만들어내거나 이런 것들을 자동화해서 이제 배에 이 선장에게 선택할 수 있는 권리를 주겠다, 뭐 이런 식으로 개발이 되다가, 이때는 사실은 이건 하나 할까 말까 선택을 해달라는 옵션이었고요. 몇 년 전부터 이제 대기오염 물질 규제가 시작되면서 뭐 낙스니, 싹스니, CO2니 이런 거에 대한 물질 양에 대한 규제들이 이제 발효가 되기 시작하면서 지금은 이 스마트십 기술이 이제 에너지 세이빙에서 시작해서 대기 오염 물질을 컨트롤할 수 있는 것으로 좀 디벨롭이 조금 더 됐고요. 그러다 보니 이제는 이게 더 이상 옵션이 아니라 이제 필수처럼 거의 모든 선박에 적용이 되게끔 돼 있습니다. 그래서 저희 지금 짓고 있는 선박들도 거의 대부분 다 스마트십 플랫폼을 설치하는 중이고요. 이 기술이 그럼 기존 선박과 뭐가 다르냐를 좀 설명드리자면, 뭐 많이들 보시는 게 자동차니까요. 이제 저 테슬라나 뭐 요즘엔 애플카 이런 것도 뭐 얘기가 있지만, 이제 주로 전기차, 수소차 이렇게 얘기는 하지만 결국에는 뭐 자율운항 자동차다 해갖고 뭐 지금 미국에서도 몇 대 시범으로 돌아다니고 있고 하는 자율운항 자동차가 있잖아요. 그 자동차들을 보면 뭐 가령 전기차를 기준으로 말씀을 드리면 배터리를 지금 얼마나 소비하고 있고 모터를 얼마나 내가 회전을 시키고 있고 하는, 그러니까 사람이 컨트롤할 수 있는 정보들을 갖고 자동차가 좀 더 안전하게 사람의 힘이나 지식을 들이지 않고 운항하게끔 해주는 플랫폼인데요. 이걸 배에다가 접목을 시켜보면 배도 똑같이 지금 전기 추진선은 없지만 엔진을 컨트롤하거나 뭐 러더나 프로펠러 회전수를 컨트롤하거나 하면서 이제 자율운항하게끔 뭐 충돌 회피 시스템도 만들어낼 수 있고 그런 것들을 할 수는 있지만, 자동차와 가장 다른 점은 자동차는 이제 바람이 많이 분다 라고 해서 옆으로 회피하는 거동을 하거나 바람이 많은 곳을 피해서 바람이 적게 부는 곳으로 다닌다, 이런 것들은 잘 안 하잖아요. 효율에 큰 차이도 없고. 배는 하지만 그러니까 밀도가 굉장히 높은 곳을 운항하는 구조물이기 때문에 이 파도가 1m일 때 배의 속도와 똑같은 엔진 마력에서 파도가 5m일 때 엔진 속도와 그 배의 속도와 파도가 10m일 땐 달릴 수가 없고 하는 외력에 의한, 그러니까 사람이 컨트롤할 수 없는 것에 대한 이 설계 포인트가 사실은 배 설계에서의 핵심이거든요. 그래서 사람이 조종할 수 있는 게 아니라 환경적인 요인이 더 크다라는 말씀을 드리고 싶고요. 그 환경적인 요인 때문에 이제 자율운항 선박이다라고 하는 것들의 개발의 이제 핵심 화두가 리스크 회피입니다. 그래서 뭐 충돌을 회피하거나 파도를 회피하거나 뭐 지금 정은 박사님께서 말씀하신 얼음을 회피하거나 하는 식으로 밖에 외력들을 어떻게 컨트롤하게 만들어낼까라는 것이 핵심이고요. 그걸 위해서 이제 외력을 알아야 되기 때문에 뭐 얼음 같은 경우는 이제 해빙 정보를 어떻게 추정이 가능하게끔 만들어내느냐, 아니면 지금 정보를 어떻게 받아올 수 있느냐, 이런 것들이 사실은 기반 기술화 되어야 된다고 생각을 하고 있고요. 또 다른 배나 자동차나 비행기랑 약간 다른 것들은, 배는 실제로 운전하면서 민첩하게 모든 걸 뭘 피하거나 할 수 있는 것들이 아니라 굉장히 많은 예측들을 해내야 무슨 물건을 피할 수 있거든요. 가령 뭐 지금 다니는 한 300m급 되는 LNG들은 이렇게 오는 물건을 회피하기 위해선 최소한 20km 전에서 회피 고동을 시작을 해야 실제로 충돌하지 않고 회피할 수 있거든요. 그런 민첩성이 굉장히 떨어지기 때문에 이 충돌하는 물질에 대한 예측을 해내는 것들이 중요하고요. 그럼 더욱더 이제 외력에 대한 공부들이 더 많이 필요하다는 것이 요즘의 트렌드고요. 그래서 저희 쪽에서 요즘 많이 신경 쓰는 부분들은 이 외력들을 어떻게 잘 추정해낼 수 있을까에 대한 부분들을 많이 신경 쓰고 있습니다. 예, 그 정도 첨언 드리고 싶고요. 정상혁 박사님께서 이제 두 가지 꼭지로 말씀을 주셨는데, 제가 알기로는 이 두 가지 꼭지가 뭐 과제화를 오래 하려다가 잘 진행이 안 된 것으로 알고 있거든요. 이 두 가지 꼭지의 과제들을 뭐 크리소 자체 내부적으로 하고 할 계획이 있으신 건지, 아니면 하고 계시는지, 아니면 또 다른 큰 과제로 만들어서 할 계획이 있으신지, 이 과제 개발 계획에 대해서 좀 알고 싶습니다. 예, 이상입니다.
네, 어려운 상황에서 집에서까지 이렇게 참여해 주셔서 너무 감사드리고요. 정말 디지털에 대한 제대로 사례를 보는 것 같습니다. 정성엽 박사님이 디지털 트윈에 대한 얘기들 많이 해주셨고, 우리 최중희 박사님께서 지금 스마트 10이라는 화두로 조선 3사에서 이미 10년 전부터 플랫폼이 개발이 됐다, 이런 얘기를 해주셨고요. 에너지 세이빙 디바이스부터 시작해서 자율운항 선박까지 지금 나오고 있는 여러 가지 화두를 얘기해 주신 것 같습니다. 기본적으로 지금 우리가 여기서 얘기하고 있는 것 중에 대부분은 그 지구의 온난화 이런 얘기를 하지만 기후 위기라는 표현들을 많이 쓰고 있고요. 그런 걸 극복하기 위한 것들이 지금 친환경 쪽으로 많이 가고 있습니다. 그래서 친환경과 디지털라이제이션이라는 큰 화두에서 사실은 조선이나 다른 여러 가지 회원도 그렇고 과학 하시는 분들도 거기서 벗어나기는 쉽지 않은데, 그런 거에 대한 것들을 좀 짚어주신 것 같습니다. 우리 정세영 박사님한테 질문하신 것 같은데 답변을 좀 부탁드릴까요?
네, 일단 최중현 박사님 온라인으로 뵙게 돼서 상당히 반갑고요. 일단 질문을 하나 주셨는데, 이제 저희가 준비를 했던 내용들이 어떻게 좀 진행이 되고 있는지 아마 그거를 좀 물어보신 것 같습니다. 뭐 아시겠지만 실제 일반 해역을 운항한 선박들 같은 경우에서는 상당히 많은 정부 과제도 진행이 되고 있고, 실제 뭐 기간 고유 사업으로도 개발이 좀 진행이 되고 있습니다. 하지만 이제 극지 해역을 운항하는 경우에서는 좀 상당히 다른 일반 해역과는 다른 환경 조건을 갖고 있기 때문에 기존에 이제 일반 해역에 적용되는 기술들을 그대로 극지 해역에 적용하는 데는 좀 한계가 있다는 것들은 대부분 전문가들은 다 동의하고 계신 것들이 되겠고요. 이런 한계성이 좀 차이가 있기 때문에 이런 것들을 좀 극복할 수 있는 기술들을 이제 좀 신규 과제로 좀 준비를 하고 있는데, 최근에 이제 극지 운항 선박에 관련된 아까 말씀드렸던 안전운항 지원 체계 시스템 개발이나 어떤 시뮬레이터 개발 과제들은 저희가 계속 부처 과제로 좀 발전하기 위해서 지금 저희가 진행을 하고 있는 것들이 되겠고, 또한 최근에 이제 차세대 세빙 연구선 건조 사업이 이제 확정이 됐는데 거기에 한 꼭지로 선박의 상태 모니터링을 할 수 있는 기술 개발들이 또 함께 진행될 계획이 되겠습니다. 잠깐 말씀을 해주신 것처럼 실제 선박들이 운행되는 과정에서 발생하는 환경 하자 등 상당히 많은 요소들이 작용을 하게 되겠는데, 가장 중요한 요소들이 실제 어른과의 충돌에 의해서 발생하는 힘, 즉 빙하중이나 빙유기에 의한 진동이나 소음 특성들이 되겠고요. 이런 것들을 모니터링할 수 있는 기술들은 아직까지 뭐 국내 조선소도 상당히 많은 기술력을 갖고는 있지만 아직 국가 공공의 기술로 확대를 시키기 위해서는 아마 기술 개발이 좀 더 필요할 것으로 생각을 하고 있습니다. 그런 관점에서 차세대 세빙연구선 건조 사업에 앞서서 어떤 선행 기반 기술 과제의 형태로 정부 부처 과제로 좀 진행을 하려고 계획을 잡고 있게 되겠고요. 또한 이제 기관 고유 사업, 크리소 고유 사업의 형태로서 계속 북극해를 운항하는 선박들의 상태를 모니터링할 수 있고 선박에 작용하는 외력을 추정할 수 있는 실선 계측 연구를 수행을 하고 있습니다. 2010년도부터 세빙연구선 아라온에 탑승을 해서 저희가 매년 북극이나 남극해를 운행하는 과정에서 어떤 다양한 환경 조건에서 선박이 작용하는 외력들을 계측을 하게 되겠고요. 이런 정보를 활용을 해서 실제 선박의 구조적인 측면에서는 어떤 충돌 과정에서 발생하는 힘들이 선박의 구조 부재에 영향을 미치지 않는지, 구조 안정성에 영향을 미치지 않는지 평가하기 위한 연구들이 좀 진행이 되고 있고, 최근에 또 산업부 과제로 해서 이런 디지털 트윈 기술을 적용한 선박의 어떤 건전성 모니터링, 전선 모니터링 시스템 기술도 개발이 되고 있기 때문에 아마 국내 여건은 이제 어느 정도 이제 공공 이익의 목적으로 해서 과제는 좀 진행이 되고 있다고 보시면 될 것 같습니다. 하지만 아까 말씀을 드렸던 어떤 항행 운항을 위한 지원 체계 플랫폼 개발이나 어떤 극지형, 즉 빙해역 전용의 시뮬레이터 개발에 관련된 내용들은 아직까지는 이제 국내 기술화가 되지는 않았기 때문에 이런 것들을 이제 국산화 시키기 위한 측면들, 그리고 뭐 아시겠지만 주로 이제 북유럽 국가들 상대로 해서 상당히 많은 기술 선점을 진행을 하고 있게 되어 있는데요. 이런 이제 저희는 이제 극지해역을 신시장으로 좀 보고 있기 때문에 콜드러시, 즉 뭐 패권 경쟁 입장에서 이런 경쟁에 좀 선제적으로 좀 진출을 하고 저희가 경쟁 우위를 선점하기 위해서는 아마 이런 국내 과제 형태를 통해서 아마 기술이 개발되고 나면은 아마 이런 여건들을 좀 마련하는데 아마 크게 도움이 될 수 있을 것 같습니다. 네, 고맙습니다.
네, 뭐 답변이 충분히 된 거라고 판단을 하고요. 오늘 여기 들어와 계신 분들이 산업 쪽에 계신 분들이 이렇게 많지 않기 때문에 제가 좀 한 가지 추가해서 말씀드리면, 자율운항 선박과 관련해서는 산업부하고 해수부에서 공동 부처 사업으로 해서 지금 개발이 진행이 되고 있고요. 정부 예산이 한 1,600억 이상 수여가 돼서 관련 기술들, 그 다음에 법 제도적인 부분들, 이런 부분까지 개발이 되고 있다는 말씀을 정보를 추가해서 드리고 싶습니다. 두 분 격조 있고 품위 있고 높은 수준의 토론 보여주셔서 너무 감사드립니다. 마지막으로 수산 과학 분야에 대한 우리 발표를 우리 오연주 해양수산연구관께서 발표를 해주셨는데, 지정 토론으로 하신 분이 우리 심성현 전문연구원이신데 같은 연구본부에 근무하시는 거로 맞으신가요? 아니요, 죄송합니다. 다른 기관에 계신데. 네, 또 주제 발표에 대해서 뭐 추가적인 의견이나 혹은 질의사항 포함해서 의견 주시길 부탁드리겠습니다.
네, 안녕하세요. 한국해양수산개발원 수산연구본부 심성현이라고 합니다. 우선 북극 연구에 관련한 뜻깊은 자리에 초청해 주셔서 감사합니다. 그리고 주제 발표해 주신 오연주 연구관님의 발표 잘 들었습니다. 우선 지구 온난화에 따라서 빙하가 녹으면서 서식하고 있는 생물에게는 그게 위기가 될 수 있다고 오연주 연구관님께서 말씀해 주셨는데, 저는 수산업적인 부분 그리고 어업적인 부분에서 보면 이러한 해빙은 북극해라는 새로운 어장을 개발할 수 있는 새로운 또 다른 기회라고 생각합니다. 하지만 이 새로운 어장을 개발하기 위해서는 그 해역에 서식하고 있는 수산 자원이라든지 그 수산 자원이 얼마나 상업적으로 가치가 있는지 이러한 것들도 살펴봐야 되기 때문에 단기적으로는 이러한 어장을 개척하는데 힘들다고 볼 수 있다고 생각합니다. 그래서 이러한 어장을 개척하기 위한 관점에서 보면 제가 생각하는 방법으로는 일단 연안국이 포함되어 있기 때문에 이들과의 관계를 좀 협력을 증진시킨다든지 그리고 우리가 수산자원 관련 연구 분야에서 우리가 기여할 수 있는 부분을 강화해서 이러한 것들을 설명하면서 우리가 북극해에서 어장에 진출할 수 있는 방안을 마련했으면 좋겠다고 생각합니다. 그리고 이러한 수산자원에 있어서는 그 지구온난화에 따라서 수산자원이 어떻게 변화하고 있는지에 대한 모니터링도 중요하다고 생각됩니다. 그래서 북극해에서 해빙에 따라서 어느 정도 수산자원의 변화가 있는지 이러한 수산자원 변화에 따라서 그들의 서식이 어떻게 변화하고 있고 먹이 생물이라든지 산란장이라든지 이렇게 어떻게 변화하고 있는지에 대한 연구도 상당히 중요하다고 생각됩니다. 그리고 최근에 2021년 6월에 중앙북극해 공해산 비규제업 방지 협정이 이제 발효된 것으로 알고 있는데 이에 따르면 이제 연안국 5개국과 비연안국 우리나라를 포함한 비연안국 5개국이 참여하여서 이 협정에 따라서 그 북극해에 있는 공해에서도 연구를 시행할 수 있는 것으로 알고 있습니다. 그리고 향후에 이러한 지역에 지역수산기구가 설립된다면 어업 또한 가능하게 한다는 것으로 알고 있습니다. 그래서 이에 대한 대비와 이들 연안국가의 공동연구 프로그램을 잘 마련했으면 좋겠습니다. 그리고 마지막으로 오연주 연구관님께 질문 드리고 싶은 거는 일단 북극해에 대해서 수산자원이 굉장히 중요하다고 볼 수 있는데 우리나라 수산자원에 대한 평가와 관리를 하고 있는 국립수산과학원이 북극해 수산자원 관리와 이런 데 있어서 기여할 수 있는 부분과 그 방안이 무엇인지 대해서 궁금합니다. 이상으로 토론을 마치도록 하겠습니다.
네, 심상현 전문연구위원님 죄송합니다. 제가 KMI에 계신 줄 모르고 갑자기 토론자가 바뀌는 바람에 어장 개발에 필요해서 관련국가 협력 많이 하자는 말씀 해주셨고요. 수산자원 모니터링이라는 얘기가 또 나왔습니다. 그래서 기후 변화에 대해서 어떤 수산자원에 대한 모니터링 할 건 이런 얘기를 해주셔서 것 같고요. 공동연구 프로젝트는 두 분이 주제 발표하신 분과 재정 토론하신 분이 똑같은 얘기 해주신 것 같습니다. 우리 오연주 연구관님께서 질문 드린 내용에서 답변을 좀 부탁드릴까요?
네, 말씀 감사합니다. 토론자님께서 말씀하신 것처럼 북극에 있어서 수산 자원도 아주 중요하고 특히 북극은 현재로 저희가 알기로는 어떤 전반적인 해양 생태계에 대해서 조사가 되어 있지 않습니다. 그렇기 때문에 지금은 남극 같은 경우에는 실질적으로 이제 많은 조사가 이루어지고 특히 주요 상업적인 크릴이라든지 이빨고기에 대해서도 이제 저희가 연구를 하고 있고 또 특히 쿼터를 받아가지고 조업을 하는 그런 상황이 있습니다. 그렇기 때문에 지금까지 우리 국립수산과학원이 이제 다른 파트에서 이제 연구를 하시는데 그쪽에서는 협력을 통해서 유기적으로 조사를 하고 또 쿼터 확보를 위해서 노력을 하고 있거든요. 그걸 토대 노하우를 가지고 북극에도 이제 만약에 한다면은 그런 게 국제적인 협력의 스킨십이 중요하기 때문에 그걸 토대로 해서 북극에서도 우리가 원활하게 어떤 새로운 신어장이 개청되고 할 때 저희들이 열심히 할 수 있을 것 같습니다. 이상입니다.
네. 예정된 시간이 이제 거의 다 끝나가고 있는데 제가 자장 시작하면서 말씀드린 것처럼 시간을 조금 좀 남아 있어서요. 플로우에 계신 분들이나 혹은 온라인에서 어느 분이 좀 모니터링을 하고 계신지 모르겠는데 나왔던 질문들 중에서 있으면 좀 없으신가요? 플로우에서 혹시 보완적인 추가적인 질문이나 토의가 있으시면 빨리 끝내기를 바라시는 것 같습니다. 네, 제가 오늘 사실은 굉장히 의미 있는 자리에 이렇게 분야가 다른 분들이 또 모여서 이렇게 통합이라는 얘기를 하는 거 굉장히 중요하다는 생각을 좀 하고 있고요. 북극활동진흥법에서 13조라고 아까 표현하신 것 같은데 말씀하신 통합정보 시스템 구축하고 운영에 대한 여러 가지 얘기를 하셨어요. 그래서 그게 사실은 여기 계신 모든 분들의 접점이 아닐까 하는 생각을 좀 하고 있습니다. 차세대 세빙연구선이라는 인프라가 우리가 26년에 이제 런칭이 될 거라고 판단이 되고요. 그 기간 동안 저희도 여러 가지 준비를 할 수 있습니다. 산업계에서 지금 얘기하고 있는 기존에 개발된 플랫폼이라든지 선박에 대한 운항 예지 포지, 북극에 대한 뭐 기후나 환경에 대한 통합 시스템, 거기 환경에 대한 어떤 빅데이터, 데이터 이런 것들을 포함해서 그다음에 선박에 대한 부분뿐만 아니라 환경에 대한 부분, 과학에 대한 부분, 수산에 대한 부분조차도 통합 정보 시스템이라는 이 법적인 근거 안에서 저희들이 뭔가 아까 우리 오연주 의원님도 말씀하셨지만 우리가 통합이라는 함께하자는 같이 하자는 이런 부분에서는 정말 좋은 의미의 그런 같이 가야 될 방향을 제시한 것이 아닌가 하는 그런 생각을 하고 있습니다. 네, 뭐 장시간 동안 그 온라인으로 혹은 현장에서 청취신 여러분한테 대단히 감사드리고요. 제가 그 맡은 진영 토론에 관련된 부분은 여기서 마치도록 하겠습니다. 감사합니다.
하셔도 될 것 같습니다. 예. May I have your attention, please? The International Arctic Science Cooperation Seminar will begin in 5 minutes. Please find your way to your seats and be seated. Participants with their name tags or panels on the table, please come forward. And as for other participants, please be seated in the rows behind. Thank you. See you in 5 minutes. and good morning. Warm welcome to the International Arctic Science Cooperation Seminar, jointly organized by Korea Polar Research Institute and Royal Norwegian Embassy in Seoul and Embassy of Denmark in Seoul and the Innovation Center therein. My name is Hyung-Chul Shin, and I'm the Vice President of Korea Polar Research Institute and the ex-officio, the Chief Scientist of the Institute. It is my great pleasure and honor to welcome the Arctic researchers and experts from Korea, Norway, and Denmark, who joined us in person and online to share their research activities and insights with us today under the theme Toward 2050, New Opportunities for Arctic Science Cooperation. Let me remind you, today's seminar will be conducted in accordance with the current COVID-19 measures, and welcoming remarks by dignitaries will also be conveyed in hybrid format. I will have no time wasted and invite Dr. Sung-ho Kang, Corporate President, to the podium for his opening remarks. Dr. Kang, please.
Thank you, Dr. Hyung-Chul Shin. Your Excellency, Ambassador Frode Solberg, Your Excellency, Ambassador Einar, early in the morning from Norway and Denmark. The rapid changes we are witnessing in the Arctic is affecting the livelihood of not only those in the Arctic states, but also those in the non-Arctic states. At the same time, innovation in scientific approaches have provided great potential for better monitoring and understanding the Arctic climate and environment. Again, science cooperation is the key to ensure sustainable and valuable research in the region, which is prerequisite for well-directed common actions to address global climate change and its negative impacts. Korea has recently introduced its 2050 Arctic strategy with contributing to addressing Arctic climate and environmental issues, and our long friend Dr. Jan Gunnar Winder, who is now representing the Norwegian Center for the Ocean and Arctic and NOFIMA. Let me once again express my sincere gratitude to their time kindly shared with us. I look forward to fruitful discussions with you all day. Thank you very much.
To take part in the Arctic Partnership Week. This event is an important platform for cooperation between the Republic of Korea and Norway, and of course, one of the key arenas for discussing sustainable development in the Arctic. I want to start by congratulating the Korea Maritime Institute on yet another important event. And let me also thank our co-hosts, COPRI and the Embassy of Denmark, for hosting this International Arctic Science Cooperation Seminar together with us. Norway's Arctic strategy builds on a strong commitment to international cooperation. And we value the good cooperation both with other Arctic states as well as observer states in the Arctic Council. Cooperation is key to mitigate the impact of climate change and to ensure that the region can benefit future generations. The Arctic is rich both in natural and human resources. 1/3 of Norway's landmass and 10% of our population live north of the Arctic Circle. It is home to many of Norway's most advanced research communities and centers of excellence, with focus on maritime areas, fisheries, natural resource management, and environmental science. And you will hear from some of these central actors later on today. The Arctic is a region where the effects of climate change are both visible and acute, and happen faster than elsewhere. Climate change endangers a range of species who are dependent on ice and snow for their survival. We must change, climate change must be fought. And we must place the Arctic at the heart of the green transition. And through cooperation with states with an interest in the Arctic, we can make this happen. Adhering to our commitments made in the Paris Agreement is vital for the future of the region. For Norway, it's important that global discussions on the Arctic are fact-based and based on the best available knowledge. Therefore, research is at the heart of the Norwegian Arctic policy. Close cooperation and interaction with the scientific community is key for reaching our overarching goals for the region. The Arctic is probably one of the most developed fields within research collaboration between South Korea and Norway. The Dasan Research Station in Svalbard and the Corporate Office at the Norwegian Polar Institute in Tromsø benefit both our countries. In addition, several MOUs have been signed between Norwegian institutions and Korean counterparts on research cooperation, including between the Fridtjof Nansen Institute and KMI, COPRI and the Norwegian Polar Institute, the Nansen Environmental and Remote Sensing Center, and the Bjerknes Center for Climate Research. Researchers from Norway and Korea work together in joint expeditions, participate in global research projects such as the Synoptic Arctic Survey, which collect empirical data from the Arctic Ocean through cruises, and conduct research on marine litter governance in the Arctic. And of course, Norway is a proud and consistent supporter of the Arctic Partnership Week. The daily dialogue between education and research institutions is part of what makes Arctic cooperation between our two countries a success story. Dear friends, to this end, I would like to highlight the great Arctic explorer and scientist Fridtjof Nansen, who traveled to the Arctic to seek deeper knowledge. He once said that the history of the human race is a continual struggle from darkness into light. And let this quote be our inspiration today, during today's seminar, in which researchers will share knowledge and experiences to find common solutions, to find light. The knowledge that Nansen produced continues to influence science and research today. And I'm confident that the investments we make in strengthening cooperation on research and education between our countries in the Arctic is worthwhile. And I hope this will produce equally lasting impacts. Thank you very much for your time. I wish you a most successful Arctic Science Cooperation seminar today. Kamsahamnida.
Distinguished guests, researchers and co-hosts, my name is Ejner Jensen and I'm the Danish ambassador to Korea. Let me start by extending my warmest welcome to all of you participating in today's seminar titled International Arctic Science Cooperation. I also would like to share my sincere appreciation for our co-host, Korea Polar Research Institute, and our Norwegian College. Denmark joined the Arctic Partnership Week 3 years ago. It has proven to be a very good platform to share the latest Arctic knowledge with researchers from Korea, Denmark, Norway, as well as other countries. It's impressive to experience how the dedicated knowledge among these finest researchers on this issue. As you know, the Kingdom of Denmark is centrally located in the Arctic. There are 3 parts of the kingdom: Denmark, Greenland and the Faroe Islands. The Arctic makes up an essential part of common cultural heritage and is home to a part of the kingdom's population. The Arctic has to be managed internationally on the principles of law, ensure a peaceful, secure and collaborative Arctic region. The Kingdom of Denmark is an important actor in the international cooperation that is virtual for the future of the Arctic. Until now, the Kingdom of Denmark has been focused on 4 main agendas. First, a peaceful and secure Arctic. Second, sustainable growth and development. Third, respect for the Arctic fragile climate and environment and nature. And lastly, close cooperation with our international partners, where these are on the main agenda. Denmark aims to cooperate with our global partners in the adherence to the UN Maritime Law Convention. Together we believe we can strengthen maritime security, sovereignty, and surveillance. We can increase knowledge-based growth and development, and not least regarding the renewable energy sector. And we can get a better understanding of the impact of climate change on the Arctic regions, which will help us better protect its fragile environment and biodiversity. In the future, the Arctic will only be even more central to us. The Danish Minister for Foreign Affairs has placed the Arctic as one of 3 central priorities for the coming 4 years. The government of Denmark, the Faroe Island, and the Greenland are also working on the new joint strategy for the vision for the Arctic for 2021 to 2030. On a bilateral level, I'm happy to announce that today the Embassy is not only hosting this seminar, we are also witnessing the MOU signing between the Ministry of Ocean and Fisheries of the Republic of Korea and the Ministry of Higher Education and Science of Denmark on polar science and technology cooperation. With this MOU, our 2 countries are committed to strengthen our collaboration on Arctic and polar science in the years to come. The COVID-19 pandemic has slowed down and reduced scientific activities in the Arctic. Unfortunately, the speed of climate change and its efforts have not. This summer was the warmest month in the recorded history of Greenland. For the first time ever, rain, not snow, was seen on Greenland's highest point. This is triggering cascading impacts on the biodiversity and to our living security. But not all is lost. We can still stop the climate crisis. It is technically within our means. It can be done in an economic, efficient way, and it will benefit the wider environmental agenda and humanity as a whole. There is only one requirement: bold action now, and all of you gathered here, the scientists are one of the most important actors who can take this bold action. I hope that today will act as a stepping stone in that direction. Thank you very much for giving me the opportunity to open this important conference. I wish you all a successful session that will hopefully lead to further collaboration between our countries. Thank you very much. 감사합니다.
Thank you for those encouraging words from the 3 dignitaries. So let us get down to the business and have the session started. Our first speaker will talk about Korea's endeavors and perspectives in Arctic Ocean research with focus on the international joint research efforts in the Arctic waters. Dr. Eunjin Yang, the first speaker, is leading the Ocean Science Division of COPRI. She has coordinated, conducted research in the Arctic Ocean for many, many years now, and she has numerous first-hand or get-your-hands-wet experience in international joint research. I'm pleased to invite Dr. Yang to the floor. Please.
안녕하세요. 극지연구.
Good afternoon. I am Eunjin Yang from COPRI. I would like to present to you how we use our own to conduct research in the Arctic, including through international joint research.
우리가 북극
So the reason why we must focus on the Arctic is because the changes in Arctic and dynamics in the Arctic may be correlated to the life of the humans as a whole. As you know, the Arctic is, with the accelerating global warming, temperature in the Arctic is rising faster than any other region, and with accelerated warming, sea ice in the Arctic is disappearing. In 2020 summer, the size of the sea ice in the Arctic recorded the smallest ever in history. With the declining sea ice extent and global warming, they threaten the human life, but on the other hand, also open up opportunities of resource development and sea routes. As you can see on the left, sea ice is reducing and opening up the sea route, and on the right-hand side, you can see that with declining sea ice in the Arctic, fishable areas are expanding. In this area, protecting fisheries and sustainable use of fishery resources, 10 countries have come together to sign the CAUFA in June 2021. So to protect fish stocks in this region, based on scientific research, joint efforts have started. Then, in such rapidly changing Arctic, what has Korea been doing? On the left-hand side, you can see that the Arctic Ocean has the Pacific Gateway and the Atlantic waters, and also the CAO. So the Pacific and Atlantic Arctic are undergoing dramatic climate changes. So to track these changes and monitor the changes, research is absolutely important. And if you see on the right, the recently Pacific Arctic, in the Pacific side of the Arctic, warm water continues to flow in, and from Russia and Canada, freshwater discharge has been growing up, which affects sea ice. And this is also linked to the sea routes. So in this area of the Arctic, with declining sea ice, the impact on the ecology, NSR, and also changes in the Arctic environment, their relation to the mid-altitude region climate, how to identify the link and track and analyze the impact are the aims of our mid to long-term monitoring research. Korea's Arctic Ocean expedition has mostly been done through Araon from June to September in the Beaufort Sea, Bering Sea, Chukchi, and East Siberian Seas. If you look at the right-hand side, since 2010, Korea has been conducting these research activities. The yellow box indicates the region where only Korea is conducting a mid to long-term monitoring research. Arctic Ocean research, with the ongoing climate change, looks at the sea ice decline, temperature rise, and freshwater inflow increase, and how it impacts the ice-ocean interaction and water mass circulation. So due to these changes, we also want to look at the changes in the ecosystem of the Arctic. So ultimately, we want to gain a future outlook of Arctic Ocean environment and ecosystem, particularly in terms of fishery resources. For this research, starting this year, we started the K-AWARE, or Korea Arctic Warning, Ocean Warning, and Responses of Ecosystem, which will be ongoing for the next 6 years. The K-AWARE project looks at the Pacific side of the Arctic for mid to long-term observation and monitoring by setting up an observation system. And based on the ocean ice interaction, we also look at the impact or changes in the biosphere. As you can see on the right, the Korea Arctic Ocean Data System is built to gather data, and the data will be fed into a system model to ultimately produce a future outlook of the Arctic. So the data compiled so far, as you can see, are entered into the KAO system and visualized. Anyone interested in the Arctic research, as long as they have an email address, can access this database and use the data available. Next, international collaboration in the Arctic. Korea looks into the Pacific side of the Arctic Ocean. As you can see on the right, there are 6 countries interested in the same area, and Korea together formed the Pacific Arctic Group with these countries. And as an endorsed activity, we have the DBO and PASEO activities ongoing under PAG to look at the ecosystem changes in the Arctic and climate change in the Arctic. And as you can see on the left, we have the Eagle Light project and ONR-led marginal ice zone projects, where we look at the sea ice in the Arctic under international projects. And in the back, we have Synoptic Arctic Survey, which will be presented later by another presenter. And we are part of this survey as well. And in the East Siberian Sea, we look at the water mass through NABOS. And ARCS-2 by Japan is being pursued, and we are part of the JAMSAC project. And recently, the EU launched the Arctic Passion project, where Korea is also a part of, to look into how we can together pursue joint research in the Arctic. Since 2014, we have used Araon in the Arctic for international collaborative projects, mostly looking at sea ice monitoring, their impact on the ecosystem, both offshore and subsea. Despite COVID-19, this year we conducted these Arctic expeditions. The yellow boxes indicate the Synoptic Arctic Survey. The red box indicates the NABOS project, and the blue one indicates Mirai by JAMSTAC. As of now, through virtual meetings, we are discussing ways to share data. And Araon has conducted very active research in the Arctic. However, the limited ice-breaking capability and the ship time of Araon. So in the Arctic Ocean, in order to resolve common tasks, we had to overcome so many challenges, and to better address these common challenges in the Arctic, we decided to build the next generation IBRV. This vessel for the next 6 years will be built, and by 2027 will start services. This will be about 15,000 tons in weight, and ice-breaking capability of up to 1.5 meters thick at 3 knots of vessel speed will be on the ship, and more than 150 days of research expedition will be possible. Using moon pools or AUV and other high-tech equipment, the vessel will be conducting research, and also a dual fuel system, LNG and low sulfur fuel, will be used in an eco-friendly manner. So starting in 2027 at the CAO, we will be able to use this vessel you can see in the slide. And this vessel will be built, and also in the sidelines, we also recently adopted the 2050 Korea Arctic Strategy, which will look at areas such as response to climate change, protecting the ecosystem in the Arctic, and many other common tasks in the Arctic. And also with Arctic states, we will be expanding the diplomatic horizon of Korea. And the next generation IBRV will also be looking at the climate, fishery resources, pollution, ecosystem technology, transpolar sea route, and blue economy. Based on scientific research, international collaboration will be expanded. And in conducting observation in the Arctic, multilateral participation will be highlighted, and data obtained thusly will be made available for any Korean scientist through an Arctic data dam that will be used to share data. So based on the 2050 Korea Arctic Activity Strategy and through IBRV, Korea will contribute to resolving the common tasks in the Arctic as a leading nation. Thank you very much.
Oops, she disappeared. I thought I was maybe having one burning question for Dr. Yang, if there is one from the floor. Okay, let's turn to the next speaker. Now, we will proceed with Norwegian perspective in the international Arctic Ocean research. I would first like to give the floor to Dr. Øyvind Pasche. Dr. Pasche is with Bjørknes Center for Climate Research and Norse Climate. He is presently the head of innovation at Climate Futures and working as a senior scientist, having over 20 years of national and international experience in earth science research with climate and glacier variability, environmental magnetism, floods and paleohydrology. His talk today is entitled Model for International Cooperation in the Arctic Ocean. Dr. Pasche, please.
Thank you. Thank you very much. Happy to be here. I want to start this presentation by paying tribute to a man that you see in the picture over here on your left-hand side, Hans Allmann. He was an eminent scientist devoted to studying glaciers in the Arctic and to understand how they interact with climate and how they impact the landscape. Quite a figure in polar research in the last century. But Allmann was a diplomat who understood perfectly well that we need to work together across borders and strive for common goals if we are to understand how the Arctic clockwork ticks. Finding new ways to better understand how the Arctic Ocean interacts with climate is high on the agenda for many countries and organizations. The reasons and motivation for this increasing engagement are many and varied, and surely you know why. I'm not going to do the full list here, but rather say that the scope and the range of the changes we're observing today imply that we also need to find new ways, like Allmann, to work together as a community if we are to obtain a better understanding of the Arctic Ocean, but also provide policy and decision makers with scientific information that can aid them in reaching sound decisions. And this is precisely what Synoptic Arctic Survey is all about. And I'm truly grateful to the organizers and friends in Korea for this wonderful opportunity to present the growing initiative. A brief introduction seems to be in order. Or to put it more bluntly, what is it? SAS is a bottom-up, research-driven initiative, and it's trying to coordinate and collect data from the Arctic Ocean within the scope of 2 years. And not all of the research vessels that we use are icebreaker. This means that, it is the researchers themselves who saw the need for coming together, working together, and trying to find ways to address some of the challenges they have seen within their disciplines. The goal is to generate a comprehensive data set that allow for an improved characterization of the Arctic Ocean. And this occurs within all of the 3 different compartments of the ocean, the physical oceanography, the marine. And the reason for this is I do think that we more and more realize that we need to see the totality of change, not just within different disciplines, but everyone together. And thirdly, this will and have already now provided a unique data set, which will allow us to track climate change and its impact as they unfold in the Arctic over the coming years, decades, and centuries. And I do think that this data set, this quite unique data set, will also be a source for collaboration for students working on those data sets and traveling back and forth between countries. Someone from Korea coming to Norway, someone from Norway going to Korea, and so forth, and trying to really understand some of these new data sets. So let's just start off then with this international initiative. I think there are many names that could be on this list. You see the flags of the different countries here and all of the different organizations that support this initiative. It's quite a huge initiative, and it has grown since 2014, when myself and Aro Olsen was in Japan attending Arctic conference, and we realized that we needed to start working on something that could bring people together in the Arctic. And we talked to people, and we had the first international Synoptic Arctic workshop in Washington, D.C. At the Norwegian Embassy in 2015. And from there on, there's been a number of meetings. And in 2018, we launched the Science and Implementation Plan, which can be downloaded from our webpage. We established a scientific steering committee. And now, since 2020 and until today, these are the years of the Synoptic Arctic Survey. So one of the overarching questions is how this system is transforming. And as we talked earlier, we've separated it into these three main compartments. And at the heart of these compartments are training, education, outreach. And within each of these three compartments, we have designated research questions. I'm not going to read all of you, but perhaps just want to give you a flavor. So research question 3, for instance, for physical oceanography is what are the changes in water masses, in water mass sources, sinks and transformations. And then if we move on into the marine ecosystems, we can ask questions like how does carbon flow vary across regional ecosystems of the Arctic? And what you notice now is that we both see the green and the blue color. So some of these questions, like number 6, overlaps with at least 2 of the disciplines. And then finally, carbon cycle and acidification. We have questions like what are the input and fate of terrestrial and subsea carbon to the Arctic Ocean? So by trying to bring all of these different cruises together, and everyone will try to answer these 9 sort of research questions in different ways, and hopefully also together in some sense. So when we started, we drew this idealized map of where we wanted the cruise legs to go, what we wanted to cover, and obviously we wanted to cover the gateways, the places where water flux through in and out of the Arctic Ocean. We wanted to cover shelf areas, deep basins, and so forth. And this was, of course, an idealized version. And this is how it looked, you know, pre-pandemic planned SAS cruises. You see the different countries here in different colors and the different research vessels. And it looks a little bit more messy than in the idealized version. But still, many important participants involved in this initiative. And so I just want to quickly show you, you know, the different cruises that has been conducted now by the different countries. This is, of course, some cruise you know, and which was presented in the last cruise. This is Aron going into primarily the Churchill Sea, but also partly the Beaufort Sea. This is Japan with the research vessel Mirai. Going also into the Churchill Sea. It was done in 2020. It will repeat it this year. And this is the Canadian heavy icebreaker Louis S. St. Laurent, which went in 2020. Again, this will repeat it. It's in the Beaufort Sea, and it's a part of the Beaufort Gyre exploration project. Here you see the Swedish icebreaker Oden, which had a wonderful cruise this year, running from August to September. And they covered what sometimes is referred to as the Canadian Hull, because we have so little data from this area, which was a tremendous successful cruise. And we're really anticipating the data set, what the data set will bring of new knowledge from that cruise. There's also the Danish contribution with the research vessel Dana, which is not an icebreaker, but carry out important science as well. This was done in August and September 2021. Greenland is also involved in that, and so is Canada and US. The Italians contributed with a track along the 75 North in August, September this year with Laura Bassi, which is their new icebreaker, formerly a Norwegian ship known as the Polar Queen. And then we have the Crown Prince Haakon, which is an icebreaker, and it made a track this year, this summer, as you can see over here, and spearheaded by the Fram Center and the Polar Institute. And there was also a second cruise in August, September, which was part of the Nansen Legacy, which you see in red on your left-hand side, on your right-hand side. And then we have the research vessel Vilnius, which covered ground just west of Nova Zemlya, and also Norwegian research vessels GeoSARS, Johan Hjort and Helen Hansen, with many cruises in the fall of 2021 covering the sort of other half of the Barents Sea. Then there's an interesting cruise with the icebreaker Academic Gryosnikov, which was carried out in August, September 2021, part of the large initiative known as Arctic Century, covering part of the Kara Sea and also running into the Barents Sea on the west side of Nova Zemlya. And then we have the icebreaker Healy and the US Synoptic Arctic Cruise contribution going into the core of the Arctic. It's not decided, as far as I know, whether this will be this year or next year. No, next year or 2023, which depends a little bit on whether they're going to use Healy or whether they're going to rent the Swedish icebreaker Odin. And so, you know, if we compare where we started with the vision or the idealized diagram of the sections and the right-hand drawings, looks like a child has drawn some of these lines, but that's the way it goes. You can see that we managed quite successfully to cover a lot of ground in the Arctic. And so, what are the next steps for the Synoptic Arctic Survey? I think we need to develop a synthesis, making all of the data available. Some of the data sets are already available, like, for instance, the ones from the Swedish cruise, I believe, is already available. So all the data needs to be available. We need to start to make syntheses. PhD students will have to start working on some of these data sets. And what we've come to realize during the time that we have worked with SAS is that more and more we realize that this first Synoptic Arctic Survey, in some sense, almost can be viewed as a pilot, and that we're now starting to work together in order for plans to come about for a Synoptic Arctic Survey 2, which we have set for 2030. So 9 years into the future. And we will need the help from all of our collaborators, also Korea, to manage to do something even more successful in 2030 than we've managed so far. And if you're interested in the Synoptic Arctic Survey, I urge you to go to our webpage. You see the address at the bottom line here. There's some new information, reports can be downloaded and so forth. And I also want to take this opportunity to thank our Korean collaborators. Kupri has been a tremendous force within SAS, and during the pandemic, when many of the Western countries were very reluctant and very unsure whether they would manage to do cruises in the Arctic, Korea paved way and showed that it could be done. So we're very happy to have you on board. And a little bit more on the personal side, I also, since you are in Busan, the way I understood it at least, the Björkman Center has a strong collaboration with the Center for Climate Physics in Busan, and personally I have a close friend there in Axel Timmermann, which is in the center here between me and Kerim Hesnes, which is a professor at the University of Bergen as well. And we have some projects running, and I have also had the pleasure of being in Busan, and I hope that we can arrange for a workshop in the near future, where we can continue this dialogue that we have started today and see how we can progress in working together on Arctic science. So thank you very much for your attention.
Oyvind will not go away. He will stay put. Okay, so because we have a little bit of time, if there is a question from the floor to Oyvind, perhaps he can entertain one or two. Any question from the floor? Okay, maybe we can pose questions later in the session altogether. But the idea of having all those ships you can get into the Arctic Ocean within a reasonably short time and have produced a comprehensive data set sounds very exciting. And being able to repeat it every 10 years is even more intriguing. I'm sure that Korea will be in much better position in 2030. But now I need to say sea ice is a very important element. Now, our next speaker is Anton Korosov, a senior researcher at the Nansen Environmental and Remote Sensing Center, located in Bergen, Norway. Actually, Oyvind is from Bergen too. So, Dr. Korosov has received a PhD in oceanography, and his current research interests include ocean remote sensing, a simulation of satellite observation into sea ice models, and the development of satellite data management system. Dr. Korosov, the floor is yours. Please.
Good morning, everyone. I'm pleased to be on this workshop. Thank you very much for inviting. I will present a slightly different view on the Arctic from above, from satellites, and also with models that we developed jointly with colleagues from COPRI. So our goal is to build an end-to-end sea ice monitoring and forecasting system. And end-to-end means that we start from very low-level signal processing that we receive from satellites, and then we develop higher-level algorithms for deriving geophysical products such as sea ice type, drift, and deformation. And this covers the remote sensing part, which is essential. This is monitoring. And then we continue with modeling. And here we develop assimilation techniques so that we can initialize the model from satellite observations and finally perform forecasting into the future and provide mariners, icebreakers, cargo vessels with accurate forecasts of sea ice concentration, thickness, extent, and drift. So in a way, we wish to help the Arctic Service to achieve good results by providing them accurate forecasts. How it is done? There are a few challenges, and I will go a little bit from low level to high level. First, there are these so-called SAR, synthetic aperture radar sensors installed on European and Korean satellites, for example, Sentinel-1 or COMPSAT-5. And they are very nice because they can see through clouds and can operate both day and night and the winter and summer and provide very high resolution. But when we're looking at the European satellite, we observe problems that it has strong thermal noise contamination, as you can see on the image on the left. So we jointly with Jung-Won Park, a researcher from Korean Polar Research Institute, developed a noise removal algorithm, which works very well and provides so nice images on the right. Then we take these images as input and develop geophysical algorithms. Here we use so-called machine learning algorithms based on convolutional neural networks in order to derive stage of development of sea ice, or in other words, how old is sea ice. On the left, you can see pictures from SAR, and on the right is the manual ice chart, where ice experts classify these images into land, ocean, new ice, first-year ice, and so on. We have developed a convolutional neural network which can do that automatically, and the architecture of this neural network is presented here. So this is just a technical slide. And then we can produce ice charts automatically with this algorithm every day, whereas the manual ice charts are produced only every week or every 3 days. So we can, and of course, manual ice charts have also lower accuracy and lower spatial scale. And our ice charts in the middle on this figure, they are produced with the higher frequency and higher spatial scale. And again, we published papers together with the Korean colleagues that show a high precision of this ice chart and are helpful. How do we then assimilate these ice charts? So we compare that with the sea ice thickness measured by a satellite, and decided to interpret sea ice charts in terms of thickness. So if we plot the thickness for each ice type, then we can plot such simple sine lines, and then we can approximate the sea ice thickness in these areas by sinus. So stage of development is derived from SAR data with convolutional neural networks. Then we fit the A and B coefficients of thickness and compute thickness as a function of the date and of sea ice type. And then we have a model. It is a new type of model. It has Brittle-Bingham-Maxwell rheology, or the physics, how the ice behaves. Unlike typical models, it is running on triangular Lagrangian mesh with relatively medium resolution, I would say, 10 kilometers only. But as you can see on the video, even this resolution is able to resolve very small openings, cracks in the sea ice. And here is an example of forecast of sea ice with assimilation of sea ice thickness and the sea ice concentration. And we forced this model with several European models for ocean and atmosphere, but the model itself is standalone. So then we developed an assimilation procedure that can assimilate this sea ice thickness into the model. And here are some examples. So on the left are observations of concentration. In the middle is the model, and on the right is the difference between them without assimilation. And here is how it improves with assimilation. So there is almost no difference except for small open cracks in the pack ice. And even after 1 day of forecast, the comparison is still very good, meaning that improving the skills by assimilation holds for several days. Here is just another example how we do assimilation, and the plot showing that right after assimilation the errors are very small and they gradually increase with the forecast lead time. And a similar animation for sea ice thickness, which shows that we have some problems in the pack ice where we stop our simulation, but we don't really care about that because this is an operational model and the main impact is to preserve ice edge correctly. Then another point of study that we share is retrieval of sea ice drift from SAR images. Imagine we have 2 images over a short time of the same area, And then we developed algorithms for comparing these images and finding differences with regard to where the ice has moved. And again, we publish together with Korean colleagues. We then can derive this ice drift and convert this ice drift into ice deformation. And this ice deformation is very localized along the cracks in the ice. And as you can see on the animation, these cracks are very dynamic. They appear and disappear and then reappear, which is very important. Because then we developed a new type of simulation technique. So here is again a simulation of Nexim, but now instead of concentration or thickness, it shows deformation features. Exactly what we can observe from SAR ice drift. And you could see that these deformation features are very realistic already, but the exact position is not the same. So what we do is we take observations of deformation from SAR, from satellites, and assimilate into Nexim. And here are just some examples of simulation after simulation and some comparison of the metrics, maximum cross correlation of that. And that helps to put these cracks in the correct place and predict them in future more precisely. So to summarize, I would also like to thank COPRI. We have long-lasting collaboration with this institute, which proved to be very successful, in my opinion. Papers are published in high-ranked journals. We co-author code which is shared on GitHub. And this CIS monitoring component is jointly developed, and it is the basis for the forecasting component. And the derived satellite data products are used in the operational monitoring and forecasting system. And for exchange of scientists, exchange of postdoc students, that would be very nice to continue that. Thank you for your attention.
Thank you, Anton. Thank you, Anton. Any question from the floor? Dr. Songjung Park, can a microphone be handed over to him? Songjung, there, yes.
Thank you, Anton. It's very impressive for you to apply satellite data in your CIS simulation. What is your predictability? You should.
Of course, it is the highest during the first day, and it is gradually decreasing, but there is still skill after 3-5 days.
Are you also applying your skill to CIS thickness?
Yes, in a way. We don't assimilate CIS thickness so far, because the product that is operationally available has very low resolution, and our model has very high resolution CIS thickness fields, so we don't want to blur this information. But assimilating concentration and the CIS thickness from CIS type helps to keep the model, keep the simulated ice edge correct, also in the order of 3 days.
Okay, thank you.
Okay, then I have a question for Oyvind, if he is around. Is he?
I'm here.
Right. So this satellite-based CIS monitoring capability, did we ever try to combine this capability into the design of Synoptic Arctic Survey, and actually it's actually running? So, I mean, when we are about to go out to sea and do some observation, did we take into account this newly coming in information, CIS information? I gather it can make your survey development and use of unmanned autonomous systems. He will present on the future of high latitude monitoring using new technologies, including drones. Michael, please.
Yeah, thank you very much. Good afternoon, everybody in Busan, and good morning to my colleagues in Norway. First of all, let me say that I'm really sad that I'm not able to be there in person at Busan. That was the original plan, but due to various challenges, including COVID-19, that was unfortunately not possible. So we have to do it virtually. What I'm going to do is to give you a rundown of current activities, collaboration between Korea and Denmark, involving both COPRI, but also the Korea Aerospace Research Institute in Daejeon. And before I do that, I would like to just to give you a perspective on who we are, the National Space Institute, and also to maybe highlight some possibilities for collaboration in other fields than the ones that we are talking about here, where we specifically talk about discussing the effects of climate change as observed in the Arctic. I think it's very important, and the reason why space research is important, we've already seen examples of the use of satellite data, that we are addressing a global phenomenon, but we are looking at specific regions of our planet where we see the effects of climate change to a higher degree than in other places. Specifically, the Arctic is, as it's been stated several times this afternoon/morning, and that's why it's very interesting. As mentioned, I am head of the DTU Space Drone Center. And we see drones or unmanned systems as, you could say, a kind of a link between satellites and ground-based activities, be it at sea using icebreakers or other platforms, because the satellites obviously will give you the grand overview, but the satellites, they are in specific orbits, so you cannot just move them around the way you want to. An icebreaker is a quite expensive asset, and it has to be used wisely, obviously. So having this kind of link between what's going on in space and on the ground, at sea or ashore, drones are a very, very efficient and interesting perspective, both on smaller scales but also on larger scales. And that's some of the things that I'm going to show you here today, both, as I mentioned, ongoing activities, but also some proposed activities for future research. In connection with our Sisimiut campus. We are also present at Thule Air Base, the American air base in the northwestern part of Greenland. And as you see at the top, we have a research vessel. It's quite old, but right now we've just recently received funding to build a new research vessel, which will be able to sail in ice. It's not an icebreaker, I must say, but it's an Arctic research vessel, or it has capability to do Arctic research, and hopefully it will be operational in 4 years from now, so in 20 National Space Institute's research areas. We have research in many areas, but obviously here pin number 3 is of great relevance, namely the cryosphere, studying ice sheets, and that's obviously both the ice sheet in Greenland but also the ice sheet in Antarctica. Glaciers and climate are closely connected, but also studying the gravity field of the Earth is something that's very relevant in order to understand the effects of climate change. So these things are closely related. We are an institute that combine research with technology development. As you can see, some of the pins here, that both radar, laser, star trackers for then going full circle back with the results and starting all over again with new research is something that we do in-house. Just a few numbers here, and again, what I would like to highlight here with partners. Organizationally, we are divided into 5 divisions. You can see here. And then we have a number of interdisciplinary centers. The drone center that I'm leading, a center for defense and security. And then right now, I am looking into establishing a center for space safety, and I'll get back to that in a little while. And I will give you some more background on that in a moment. That the drone center is not a research center, but what we do is that we coordinate and facilitate projects. So we find the relevant partners, we connect the relevant researchers in order to conduct research projects. We focus on all domains, so we are, even though we call it a drone center, for us drones is not necessarily just something that flies, but we're also looking at land and sea and subsurface capabilities. So we go in all domains. We have in the recent years developed advanced testing facilities both at our campus and also in other places in Denmark, where we are able to test unmanned systems in all domain, land, air, sea, subsurface, both under controlled conditions, but also in realistic conditions, both urban and rural. And then obviously going also into the Arctic with all the challenges that this poses is something that is of high value for both technology development and research. As it was mentioned initially by our Danish ambassador to Korea, His Excellency Einar Jensen, it is the Kingdom of Denmark consists of Denmark, as you see down here on the lower right, the Faroe Islands just below the middle of this map, and then Greenland. So the Arctic part of the kingdom is obviously Greenland, and it's covering a huge area stretching from the North Atlantic into the Arctic Sea. This is an advantage, but it also poses challenges. As I mentioned before, moving around in Greenland is a big challenge. Everybody who's been involved in Arctic research knows that logistics is a huge challenge and something that really can tie down resources and makes planning of activities very, very challenging. So having partnerships with research institutions which may be versed in working in other places in the world, with institutions like ours who have more than 100 years of experience working in the Arctic, is very beneficial, because all these challenges that you face when you're working with Arctic research needs some sound experience. Let me just briefly introduce you some of the infrastructure that we are maintaining in the Arctic. D2 Space, we build and maintain a network of ground magnetometers. You can see here the red dots